Welcome to the AWS course. Although the title says that this is a course for beginners, during the course itself, we will get to know some more demanding services and learn how to successfully navigate AWS waters. But before we start learning, in the first chapter of this course, I wanted to greet you and wish you welcome. As was the case with Azure Cloud, in this AWS course, we will start from the very beginning. Most of the time, these opening words are boring, so I won't make them too long. Buckle up and let's go. But before we start learning, allow me to introduce myself. My name is Vladimir Živković, and I'm a certified Microsoft trainer and Azure Cloud Solution Architect expert. In addition to these certificates, I have several Azure and AWS certificates. I have spent a good part of my career working in the cloud, with considerable experience in the concept of the Azure cloud itself, and of course AWS. I spent 5 years as a Udemy instructor, and most of my courses were part of the premium offer, like AZ900, AZ104, AZ500, AZ700, AZ305, SQL Database, Cosmos DB, Entra ID Service, then Ubuntu Linux, Docker, Kubernetes, and container services in Azure. Of course, there was dedicated courses to AWS. If you remember, there was a course almost 100 hours long about AWS and its services, and this course, the name of this course was working title From Zero to Hero. Of course, all my courses were on English and my native language on Serbian, but unfortunately many of you have witnesses that Udemy is not what it used to be. So like many instructors, or most of them, I have decided to leave them and withdraw all my courses, mainly due to disagreements with their policy towards user and instructors. But all this will not prevent me from delivering the best possible course on AWS Practitioner course. After all, as you are used to, and if you follow my work, all my courses are extremely detailed and full of labs. Also, if you want to hear from me or have some comment, you can contact me on LinkedIn. Just search my first and last name and it will pop at your search. Let's continue to the next chapter of this course. When I started to create this course on AWS, my intention was to create a short course, explain the services and show the basics. And then I realized that there are a large number of people who do not understand the very basics. So I decided at the beginning that we should learn the basics of the cloud, and that when we acquire these very important basics, we will slowly start getting to know the whole of AWS and its services and resources that we can create and use every day. As already mentioned, I will talk about what we learn in this course in the next chapter, but just another explanation. If you're wondering why I want to publish this AWS, because there is so many different AWS courses. Of course, you can find different courses on YouTube, on some paid courses on some different platforms, but this is just my intention to help people to learn basics of this cloud. So let's go to another lesson and learn more about how this course is structured. So, as already mentioned, now it's time to get acquainted with the structure of the AWS course itself. As I mentioned in the previous lesson, the desire was to divide the complete learning cycle into several pillars or areas, so that students could more easily understand what I'm talking about. That's right. The course itself contains more than 10 areas or pillars, dividing by most important pillars like compute, storage, networking, and etc. And in those areas, there are services that we will learn. Many years of experience in creating courses and training have shown that this is the best way to learn everything that is offered and to get the most out of the course itself. Also, what I would like to mention is that this course is intended for beginners, but that those who want to refresh their knowledge or simply see what I'm offering in this course can freely watch it. I thought it was extremely important for me as the creator of this course, but also for the student to be able to skip certain areas that he or she does not want to or knows enough about it. It is important to point out that the course itself contains a sufficient number of explanations, which I created and wrote, but also it is almost impossible to show all the services, how they work and function, so we will mention some of these resources in the form of theory. So many of these examples or labs or hands-ons will be available, and you can see for yourself how it looks like to work with different services. Let's move on. If you are wondering how it is possible that this course is free when there are paid courses for AWS practitioners or different paths to get a certs or certificate on different platforms, and they contain a fewer chapters and labs, hands-ons, there are several reasons for that. The first main reason is that I have received a large number of messages regarding my courses on Udemy platform, not only those regarding Azure, but also AWS. A large number of people could not watch everything I recorded and prepared in my AWS courses, and they paid to learn. As is well known, my courses on the mentioned platform were very long, with a lot of theory, but also more practical labs than theory. So I thought that for the money they pay and could not return, it was my duty to create this more advanced course to thank everyone who asked and supported my work during the previous years. Another reason is that I wanted to present AWS for all those who do not have the funds to provide expensive courses and work with instructors. So this course is free and quite sufficient to pass the introductory or fundamental or practitioner exam, but to help you, also this course will help you to prepare more easily for the more advanced one. Another thing that I forgot to mention in one of the previous chapters is that this course is a mixture of labs that were created during last year and this 2026 years, but this changes absolutely nothing, because the principle of resources creation is almost the same. So once again, welcome, and it's time to finally start learning AWS. So before we start learning, let's first define and learn what is AWS. If you're ever wondering what this means, AWS, this stands for Amazon Web Services, the leading cloud computing platform offered by Amazon. It provides a wide range of cloud-based services, including computing, storage, databases, networking, analytics, and more. And these are these pillars that we are already mentioned. These services enable organizations to build, deploy, and manage applications in the cloud, offering benefits such as scalability, cost-effectiveness, and global reach. It offers on-demand computing services such as virtual servers and storage, but that can be used to build and run applications and web pages. AWS is known for its security, reliability, and flexibility, making it a popular choice for organizations that need to store and process sensitive data. So, why, if you ask yourself, why do you want to learn about AWS? First of all, it is widely used by leading companies and startups around the world. It powers major services like Netflix, LinkedIn, NASA. It offers a hands-on cloud experience with real infrastructure. It is a scalable, secure, and cost-effective platform for building applications. AWS was launched in 2006, starting with the release of their first services, Amazon S3, or Simple Storage Service, which transformed the way businesses manage scalable storage. This was the beginning of AWS' mission to offer cloud solutions that are both cost-effective and affordable to companies of all sizes. The introduction of Amazon EC2, or Elastic Compute Cloud, allowed users to rent virtual servers, significantly reducing the cost of setting up the hardware infrastructure. As the platform evolved, services like AWS Lambda brought serverless computing to the forefront, allowing developers to run code without managing any server. Over the years, AWS has continued to expand its range of services, adding tools like Elastic Beanstalk for easy application deployment and various machine learning services to meet the growing needs of businesses around the world. Today, AWS is a cloud powerhouse, offering hundreds of services to support businesses in almost every industry. AWS services are delivered to customers through a worldwide network of AWS server farms. Charges are based on the combination of usage known as a pay-as-you-go model, hardware, operating system, software, and network features selected by subscriber, requiring varying degrees of availability, redundancy, security, and service options. Subscribers or users can pay for a single AWS virtual computer, a dedicated physical computer, or clusters of either. Amazon provides selected parts of security for subscribers, like physical security of data centers, while other aspects of security are responsibility of subscriber or user, like account management, vulnerability scanning, remediation, etc. AWS operates from many global geographies, including 7 in North America. Amazon sells AWS to subscribers as a way to get large computing capacity faster and cheaper than building an actual physical server farm. All services are built based on usage, but each service measures usage in different ways. As for the first quarter of 2023, for example, AWS has 31% market share for cloud infrastructure, while the next two competitors like Microsoft Azure and Google Cloud have 25 and 11% respectively, according to Synergy Research Group, or SRG. In December of 2024, AWS announced Amazon Nova, its own family of core models. These models, offered to Amazon Bedrock, are designed for a variety of tasks, including content generation, video understanding, and building agent applications. They are available in 6 different sizes, but investment in machine learning and artificial intelligence have become a trademark of AWS in the last few years. So, the development of these services is in a full swing. Of course, other services are also regularly updated, and the popularity of this cloud service provider has not changed for years. AWS is still the king of the cloud among cloud providers, and it remains in first place. Now that you know what is AWS, let's understand what is AWS certification, for example, and what is certification means in the cloud. If you are new to the cloud or want to learn more about the certifications offered by a different cloud service providers, then this is the right place. Without too much of an introduction, AWS and, for example, Azure offers several types of certification, arranged in several categories and strength and areas they cover. If you are interested to learn about Azure, there are another course here in my YouTube channel, so I encourage you to go and see. If you decide to take the path of certificate or certification, then you must know that the exams themselves are very demanding, and in addition to theory, they also require good practical knowledge. So you must open a free account or account on AWS and start learning and start do more practical exams. Then often the combination of this part confuses the participant or students, and they decide to neglect one of them. That's why it is very important to understand the basis of the cloud itself, because then the understanding of the services themselves is much easier. Let's start here with AWS. First, you must know that there are practitioner, associate, professional, and specialty certificate. Which path you decide to take depends on you and your needs and predispositions. Now, let's go to official site and see what AWS are offering us as a student. Well, as I already said, if you go to aws.amazon.com/certification, you can see the list of certificates that is offered by AWS. As you can see, AWS certification is someone will call a measure to validate technical skills and your cloud expertise to grow your career and business. So it is very important to know what path you must go to learn and to take your exam to earn this certificate. Well, let's start for foundational certificates. As you can see, AWS are offered two types of foundational certificate. First one is AWS Certified Cloud Practitioner, and the second one is AWS Certified AI Practitioner. Foundational certifications are the basic one, as you can see, and there is no prior experience needed. If we go inside one of these certificates, you can see more about this exam. For example, the cloud practitioner validates your foundational high-level understanding of AWS cloud services and terminology. This is a very good starting point to start your cloud journey. If you open this certificate in the new browser, you can see more details about AWS Cloud Practitioner. So there is a category, as I already told you. We have foundational category. Exam duration is 90 minutes. Exam format is 65 questions. It is either multiple choice or multiple response, and it costs $100. And you can take this test in person in some testing center or in online with proctor. So it is very strict, and you must be careful. If you do something, if you try to cheat, they will ban you. That's it. And you can see what languages are offered for this exam. So there is also test. There is also tests for this foundational certificate, and also you can check your AWS knowledge, skills, and so on and so forth. You can prepare for the exam, follow this exam preparation plan or AWS skill builder. you can use online learning center, and you can prepare for this certificate very well. Then we have something called AWS Certified AI Practitioner. If we want to see and learn more about this Certified Cloud Practitioner, this is artificial intelligence practitioner that validates your knowledge in these two fields or three fields: artificial intelligence or AI, machine learning ML, and generative AI, and you can find everything on this page. It is exactly 90 minutes and format is 65 questions. Then we have associate certification. This is for the candidates who have some prior cloud or IT experience, and you have 5 of them. You have AWS Certified Machine Learning Engineer Associate, AWS Solution Architect Associate, AWS Certified Developer Associate, you have AWS Certified Data Engineer Associate, and AWS Cloud Ops Engineer Associate. For example, if you choose to see AWS Certified Solution Architect Associate, you can see that you can validate your knowledge, and this exam or certificate is focused on the design of cost and performance organized solution, as you can see in the explanation, and this is an ideal starting point for candidates with AWS Cloud or strong on-premises IT experience. As you can see, this is a category. Exam duration is 130 minutes. It contains 65 questions, and it costs $150. But before we continue, I must mention that if you will pay the full price for one of these exam only the first time. If you pass this exam, the second exam that you take will have 50%. So for example, you already have practitioner or foundational certificate, and then you want to prepare and to take this AWS Certified Solution Architect Associate exam, then cost will be $75. If you go back, there is also professional certification. This is Master Advanced AWS Architecture and Solution and requires 2 or more years of AWS experience. We have 3 certificates. First one is AWS Certified Generative AI Developer Professional. This is a new certificate or exam, and we have 2 more. This is AWS Solution Architect Professional and AWS DevOps Professional. If you go inside our AWS Solution Architect Professional, you can see that this certificate is professional and it is required to have very extensive knowledge about all of these resources. So exam duration is 180 minutes. It contains 75 questions and it costs $300. And the last one is this specialty certification. We have 3 of them, and this is expert level. So we have AWS Certified Machine Learning Specialty, AWS Advanced Networking, and AWS Certified Security Specialty. If you go to Networking 1, you can see that it requires 5 years of hands-on experience, architecture and AWS network solution, for example, and candidates should have deep knowledge of AWS security, storage, networking services, plus expertise in advanced architectures, including IP, VPN, MPLS, automation tools, routing protocols, multi-region solution, and network security features like AWS WAF, IPS, and DDoS protection. The exam duration is 170 minutes. It contains 65 questions, and the price is exactly the same as professional. If you want to go and actually work in AWS and, for example, Azure, you must have something called an account. And of course, you have to open it. Creating an account is not complicated at all, and all it requires is a valid email address and a credit card. When you open an account with both providers, the first thing you need to do is to go to address. For example, for AWS, you must go to signing.aws.amazon.com, sign up, request, or register. Of course, like any new users, both cloud service providers try to offer you certain benefits in the form of credits that you can spend on certain services, or in the form of free services in the next year. So let's see how can we open an account on our AWS. But I must mention you that some of these recordings are from 2025, and I opened my account, my latest account for this course in June 2025. So there was a special offer that was here for previous years. So I still have my free account for 1 year, but in July AWS decided to change something, and I will show you how can you the whole process of how can you create this account and get 6 months of free services. Well, it's now time to see how can we create AWS free account. But before that, when I started to create this service, there was a free tier option that was valid for 1 year. In the meantime, AWS decided to change this free tier, and now we have a different free tier. So my account is still valid until June 2026, but if you want to open new account, you will have to go to AWS amazon.com/free. So we have a new AWS free tier. We have something called free plan and paid plan. So you, as a new customer, will get up to $200 in credits. All new AWS customer can start it as a no-cost free tier, and this is a new free tier option, and you will get $100 at sign up, and you can also earn another 100 as you explore key AWS services. This free plan is valid for 6 months, and you won't be charged for any service unless you choose to the paid plan. So in the free plan, we have an option to choose the free plan, and you can try AWS for 6 months without any cost or commitment. You will receive up to $2,000 in credits, including free usage of some selected services. There is no charge incurred unless you switch to the paid plan, and the negative side of this is workload scale beyond credits threshold, and you can't access to all AWS services and features. So in this free plan, you have these credits, and if you using any of this service, you won't pay anything, but any cost that you make, it will deduct it from these $100 that you get when you create this free plan. In the paid plan, you can develop production-ready workloads with access to over 150 AWS services. You can receive up to $200 in credits, including free usage of selected services. You can pay beyond credit thresholds. Your workloads can scale beyond credit thresholds, and you can access to all AWS services and features. So this is the main difference between free and paid plan with new AWS service plan. I must mention again, when I started creating this course, I didn't know about this offer because it wasn't announced. It was announced later, and there is absolutely no difference. So if you go and search for free tier, you can see that Amazon EC2 service is free, is included in free and paid plan. And if you scroll down on this page, you will see what services are included in which plan. So as you can see, compute Amazon EC2 service is available on both plans, just like Amazon RDS, Amazon S3, Amazon DynamoDB, Bedrock, and so on. Amazon SageMaker, Amazon Aurora, DSQL, and so on. If you go down, you will see that AWS Clean Rooms is only available with paid plans. Amazon VPC is available on both plans. So as you can see, some services are available, some with free tier, some not. So there is an explanation about free plan, about paid plan, what is a short-term trial, and what service or services are always free. So you can see you can access to complete portfolio of 100 plus AWS services with a pay-as-you-go option. Also, there is a large offer that you can use and is always free. And let's click on create account. We are now in AWS console sign up. As you can see, we need to use our valid email address, and we need to specify our account name. As I already mentioned, you can try AWS for free up to 6 months, and you can add your root, something called root user email address. So be aware to, when you add this address, it must be unique. So I already have a free tier account, as I already mentioned, and I will use my different email. So I need to provide my AWS account name, and of course you can change this later in your account settings after you sign up for this. Once you click verify your email address, we need to check your email and see a validation code. Let me go to my Yahoo Mail, and I will add this verification code. Here, and click on verify. Now that we successfully verified our email address, we need to add root user password, and this password provides you with sign-in access to AWS. So it's very important to add some password that is known to you. Of course, as you can see, I already add some random password, but it is publicly known. So let me add another root user password. It must contain uppercase letters, lowercase, number, and non-alphanumeric characters, as you already know. So after we provide our password, we will hit on next, and now we must choose our account plan. As you already know, I already explained what is a free and what is a paid plan. We will choose free plan, and then we need to add our contact information. How do you plan to use AWS? For business or for personal? I will use personal for my own projects, and we need to add contact about this account. Here I will add my full name, country code, country origin, address, city, state, and postal code. And I will check this box that I read and agree with the terms. Of course, once that we add our information, we are in the next page and we need to add our billing information. You will add your billing country, credit or debit card number. Once that you add your credit or debit card, AWS will take $1 from your account and it will pay you back. And this charge is used to verify your account and to prevent any kind of frauds. So for the free plan, no charges occur until you upgrade to paid plan. And as you can see, providing your billing information now enables a seamless upgrade to a paid plan. After I add my banking information, we need to choose our identity. I will choose my country, region, and add my mobile number. And we will verify it once again. And let me choose my country, and I will add my phone number, and we will click on send SMS. After I add my phone number, I received my verification code. I will now add this code to confirm my identity, and let's finally click on continue. As you can see, I'm not eligible for the free plan because I already have my free plan, and the only thing I need to do is to upgrade to a paid plan. So I need to agree by choosing confirm and click on confirm. But for you, if you are using this free plan, this will be, of course, the last step, and you will hit on confirm. And that's it. This is how can you create a free plan or free account on your AWS. Now that we know how to open a free account, we are logged in as our root user, as you can see, and we are inside our AWS console. If I scroll down, you will see a lot of information, and this information is available on your front page. If I go to the left side of my screen, you will see that we have something called service menu. If I click on this link, we can access all our services, AWS services here. So there is a section for recently visited services, and the whole list will be seen here. Also, there is something called search. If I type any resource name, it will be listed here. So you can use search for your search bar. Then in this little cog, there is unified settings. If I click on this, you can change our language. As you can see, we can change our visual mode and add light, browser detail, default, or dark. So if we go to see all user information, we will see our unified settings. So we can add our display, localization, and default region, settings management, and so on. If I click on this AWS logo, we will get back to our home of our console, and if we click on this info, for example, you will get on the right side of your screen a detailed information what is console and how to customize your home dashboard. So you can go even more granular if you want to see. Also, there is a recently visited option. You can see or view all AWS resources. You can choose view all AWS resources to the bottom of this page, and you will see all resources that we recently visited or used. Also, there is some option for this application. You can create application from here. You can click on info and get detailed information about this widget. You can also add any widget on your console dashboard, and it is very customizable. If I scroll down, there is welcome to AWS message. You can see how to start with AWS. There is option link for training and certification. You can see what is new in AWS. Also, there is AWS help widget, and you can view events that might affect your AWS infrastructure and account. You can use these alerts to get notified about any changing, about open issues, schedule changing, or any other notification. Also, there is a cost and usage widget, and because this is a new account, there is no data available about our cost explorer. But when we progress, how this course progressed, and when we use our resources, there will be some monthly billing, and this cost and usage widget will be effective. Also, there is an option for security, to explore Windows, to explore AWS, and so on. Also, when you create this cost and usage, you can turn on this cost explorer. If I scroll down, we can see different solutions, and also there is a solution option, so you can help a solution or ask for AWS help to solve your business and technical cases and problems if you have one of them. Also, console, or the front page of our console, is very rich with widgets. You can add or remove widgets or do anything that you want. So you can also explore AWS. And the good thing is that you have this info button, so you can check for all information about every widget that you have. If you see these dots before or right beside our security, you can change the place of your widgets. So you can pull them, drag and drop down, left, right, and so on. There is also latest announcements. There is recent AWS post, so you can track all the news and see all blog posts, see all announcements, and so on. So it's very easy, as you can see, to modify your home dashboard in AWS console. Also, there is option to add widget. You can add favorites, and also you can reset to default your layout if you want. If I click on this this is my name, this is my account ID, this is my account organization, there is some links. You can turn on multi-session support, and this is me as a root user. And if I click on this drop-down menu, you can see all regions that are available to us. You can choose any region that you want, and it really depends of your need. I must told you that I didn't tell you, but I must tell you that these root users are. You must be very careful when you open your account. You, as a root user, are responsible for all costs and all security in this account. So there is another settings, and then the good practice is to open a new user and add that user some privileges, for example, global administrator, and then you will use this to log in with this new user. So root user is only for, you will use your root user credentials only when you need. If you go to this free compute services, you can see this free tier, and as I already mentioned, this is when I started recording this course, this free tier was eligible, of course. Now, in the middle of the recording, AWS changed this free tier option, so I already showed you how can you use new free tier, but it really doesn't change anything about this course. So you can see what is available and for how long and what services for you. So this is how can you go to your billing and cost management, and in this billing and cost management you can set your own budget, for example, and you can track your charges by account, see your invoices for billing period, for a monthly billing period, and there is also bills options. You can cost all categories, cost allocation tags, use cost explorer, and so on. Then we already saw what we can do. Also, there is a support. You can go to support center, ask for expert help, check documentation, see all training resources, or getting started with their AWS Resources Center. Also, there is a notification center. All notifications that you get will be located here in this navigation center. Most recent, user configured, and AWS Center. And the last thing that I want to show you is, of course, we don't have any notification right now because this is a new account. And of course, the last thing is the Cloud Shell. We will be able to use this Cloud Shell later on, but just for now, Cloud Shell is your terminal, and you can use your command line right here. Also, there is preferences and settings that you need to, or have options to use. So this was our AWS console tour, and of course there is this recently visited site, or you can see all services by categories. So if you need, for example, compute, you will type on compute, and the recently visited services will be located here. So there is a lot of shortcuts. There is also a hamburger menu, and if you click on all services, you can check all services that is available to you in this AWS. So if you go to compute, you will have AWS App Runner, AC2. You can build virtual servers in the cloud, for example. There is also a Lambda service, Lightsail, and with all these services we will get acquainted in the later part of this course. I hope this was helpful, and this was just a little tour in AWS console. Once again, once that you logged in with your root user, be aware that this is only temporary. Why? We will see that later. If you, for example, go to this search bar and type AC2, you will see that we'll get our services, and you can search anything that you want. Also, as I already mentioned, in the hamburger menu, you can see all your application or your services. Thank you for watching. Now that we know how to open an AWS account, and in the previous lesson we take a look at how AWS console looks like, let's see how can we set a budget in AWS. And the next lesson will be how can we create EC2 SSH key. These are some prerequisites that we need to take before we start create our resources. So first, so as already mentioned, it's time to see how can we set a budget in AWS. Creating a budget is very important for several reasons, and one of them is that in this way we can limit the monthly demand for resources that we will create while practicing. But in a production environment, you need to take this much more seriously. Of course, like everything in life, it costs. So does the creation of resources and the use of certain services. And offering AWS is really big. That's why it is important to learn before the very beginning how to make a budget. So let's see how can we do this. So once again we are in our console, and in this chapter, as you can see, Amazon Q has moved, and now the simple, as you can see, icon was added here, and now if you click on this icon you can see your Amazon Q, and you can also type and add some prompts here, or how can I help you today. So you can ask your Amazon Q, that is your AI in or simple helper, here in our console. Let me just go to here and let me type budget, or sorry, let's hit on budgets, and here in the billing and cost management I can create my budget, as you can see. So let's hit on create a budget. Here you can choose a different budget type. You can use a template, which is simplified look, or you can customize your own option. In this template you can see that there are 4 templates that are offered to us. First, you can zero spend budget, then you have monthly cost budget, then you can have daily saving plans coverage budget, so you can add your daily saving plan that notified you when you fall below defined target, or you can add your daily reservation utilization budget. Because I'm using free tier, as you already mentioned, I using this zero spend budget. But if you want to add your customized budget, you can add your customized budget here. You can add different cost budget. This is recommended. You can choose to usage budget, saving price budget, reservation budget, as I already told you. But if you're using, for example, this simplified look, we can add monthly cost budget. Then this will be my monthly cost budget. I can, for example, add my desired wish here, for example, $10, and then I can add my email address here. Then for the scope, I can choose my, all AWS services are in scope in this budget. So you will be notified when your actual spend reaches 85%, then your actual spend reaches 100%, and if your forecast spend is expected to reach 100%. So you're good to go, you're covered. And finally, you can go to custom. As you can see, you can download your JSON file, and if I click to create a budget, our budget is here and it's all set up and we are ready to go. So this is how can you set up an easy budget and be prepared for some unnecessary surprises in the cloud. And when you reach this point of your budget of $10, you will be notified. Now if I go inside my budget, you can see that I can delete or edit this budget, and this is my threshold is okay. You can view your alerts if we check our alerts, you can see that we have our actual budget, forecasted budget, and actual cost. If you want, you can delete this alert. You can view details for this alert. For example, let me just go back to our alert, or you can edit this alert. For example, if you want to edit this alert, you can remove, or you can check your new threshold. You can change this percentage of, for example, this threshold percentage when should this alert be triggered, and you can check this to absolute value or percentage of budget amount, as you can see. And trigger will be this alert will be triggered by your actual or forecasted amount. And then you can change all this. You can also check your SNS simple notification service. For example, you can check your alerts or remove your alerts. You can add your chatbot alerts, and so on and so forth. So you can play around and learn more about budgets. But our budget has been created successfully, and we will leave this budget to the end of this course. But as I already told you, I don't need this budget because I'm using a free tier for now, and I will simply delete this budget. So the recommendation is for you is to leave this budget until the end of your exercise. As I already mentioned, another important thing to do before the official start is to create EC2 SSH key, which we'll use during the course. But before that, let's learn what is EC2 SSH key. And EC2 SSH key is an authentication credential used to securely connect to a Linux virtual server known as an Amazon EC2 instance in Amazon Web Services or AWS using the secure shell or SSH protocol. AWS uses public key cryptography and asymmetric encryption method instead of traditional passwords for this purpose. So an EC2 key pair consists of two parts. First is public key, and we have private key. With public key, this key is stored by AWS and placed on the EC2 instance, specifically in this key file for Linux instances, as you can see on your screen. When the instance is launched, it acts like a digital lock that encrypts data. On the other hand, private key, this is a key file typically with a .pem extension for Linux instances or .ppk for Windows that you can download and store securely on your local machine. It is the unique key that decrypts the information encrypted by the public key, proving your identity when you attempt to connect via SSH. AWS does not keep a copy of the private key. Well, key functions of using EC2 SSH key. The first one is a secure access, so you can establish an encrypted and authenticated secure connection, allowing you to manage the instance remotely over an unsecured network. Then it serves for the authentication, and it serves as a primary method of authenticating your access to the EC2 instance, as AWS does not provide default usernames and passwords for Linux instances. Also, you can use data key pair and helps you to ensure the security and integrity of communications within the AWS ecosystem. Also, you must create a key pair in the Amazon EC2 console or via the AWS CLI before launching an instance if you want to connect via SSH. But the most important thing that if you lose your private key .pem file, you will be unable to access the instance via SSH. Though alternative methods like EC2 Instance Connect or Session Manager may be available, or you may need to follow specific recovery procedures. The private key files require strict file permissions, typically read-only for owner or using chmod 400 for your key.pem file, or your local machine to work correctly with an SSH client. So let's hop to our console and see how can we create our EC2 SSH key. Now that we know how can we set up our budget, let's go once again to our front page of our console, and if I type, for example, SSH key, let me just go to, it's easier for me, let's go to EC2 service. This is a Elastic Cloud service, and here we can set up our key pairs. I will hit on key pair, and I already have my key pair that I'm using from time to time, and I will now show you how can you create your key pair. Let's click on create a key pair, and here we need to add a name for our key pair. You can add whatever name you want, but this will be, for example, key pair. Let me add something like demo key pair 1, for example, and then you must provide a key pair type. We have RSA and ED here, but I will use my, if you click on info, you will see that both these key pair types, and you can use this second one, but it has some kind of limitations. Let me just choose my RSA, and I will choose .pem for OpenSSH, and you can use PPK if you want to use PuTTY or PuTTY. I will not use any tags, and simply let's hit on create key pair. So our key pair is downloaded on our VM, and if I open this file with, for example, Notepad, this is our private key. Be aware, your private key must be private, so I'm showing you this file just for the sake of this course, and I will be deleting this demo key pair, and then we will create a new one, and that's it. Thank you for watching, and let's now learn more theoretical part. For example, what do we need? Why do we need a cloud computer? Moving to the cloud gives organization all of shapes and sizes the ability to move faster, be more agile, and innovate their businesses. The shift to the cloud computing has completely transformed the way we work, communicate, and collaborate, and it's quickly becoming a necessity to stay competitive in today's digital world. If you are considering moving to the cloud-based services and solutions, it is important not only to understand the basics of cloud computing and how it can help you accelerate your digital transformation, but also its benefits and limitations. In today's ever-evolving businesses world, unlocking the true power of cloud technology is not just an option, but an essential strategy. The cloud isn't just a tool, it is a dynamic force for change. Success is shaped with Cloud Continuum, a spectrum of capabilities and services that stretch from the public cloud to the edge and everything in between, seamlessly connected by networks that are the forefront of the cloud and supported by advanced practices. At the heart of this transformation lies data and artificial intelligence. Data migrations is the only first step. The cloud supports the greater ability to create a reliable data platform in different parts of the business. A modern data platform is a prerequisite for advancing artificial intelligence and machine learning capabilities, including generative artificial intelligence. The cloud is the driver, data is the driver, and AI is the differentiator. In the pursuit of the cloud excellence, adhere to basic practices that maximize the value of the cloud. Embrace the cloud as a transformative force to drive innovation and competitiveness. Cloud computing orchestrates technology and infrastructure, offering unparalleled flexibility and efficiency. Cloud computing uses remote servers in huge data centers, segmenting physical servers into scalable virtual machine VM for independent application and OS functionality. Resource pooling consolidates compute resources for on-demand allocation, improving utilization and rapid scaling. Service models meet different needs. Delivery models offer flexibility. Secure, scalable data storage fosters global availability and collaboration. Robust networking ensure low latency and secure connections, and security measures include encryption, access control, and threat detection. Scalability allows for the adjustments of resources for cost efficiency through a pay-as-you-go model. Global data centers provides low latency access, pushing businesses into the digital era. In the next chapter, we will learn what is cloud computing. Cloud computing is the availability of on-demand computing system resources, especially data storage, cloud storage, and computing power, without direct active management by the user. Large clouds often have functions spread across multiple locations, each of which is a data center. Cloud computing relies on resource sharing to achieve coherence and typically uses a pay-as-you-go model, which can help reduce capital cost, but can also lead to unexpected operational costs for users. A statement for the European Commission, published in 2012, argues that the breadth of scope offered by cloud computing makes the general definition elusive, while the definition of cloud computing is from 2011. The US National Institute of Standards and Technology has identified 5 essential characteristics. On-demand self-service. The consumer can unilaterally provide computing capabilities such as server time and network storage automatically as needed, without the need for human interaction with each service provider. Wide network access. Capabilities are available over a network and accessed through standard mechanisms that promote the use of heterogeneous platforms by thin or thick clients like mobile phones, tablets, laptops, and workstations. Consolidation of resources. A provider computing resources are pooled to serve multiple consumers using a multi-tenant model with a variety of physical and virtual resources that are dynamically allocated and allocated according to consumer requirements. Fast elasticity. Capabilities can be elastically provided and released, in some cases automatically, to scale rapidly outward and inward in proportion to demand. To the consumer, the opportunities available to provide often seem limitless and can be appropriated by any quantity at any time. Measured service. Cloud systems automatically control and optimize resources utilization by using the ability to measure at some level of abstraction appropriate to the type of service, like storage, processing, bandwidth, and active user accounts. The use of resources can be tracked, controlled, and reported, providing transparency for both the provider and the consumer of the service use, although for some organizations the impact on revenue from large-scale use may affect profitability compared to the sunk cost of capital option. One of the main challenges of cloud computing, compared to more traditional on-premises computing, is data security and privacy. Cloud users entrust their sensitive data to third-party vendors who may not have adequate measures in place to protect it from unauthorized access, breaches, or leaks. Cloud users also face compliance risk if they have to comply with certain regulations or standards regarding data protection such as GDPR or HIPAA or HIPAA. Another challenge of the cloud computing is reduced visibility and control. Cloud users may not have complete visibility into how their providers manage, configure, or optimize cloud resources. They may also have a limited ability to customize or modify their cloud services according to the specific need or preferences. A complete understanding of all technology may be impossible, especially given the scale, complexity, and deliberately opacity of modern systems. However, there is a need to understand complex technologies and their interrelationships in order to have power and action within them. within them. The metaphor of the cloud can be seen as problematic as cloud computing retains the aura of something noumenal or numinous. It's something experienced without a precise understanding of what it is or how it works. In addition, cloud migrations is a significant challenge. This process involves transferring data applications or workloads from one cloud environment to another, or from on-premises infrastructure to the cloud. Migrating to the cloud can be complicated, time-consuming, and expensive, especially when there are compatibility issues between different cloud platforms or architectures. If not carefully planned and executed, cloud migration can lead to downtime, reduced performance, or data loss. To reiterate, cloud computing is a term used to describe the delivery of on-demand computing resources, hardware, storage, databases, networking, and software to businesses and individuals over a network, usually the internet. Cloud computing allows the organization to access and store information without managing their own physical devices or IT infrastructure. In the following chapters, we will get acquainted with the fundamental concepts and benefits of cloud computing. And just a quick reminder or information about naming conventions in this course. In order to make it easier to understand what resources we are creating, I decided to use simple names for resources in this course, such as Linux _VM, Windows _VM for EC2 instances, VPC for virtual private networks, S3 bucket, etc. In the real world, the naming of resources is very important, so you need to pay attention to this segment when you create Linux instance, for example. It can be dev_environment dev Linux _Linux_VM the name of our region, for example North Virginia, or something else. Of course, you can change whatever name or add whatever name do you want for your instance, but this is some explanation about naming conventions in this course. I think it is important to highlight this as the last lesson of the introductory part of the course. Before we start learning about the basic concepts in the cloud, I must mention that those students who already have experience and know what I will talk about in the next lessons can skip this part and go to the next part of the lessons. As a dedicated trainer and lecturer, my duty is to give every student the same chance to learn, and my obligation is to start from scratch. Learning the basic concept in the cloud is a very important part of the course. This course especially, because it will give you a deep understanding and knowledge during most of the services we will cover, but also give you an excellent foundation for the continuation of the course itself. Also, using PowerPoint slides in the beginning of this course is necessary, because recent studies have shown that it is easier to follow, especially when dealing with important concepts. In the rest of the course, we won't have many slides, other than the basic information about the service. Thank you for your understanding. In today's fast-paced digital world, it's essential for business to ensure that their mission-critical systems and applications are always available and accessible. Downtime, whether caused by hardware failures, software errors, or natural disasters, can have significant financial and reputational costs. That's why businesses need to implement strategies that ensure high availability, fault tolerance, and disaster recovery. High availability, or HA, is a characteristic of a system that aims to provide an agreed level of operational performance, usually uptime, for a period longer than normal. Highly available systems are designed to minimize or eliminate downtime caused by hardware or software failures, network interruptions, or other problems. The primary goal of high availability is to ensure the critical systems and applications are always available to end users, even in the event of a failure. To achieve high availability, businesses typically use redundant hardware, software, and network components such as servers, storage devices, switches, and routers. These components are configured in a such way that ensure that if one component fails, the other components automatically takes control, with minimal or no interference from end users. High availability systems also include monitoring and alert mechanism that notify IT staff of any issues or potential failures, allowing them to take corrective actions before a downtime occur. Fault tolerance is a measure of a system ability to continue operating in the event of component failure, without any impact on end users. Unlike high availability, which is focused on minimizing downtime, fault tolerance aims to eliminate downtime altogether. Fault tolerance systems are designed to automatically detect failures and switch to redundant components without any interruption in operation. To achieve fault tolerance, businesses typically use hardware and software redundancy, including RAID arrays, dual power supplies, and redundant network connections. Fault tolerance systems also use a grouping or load balancing techniques to distribute the workload across multiple servers so that if one server is failed, the other can continue to work without any downtime. Disaster recovery is a measure of a system ability to recover from a catastrophic events such as fire, flood, or earthquake that renders the primary data center unusable. Disaster recovery is focused on ensuring that critical systems and applications can be fully operational as quickly as possible with minimal data loss. To achieve disaster recovery, businesses typically employ a backup and recovery strategy that includes off-site backups, replication to a secondary data center, or cloud-based disaster recovery solutions. These solutions provide businesses with the ability to quickly rebuild critical systems and applications without relying on on-premises infrastructure. There may be some similarities between high availability, fault tolerance, and disaster recovery in the way that they are designed to ensure the critical systems and applications are always available. But there are also differences in their approaches and goals. High availability and fault tolerance focus on minimizing downtime and ensuring continuous operation, while disaster recovery focuses on rebuilding operation after a catastrophic event. High availability and fault tolerance require redundancy and overcoming mechanism to minimize downtime, which disaster recovery requires backups and replication to a secondary location or cloud infrastructure to ensure data availability in the event of disaster. High availability and fault tolerance are primary hardware-based solutions, while disaster recovery is often software-based. In conclusion, businesses must carefully consider their needs and requirements when choosing between high availability, fault tolerance, and disaster recovery solutions. While all three strategies are critical for ensuring the availability and accessibility of critical systems and applications, they differ in their approach and goals. By understanding the differences and benefits of these strategies, businesses can make informed decisions and implement the right solution to meet their needs. Scalability and elasticity are big words in cloud computing, and they are not twins, although they are often used interchangeably. When we talk about scalability, we are talking about the ability of your cloud services to grow with you. You plan for it, ensuring that your technology can handle the extra load as your business or project grows, whether it's data storage, processing power, or customer traffic. Elasticity, on the other hand, depends on flexibility. It's the cloud way of saying "I've got you," adapting to your needs in real time. Elasticity allows you and your cloud services to expand instantly to cope with traffic spikes and then shrinks again when things cool down, ensuring that you don't pay more than you need. Scalability refers to increasing the capacity of a system to efficiently manage and increase workload. This includes either building on the capabilities of existing resources, like scaling, or incorporating additional resources for load scaling. And increase may include an increase in memory, processing power, or storage within the current settings. In contrast, scaling spreads tasks across multiple mechanisms of service optimizing overall system performance and reliability without compromising speed or quality of service. Scalability ensures that your project management tools can grow and adapt as your project increases in complexity and size. Elasticity is the ability of a system to automatically adjust resources levels to suit the workloads it faces at any given time. This smart adaptation ensures that resources are well spent during quiet periods and can be managed during high demands. By automatically increasing or decreasing resources, elasticity helps maintain optimal performance without unnecessary cost, making it go-to for business dealing with unpredictable or changing workloads. Cloud agility describes the rapid provision of computing resources through the cloud. Therefore, adopting secure cloud services and controlling your IT infrastructure there to be enable faster application delivery and drive business agility is cloud agility. The benefits of using the cloud include the increased business value and agility that cloud computing provides. The ability to quickly develop, test, and run software applications in the context of cloud computing is commonly described as agility. They may focus on other issues such as security, monitoring, and analysis rather than delivery and resource management. Agile is often used in the context of cloud computing to describe the rapid development, testing, and launch of applications that drive corporate expansion in a rapidly evolving IT environment. Cloud computing is a major element in enterprises' quest for greater agility and provides companies with the means to foster agility. Enterprise can use cloud computing to significantly reduce the time it takes to provision and outsource IT infrastructure, accelerating the delivery of IT projects that are critical to increasing sales or reducing costs. Unlike setting up a physical server, which can take days or weeks, a cloud server can be ordered and configured in minutes. Time to market is directly correlated with time to revenue. If you're trying to decide between using CapEx financing for data centers or colocation versus using OpEx financing to move your infrastructure to the modern cloud, you need to watch this lesson carefully. Most businesses today will need some sort of online presence. Options used to be extremely limited and expensive, and in fact, until the last few decades, the only option was to build your own data center or collocate your server to an external data center. In the 21st century, cloud computing has become a viable option for all businesses. Cloud technology is now widely adopted by businesses of all types and sizes due to its performance, security, maturity, and surprising affordability. Businesses have two types of cost around infrastructure of cloud: CapEx or OpEx. CapEx financing or capital expenditure means spending funds on real estate and even purchasing infrastructure such as building a data center. CapEx financing, by its very nature, requires startup capital for these large purchases, which limits many organizations in building data centers. Capital expenditures are accounted for in payments for goods and services and recorded on the balance sheet. Capital expenditures are amortized as assets age. On the other hand, OpEx financing or operational expenses is an expense incurred during the course of doing businesses. Colocation and cloud computing fall into this category. This means that cloud computing and OpEx funding are intertwined compared to a CapEx funding. Operation expenses are recorded in the income statement. Cloud computing is an example of operating cost or OpEx. OpEx spend money on products or services such as electricity, payroll, marketing, and even paper and printer cartridges. Simply put, it is expensive. It is an expense that is necessary for the day-to-day operation of the business. When we start talking about operational expenses, there is another contrasting term in the background, which is CapEx, capital expenditure. CapEx, these are funds savings that businesses spend on acquiring, upgrading, and maintaining physical assets such as land, hardware, furniture, buildings, etc. We can also say that these are costs for long-term benefits. CapEx is also considered a negative investment because its value decreases over time. These costs will now not allow you to deduct from taxes, but we must recoup them over time. For example, I bought a machine A, and after 2 years it has to be replaced because the version is outdated, but A works fine. Now I have bought a new version, machine B. Since A here has to be replaced with B, even before machine A deducts itself from taxes, this leads to another negative investment by the company. So sometimes it is difficult to identify the real cost and value of assets for a company. On the other hand, OPEX or operational expenditure, this is spending money on products or services that will be used immediately. This is not an upfront cost. We pay for the products services that we use. Business expenses are full tax deductible and can be deducted from income. Operating expenses reflects the cost of doing businesses as the benefits and value are immediate and can be easily identified. If the operating costs are too high, we can quickly reduce consumption by switching to different products. This would be easy because we haven't invested much more. One of the main advantages of the cloud, that is OPEX, is that there is no need for long-term investments. If the infrastructure requirements are reduced between the time you buy the hardware and the time the hardware reaches the end of its life, then we are going to end up with a lot of negative investments. Thus, with the help of the cloud, we can eliminate the need to purchase infrastructure by choosing the appropriate service model. We can increase or decrease resources at any time. Another advantage is that OPEX is completely tax-free from the same year we bought it. When you compare CapEx or OPEX for cloud computing, a private cloud funded by OPEX is the best option for most companies, especially during turbulent times. This can save your company money in the long run but not having to buy expensive servers and IT equipment or staff. It can also save money by not having to buy land to build your own data center. A private cloud is a great location to host your company's IT assets, and managed private cloud is a great option to consider when choosing the cost of a private cloud funded by OPEX. There are a large number of benefits that can offer us if a company or individual decided to move their businesses to the cloud. In this chapter, we will mention only a few, but it is impossible to write a complete list. Hardware savings. Most traditional system settings have a large hardware component as needed. These basically have a relatively large server which can often sit in a room dedicated to its accommodation. All this hardware costs money, but upfront in terms of purchase and over time in terms of maintenance. Electricity is required, as well as cooling, and this is becoming more and more expensive. Software savings. Also installation costs a considerable amount with frequently required modification to the building, and that space that the server requires can be taken up by something more productive for your businesses, so it's a higher cost. When you make a decision to go with cloud computing, all this physical equipment disappears, carrying with it all that financial outlay. On top of this, all the updates that your business will inevitably need are taken care of by your cloud provider, so that more money and hassle are saved. As I already mentioned, there is software savings. As with hardware, software needs to be updated. In fact, much more. These updates can be very costly for the internal system, but this area can be one of the biggest financial benefits of cloud computing. In addition to those savings, your business will enjoy additional benefits such as immediate and direct employees access to all the necessary software, which means savings in terms of fewer printed copies required. Software is becoming more and more important, coming into more and more productive areas as the Internet of Things grows rapidly. IoT software development will consequently be a larger and more expensive area when you need to stay on top. If you can rely on another body to take care of this for you, so much the better. Finally, the most importantly, you must have a support, and they are met 24/7, 365 via email, instant messaging, even Microsoft Voice, so downtime is minimized. Expensive software technicians should not be kept on the payroll, which is a significant financial savings. It is precisely because of the savings it enables, as well as other advantages, that SaaS is showing such remarkable growth. Pay-as-you-go, both hardware and software service can be delivered on a pay-as-you-go basis. This is of great benefit to business, easing the burden of buying equipment and software in bulk. An additional advantage here is that you will often only pay the amount used, that is, you will have coverage that is adapted to the size of your business. What's more, if there are aspects of the service that you don't use, you can usually choose to discard the part of the package with little waiting time. For example, small business phone service providers will offer packages that differ in content from large business service providers, and will give customers a range of options from the basic chat, text and meeting package upwards. Energy saving. Electricity is expensive and prices are rising. Why pay to power a room full of energy-hungry equipment when you can transfer all of this to the cloud? Using a cloud-based system makes sense from an energy purchase perspective and from an environmental perspective. The multi-client security model results in lower energy cost per unit, thanks to economies of scale. Your business will benefit from these savings. When it comes to the environment, cloud-based services can be beneficial. In-house servers are underutilized and inefficient. Cloud-based services are usually adapt and anticipating demand, so they are optimized for peaks. This results in a more efficient use of energy and consequently a greener profile. Imagine if all free videos were stored on a multitude of local servers across the country. Now visualize all the energy that would have to go into powering and cooling those servers. Now consider a single cloud-based server that delivers those videos to a large number of customers. That's green thinking. Reduce manpower costs. As mentioned earlier, when you start using cloud-based systems, you need to retain IT professional. On your staff is immediately eliminated. Software and hardware specialists are expensive to keep on the payroll. They have to go through training to stay at the top of their game. This may include the additional cost of bringing in other professionals. The whole thing can be a huge financial outlay because IT specialists are not cheap. This is an overview of the situation in the world. For many businesses, staff is a huge expense. A call center, for example, depends on a high level of staff to provide services. A hosted contact center service will enjoy reduced cost thanks to the fact that it will eliminate the need for a technical department full of the brim expensive cable specialists and who knows what else. No cabling, no cost. Better data storage. The use of cloud computing and cloud integration means a higher level of data security. That's because cloud-based service providers are security professionals. They will use the most comprehensive and up-to-date security solutions. What are the financial advantages of cloud computing? By protecting your businesses from ever-increasing costs that make you need to stay on top of data breach threats. Data breaches are costing US companies more than ever before. In 2022, the average cost of a data breach rose to $4.35 million. Of course, the cost of your business reputation is immeasurable. All of this careful cultivation of customer confidence was blown away at a careless moment. As the volume of customer data that your business accumulates grows and the need of compliance becomes more severe, the need to be aware of the increasing range is intersections where data is shared, such as touchpoints in the customer journey. If you allow cloud computer to help with this, your life will be made easier at all. Increase productivity. By increasing your company's collaborative potential, your cost in relation to productivity will decrease. A cloud-based system will provide the same service to all staff no matter where they are located. This means that your business can benefit from teams working all over the world, using the same system and the same data. This applies to a number of business models. For example, when an e-commerce operation is considering how to set up an affiliate program, it's worth considering how a cloud-based system will allow affiliates to have a greater potential to collaborate with the business and with each other. This is because cloud-based services are more adapted for use by remote elements. Also, when it comes to installing new software by modernizing application in the cloud, it can happen throughout the company in a matter of hours. In a house system can take days, and all the problems that arise must be solved by you and your IT experts. With the cloud-based systems, problems need to be solved by the service provider. Better scaling. As your business grows, you need to know that the system it uses will grow in capability accordingly. If you purchase an eternal system, you may not find that you outgrow its capacity relatively quickly. This is followed by expensive and wasteful discarding and replacements. With a cloud-based service, your growing needs are met by a truly resilient and adaptable business assistant provider. This will lead to your business paying for a system that is set up at the right level, rather than struggling to keep up with your company's growth and not too big for your needs. You also won't have to rely on uneven and unreliable growth forecast. Just upgrade your service when needed. You can also temporarily increase the size to meet short-term peak levels of demand. Disaster recovery. It's not pleasant to think about it, but sooner or later your business will no doubt experience some kind of data-related disaster. When this happens, you will have to significant costs. Cost in terms of the help of IT specialists. If the data requires a lot of updating, your IT staff will have to devote their resources to this task, at the expense of other areas that are their daily duties, such as maintenance, staff training, etc. Cost in terms of downtime. Imagine that all profits disappears while your business lies affected. And think of your competitors who descend to steal your customers with all the joy of hungry predators. By using cloud-based systems, your business will have access to better data recovery service than in a conventional on-premise system. Another advantage is that a cloud-based system will be able to route user traffic more efficiently to avoid problems in one specific sector of your business. Facilitation of testing. Using cloud-based services make testing new procedures much easier, simpler and cheaper. Testing such as data analysis is easier to perform in a cloud-based system. For example, cloud computing gives them the ability to test a new platform before actually implementing it. This helps to establish reliability in a secure format that protects the company from any unintended consequences. Consumption-based pricing, also called pay-as-you-go, custom billing, or usage-based pricing, refers to a pricing model in which the price of a product or service is determined based on the use or consumption of that product or service. In this model, customers are only charged for what they actually use rather than a fixed or predetermined fee. Consumption-based pricing has become popular due to its flexibility and cost-effectiveness in a variety of industries. It offers businesses and customers a more transparent and equitable approach to collection, as they are charged according to their specific use. In this pricing model, businesses track and quantify the use of consumption of a product or a service by their customer. This is usually done through measurement of or tracking systems that collect data on the amount of resources used of their or service consumed. This usage data is then used to calculate the corresponding cost. Cloud service providers often use consumption-based pricing model to charge customers based on the amount of resources they use, such as storage space, computing power, or data transfer. This module allows users to scale their usage as needed and pay only for the resources they consume. Software as a service, for example, many SaaS companies offer subscription-based pricing where customers pay a recurring fee based on the number of users or features included in the plan. However, some SaaS providers have begun to adopt consumption-based pricing models, allowing customers to pay for the exact amount of services they use. This model can be especially useful for customers with variable levels of use. Also, Utilities such as electricity, water, or gas suppliers have been using consumption-based pricing for years. Customers are charged based on their actual usage, promoting efficient use of resources and allowing users to have control over their accounts. Some telecommunications providers apply usage-based pricing for data usage or voice calls. This allows customers to pay based on their actual spending rather than predetermined plans or package. The IoT or Internet of Things industry often adopts consumption-based pricing model as devices within the IoT ecosystem generate data that needs to be processed, stored, and transmitted. By charging customers based on their data usage, IoT service providers can align cost with usage and provide more flexibility for customers. These are just a few examples of industry and sectors where consumption-based pricing is applied. The flexibility of this pricing model makes it suitable for businesses that want to align cost with actual usage and provide their customers with more customized pricing options. I will also mention a few benefits of the consumption model. First one is improved customer retention. Consumption-based pricing allows customers to dynamically adjust their spending based on their needs, any budget, which can increase customer satisfaction and improve retention. By accurately measuring and charging customers for using their products or services, businesses can minimize revenue leakage and optimize their pricing strategies. Consumption pricing gives customers the freedom of experiment and testing different combinations and revenue and pricing models that are repeated. This pricing model creates an approach focused on partnership between the seller and his customer, aligning their interest toward achieving customer success. Consumption-based pricing can challenge businesses to anticipate and stabilize their revenue streams. Since customers are charged based on usage, revenue can vary based on consumer spending patterns. This uncertainty can make financial planning and forecasting difficult for businesses. Implementing and managing consumption-based pricing can be complex, especially when multiple variables need to be taken into account, such as scope of use, tiers, and different pricing models. Determining the right pricing structure and accurately tracking usage can be challenging for businesses. For some customers, consumption-based pricing model may be unpredictable or difficult to understand, leading to concerns about fairness and trust. Businesses need to ensure transparency in their pricing methodology and provide clear communication to build trust with their customers. Consumption-based pricing often requires businesses to have the right infrastructure in place to accurately track and measure usage, scaling and tracking and billing system to handle potentially large amounts of usage. Data can introduce complexity and require investments in technology and resources. Usage-based pricing can lead to lower profit margins, especially if there are significant fluctuations in customer spending. Businesses should carefully monitor and manage their costs to ensure profitability and avoid taking on new customers that are not economically viable to use. Consumption pricing models can encourage customers to focus on optimizing usage to minimize cost. This can lead to customers actively looking for ways to reduce usage, which can inadvertently reduce revenue for the business. As AI continues to grow, more and more companies are adopting consumption-based pricing models to monetize their AI services. One emerging trend is the use of the machine learning to help businesses understand how customers use their products or services and then adjust prices accordingly. The shift of cloud-based IT infrastructure is also driving the adoption of consumption-based pricing models, allowing businesses to move away from large capital expenditures and instead pay for services as they use them. Consumption-based pricing finds a variety of applications in a variety of industries, offering benefits such as improved customer retention, revenue optimization, and financial efficiency. However, it presents challenges such as predictability issues, pricing complexity, and concern about customer perception and trust. As businesses face these challenges, current trends point to increasing adoption of consumption-based models, driven to the rise of AI services into the shift of cloud-based IT infrastructure. The changing requirements suggest continuous exploration and innovative approaches such as using machine learning to adjust prices based on customer usage patterns. Traditionally, before cloud computing came on the scene, most organizations had to build internal server rooms to run their networks and software. These servers cost a huge amount of money to acquire, maintain, and secure. The internal server handle all the organization's data computing needs, from email management to the various software subscriptions that the company had acquired. Cloud computing, on the other hand, eliminates the need for internal servers and server rooms by allowing you to access remote servers that house your networks and software. You only need to pay for cloud computing services that cover all of your computing requirements instead of paying for a server room. Most cloud computing services offer a wide range of tools at a fraction of the cost because they can split the cost among their different clients. IaaS, PaaS, and SaaS as a part of cloud computing. Computing is a generic term for what is a really complex concept. It's the same with cloud computing. Cloud computing can be divided into three basic subcategories. Infrastructure as a service, or IaaS. You place your entire network infrastructure on remote servers. This can include virtual machine and storage space for your application and data. Platform as a service, or PaaS, where a certain portion of your IT infrastructure is outsourced to a service provider to gain access to greater computing capacity. Software as a service, or SaaS. You get access to specific software without having to update the software. The vendor deals with upgrades, maintenance, and other issues related to the software itself. IaaS, PaaS, and SaaS are examples of cloud computing where different parts of your IT infrastructure are hosted on the server clouds located in remote location. Now that you have a basic understanding of cloud computing, IaaS, SaaS, and PaaS, let's take a closer look of these subcategories. First, infrastructure as a service, or IaaS. Traditionally, organizations had to construct and deploy these huge servers at the local level that could support their IT infrastructure. Modern server costs are estimated at $1,500 per month for a single rack, not counting the cost of human resources for the maintenance of these servers. The idea is simple. Instead of getting your own servers, you rent servers in a remote location that are maintained by your service provider. The entire IT infrastructure is housed on these servers with state-of-the-art security and multiple protocols that make sure your network never go down as a service. IaaS. Traditionally, organizations had to construct and deploy these huge servers at the local level that could support their IT infrastructure. Modern servers costs are estimated at $1,050 per month for a single rack, not counting the cost of human resources for the maintenance of these servers. Let's take a look at some benefits of IaaS. Performance improvement. Your chosen cloud service provider will, of course, have a multiple and much more robust infrastructure than what you could afford. The industry standard is that you have redundancy rates up to 99% to make sure your networks never break down and that the host is constantly investing in improving their technology and hiring experts to maintaining your servers. There are fewer problems in functionality, and you also get more data processing power due to infrastructure superiority. Since your network can process data much faster, you can use better software, work more efficiently, and make decisions much faster than your competitors. If you're working with private servers, you can expect far more efficiency improvements than you thought possible. Scalability is much easier. As you grow and expand your business, you need access to more infrastructure resources than before. Instead of getting more hardware for an internal server room, you can ask your service provider for more server space than before. This is a far more cost-effective model than expanding your own server capacity, which also takes less time. The flexibility offered by IaaS is unparalleled and allows you to change scales with much more fluidity than expanding the interior space. It is a great advantage to have someone with the space and capacity that will allow you to expand your organization network infrastructure without too many problems that arise in the process. If that wasn't obvious enough, using IaaS is much more cost-effective method of setting up IT infrastructure than investing in your own servers. Service providers have enough space to spread their cost between each of their clients in order to reduce the financial burden of setting up and maintaining server rooms. Let's talk about platform as a service. You can think of PaaS, or platform as a service, as a kind of specialization within an IaaS model, where IaaS only gives you access to servers that you can use as you wish. The PaaS model gives you access to all of the computer frameworks, hardware, software, tools, and everything. The purpose of PaaS is to help ease the application development lifecycle from prototype development, testing process, all the way to application deployment and scaling. You have all the tools you need to complete it. Most PaaS models are also equipped with licensed software and tools that you need to complete it. For all kinds of work, of course. Common PaaS applications include application development, business analytics, and more. Think of it as a ready-to-handle environment with built-in tools to help you complete your projects without the hassle of building one yourself like you would with IaaS. Benefits of PaaS include short time to market, since you don't have to manage the licensing of the tool or the maintenance of the server. You can immediately move on to the completion of various projects. The service provider will take full responsibility for the maintenance and operation of your systems, while providing you with the access to licensed analytics and development tools. You just have to focus on making sure that your projects meet the stipulated deadlines. With the elimination of logical uncertainties and access to a server that can process huge amounts of information, you can expect greater productivity and efficiency. This shortens the lead time and accelerates the development lifecycle for a shorter time to market. It also reduces development cost. There are no resources that you will have to pay for in full because all services are covered by the cost you will pay as a part of your package. Even expanding the space of your server or getting new tools is more affordable compared to working with internal servers. This can significantly reduce your overall development costs. Cross-platform development is easier. One of the main benefits of PaaS is access to tools that help you develop apps for different platforms at the same time, whether you want to develop applications for mobile devices, computers, different operating systems, or other types of devices. It's much more easier to develop them through PaaS than through your own servers. Unleashes internal sources. There are many organizations that use PaaS solely for development or to run business analytics. This allows them to maintain internal servers that they dedicate to their day-to-day work while devoting application development only to the servers they have hired through PaaS. This reduces the pressure on your internal hardware and resources to run two streamlined workflows in parallel without any delays. And the last one is software as a service, or SaaS. Software as a service is the ultimate type of cloud computing that focuses on delivering applications rather than application development or IT infrastructure. The most common SaaS application, as mentioned earlier, is Netflix, which operates on a subscription-based model, whereby Netflix subscriber can access the app over the internet on their personal devices in exchange for monthly payments. This does not necessarily mean that you, as the creator of the application, can use this model to deliver your application. Instead, your service provider may give you access to cloud application on their servers. Licensing fees are covered as part of your subscription and generally less expensive than just getting licenses, which is why many organizations use SaaS instead of getting their own subscription. The advantage of SaaS include automatic updates. Your service provider will manage all updates and will make sure that software continues to work without your intervention. All you have to do is to keep track of your payments, and host will take care of the rest. Some service providers even offer training of how to use the software to its full potential. Cost advantages and flexibility. Your service provider will charge you a fraction of the cost you would have to pay if you had a subscription yourself. A server owner typically invests in group subscriptions that are shared between customers and even allows you to scale up to acquire new functionalities as your organization grows without much additional cost. Shorter time to benefit. Service providers pre-configure all software depending on what functions they need to give you. Ready-made software equipped only with those tools that you will need. This makes it easy to integrate your software so that it becomes part of your workflows. In the conclusion, IaaS, PaaS, and SaaS are all great alternatives to getting your own servers and subscriptions. Low cost, ease of integration, greater flexibility and reliability of working with remote servers give us a greater degree of freedom and efficiency compared to internal servers. Given the potential of the cloud computing and the various outsourcing options associated with it, it should come as no surprise that IaaS, SaaS, and PaaS have become commonplace in the average user's world. The best way to understand what is a shared responsibility model in AWS is to go to the official pages of AWS. As you can see, in the aws.amazon.com, in the compliance section, there is a shared responsibility model. So let's take a quick look of what is your responsibility and what is the responsibility of AWS as a cloud provider. So I will read this to better understand this overview. Well, security compliance is a shared responsibility between AWS and the customer. The shared model can help relieve the customer operation burden as AWS operates, manages, and controls the component from the host operating system and virtualization layer down to the physical security of the facilities in which the service operates. The customer assumes responsibility and management of the guest operating system, including updates and security patches, and other associated application software, as well as the configuration of the AWS provided security group firewall. Customers should carefully consider the services they choose, as their responsibility vary depending on the service is used, the integration of these services into their IT environment, and applicable laws and regulation. The nature of the shared responsibility also provides the flexibility and customer control that permits the deployment. As shown in the chart below, this here is differentiation of responsibilities, commonly referred to as security of the cloud versus security in the cloud. So in this security model here, you can see a different, let me just check this once again. You can see what is a customer and AWS responsibility. Let's start from AWS. AWS is responsible for security of the cloud, and customer is responsible for security in the cloud. So in the AWS side, you can see that we have our regions, availability zones, and edge locations. In later part of this course, we will take a deep dive. What are regions, what are availability zones, and what are edge locations. Then AWS is responsible for the state of hardware, and this hardware is part of AWS global infrastructure. AWS is responsible for compute, storage, database, and networking, and then for the software that will run on this hardware. Then, as I already mentioned, we are, as a customer, responsible for customer data, as you can see, platform, applications, identity and access management. Also for operating system, for patches, networking, and firewall configurations. So if you, for example, create security group and you didn't specify your rules in that group for outbound or inbound traffic then it is your responsibility to take some action to improve this, for example, traffic to your instance or outbound to internet from your instance, for example. Then it is your responsibility for client-side data encryption and data integrity authentication, for server-side encryption like file system and or data, networking traffic protection, encryption, integrity, and identity. So this is just what is and this is the AWS shared responsibility models. If you go even scroll down, you can go even deeper for understanding the AWS shared security model. So you can check this by your own. What is AWS responsibility security of the cloud? So as you can see, AWS is responsible for protecting the infrastructure that runs all the services offered in AWS cloud. This infrastructure is composed of the hardware, software, networking, and facilities that run in AWS cloud services. Your responsibility, as you can see, is much longer. Your responsibility will be determined by the AWS cloud services that a customer select. So, for example, if you select a service such as Amazon Elastic Cloud, Compute Cloud Service, or EC2, or service that you can create your instance or virtual machines, this is categorized as infrastructure as a service, IaaS, and you as a customer, you need to perform all necessary security configurations and management tasks. So when you deploy an EC2 instance, you're responsible for management of the guest operating system, including updates and patching, security patches, any application software or utilities installed by customer on that instance, and the configuration of the AWS provided firewall. This is called security group on each instance. So as you can see, this is your responsibility, and you have some inherited control. You can see that AWS, you can control which the customer fully inherits from AWS, like physical environment controls. Then there is a shared control, like patch management, configuration management, awareness and training, and so on. And there is some specific responsibility, as you can see, like service and communication protection for or zone security, which may require customer to route or zone data with specific security environments. And applying the AWS shared responsibility model in practice, you need to understand these rules, and you can check all this documentation on this shared responsibility model pages. Thank you for watching, and let's move on. Now that we learned most of the basics of cloud computing, it's time to get acquainted with deployment models. Cloud deployment models define how cloud services are delivered, managed, and accessed. The choice of model affects the flexibility of your organization, cost efficiency, and security position. With global cloud spending expected to exceed $500 billion by 2027, it's critical to make informed decisions about which model best suits your needs. First is public cloud. The public cloud is the most widely accepted deployment model, where services over internet are provided by third-party providers such as Amazon Web Service or AWS, Microsoft Azure, and Google Cloud. These services are shared across multiple organizations, making the public cloud an ideal choice for businesses looking for scalability and cost effectiveness. Key features: scalability. Public clouds offer virtually unlimited scalability, allowing businesses to quickly expand or contract resources in response to changing demands. Cost effectiveness. With a pay-as-you-go model, public clouds reduce capital expenditure, allowing businesses to optimize cost based on actual usage. Maintenance free. A cloud provider manages all maintenance, updates, security, allowing organizations to focus on their core business activities. A recent study by Gartner found that 80% of organizations that adopted the public cloud achieved significant saving in the first year. Public clouds are ideal for organizations that want to implement scalable, cost-effective solutions with minimal management costs. Common use cases include web hosting, SaaS applications, and development environments. A private cloud is a cloud environment dedicated exclusively to a single organization. The infrastructure can be hosted on premises or managed by a third-party provider, offering enhanced control and security. Key features is I already said enhanced security. With dedicated resources, private cloud provides a higher level of security and compliance, making them suitable for industries with stringent regulatory requirements. Customization. Private clouds offer greater flexibility in configuring resources and services to meet specific business needs. And control. Organizations maintain full control over cloud environment, including data management, security policies, and infrastructure management. IDC reports that 70% of large enterprises have adopted private cloud solutions to meet stringent compliance and security requirements. Private clouds are typically used by large enterprises, financial institutions, healthcare professionals, and government agencies that require a high level of control, customization, and security. Then we have a hybrid cloud. A hybrid cloud combines elements of a public and private cloud, allowing organizations to take advantage of both. This model provides flexibility, allowing data and applications to be shared between environments based on business needs. Key features is flexibility. Hybrid clouds allow organizations to store sensitive data and critical workloads in a private cloud while using the public cloud for less critical operations. Scalability with control. Enterprises can scale resources in the public cloud while maintaining control over core operations in the private cloud. Seamless integration. Hybrid cloud environments can integrate seamlessly with existing IT infrastructure, providing a balanced approach to cloud adoption. Flexa report shows that 92% of enterprises have adopted a multi-cloud strategy, with hybrid cloud being a key component. Hybrid clouds are ideal for organizations that require the scalability of public clouds but need to maintain control over certain operations. Typical use cases include disaster recovery, data archiving, and application with variable workloads. And the last one is community cloud. A community cloud is a collaborative cloud environment shared by several organizations with common goals of regulatory requirements. This model is often used by industries with common interests, such as financial services, healthcare, or government. Key features. In the community cloud, you have shared infrastructure. Community clouds allow multiple organizations to share resources, reducing cost while adhering to industry-specific regulations. Collaboration. Organizations within the same industry can collaborate more efficiently by sharing data, applications, and services in the community cloud. Compliance. Community clouds are often designed to meet specific compliance standards, making them ideal for regulatory industries. According to Deloitte survey, 58% of healthcare organizations are using clouds in the community to improve and meet regulatory standards. Community clouds are suitable for organizations in highly regulated industries that need to collaborate while maintaining compliance. Common use cases include research collaboration, health data sharing, and government services. Choosing the right cloud deployment model is more than a technical decision. It is a strategic choice that affects the agility, security, and long-term growth of your organization. Whether you are learning toward public cloud scalability, private cloud control, hybrid model flexibility, or the collaboration offered by community cloud, each options offer different benefits. As the cloud adoption continues to accelerate, understanding these deployment models will position your business to harness the full potential of the cloud. Let's take a look at what those basic savings, and we'll also look at what it looks like in AWS. On-demand on instances or on-demand instance. This model allows you to pay for computing capacity, per hour or second with a minimum of 60 seconds without any long-term commitments. It offers maximum flexibility as you can scale resources as needed. It is suitable for workloads with changing or unpredictable requirements. Then we have reserve instances. Reserve instances provide a significant discount up to 75% compared to on-demand instances in exchange for committing to a specific instance type, region, and period from 1 to 3 years. This model is ideal for stable, predictable workloads. You can choose from 3 payment options: no upfront, partial upfront, and all upfront, with growing discounts for higher upfront payments. Then we have saving plans. Saving plans are a flexible pricing model that offers lower pricing for computing services such as Amazon EC2, AWS Lambda, and AWS Fargate in exchange for committing to a certain level of usage. It is measured per dollar per hour over a 1 or 3 year period. They offer a balance between flexibility and cost savings. There are 2 types of saving plans: compute resource saving plans and instance saving plans, with varying levels of flexibility and discount rates. Then we have something called spot instance. Spot instance give you access to backup AWS consumption capacity at a discounted price up to 90% off on demand if your workload can tolerate interruptions. There is a cost-effective options. This is a cost-effective options, and it uses fault-tolerant workloads. It is for fault-tolerant workloads. AWS can restore spot instances with a minute or 2 alert if capacity is needed for other purposes. Then we have similar things like in AWS, that is dedicated host. Dedicated hosts provide physical service dedicated to your use, allowing you to use existing software license per socket, per core, or per virtual machine. This model is suitable for working with specific licensing requirements or compliance needs. While it's not as cost-effective as other options, it provides a maximum control and flexibility in addition imagine that you have some virtual machine or instance and you want to host that instance on your dedicated host. This host will be only yours in that data center, in that rack. So all your virtual machines that you choose will be located specifically on that host. So you will pay extra for this host. In addition to these basic models, AWS also offers a few things. As we already know, there is a free tier. There is now a new frontier that provides free access to certain services for a limited time or level of use, often used for testing and evaluation. Discounts based on volume. Then some services offer lower prices per unit as the usage increases. AWS pricing calculator. We have a cost estimation tool for your specific workloads and configuration. And you have something called enterprise support plans or enterprise plan. It offers dedicated support and resources for large installations. So you have pay extra for this enterprise support. If I'm wrong, no, not wrong, it is $100 per month. So let's talk about AWS global infrastructure. Amazon Web Service provides the broadest global footprint compared to any other cloud service provider on the market, opening up new regions faster than others. AWS maintains a number 1 of global geographic regions, from North America, South America, Europe, Asia, Pacific to the Middle East. AWS serves 1 million active customers in more than 190 countries. AWS can support the massive workload, a global cloud infrastructure consisting of availability zones, regions, and perimeter networks or edge networks. AWS global cloud infrastructure is the most secure, comprehensive, and reliable cloud platform in the industry today, offering a wide range of cloud services. AWS is the best choice for SMBs to globally deploy their applications, workload, and distribute content closer to end users with low latency or no delay. It provides you with a highly available and fault-tolerant cloud infrastructure where and when you need it. So, as you already know, AWS owns and manages thousands of servers and networks devices that are running in a variety of data centers scattered around the world. AWS provides us with an infrastructure with data centers that are available around the world. AWS provides us with the possibility of multiple availability zones. Even in the event that one availability zone fails, the other availability zone carries the load and continues our operation, which is the main advantage of AWS Global Infrastructure. The AWS Global Infrastructure Map is a comprehensive visualization of Amazon Web Services' broad global presence. It highlights AWS data centers, including regions, availability zones, and edge locations spread around across different geographies around the world. This infrastructure provides low latency access, high availability, and fault tolerance for AWS customers, enable them to deploy applications and services with greater reliability and performance. By distributing data and services closer to customers, AWS Global Presence supports scalability and resilience, ensuring that enterprises can deliver seamless digital experiences across all regions. The AWS Cloud is distributed across 108 availability zones in 34 regions around the world, with future planned extensions for 18 additional availability zones and 6 new regions, including Mexico, New Zealand, Saudi Arabia, Thailand, Taiwan, and AWS European Sovereign Cloud. So, what are the main parts of AWS Global Infrastructure or its components? The first one is data center. A data center is a physical facility that contains hundreds of computer systems, networking devices, and data storage devices. So we can run our applications in 2 or more data centers to achieve high availability, so that if there is a failure in one of the data centers, we still have other servers running in the other data center. The data center can also deliver cached content to your global end users to improve response times. As its core, AWS Global Infrastructure uses multiple data centers and groups them into availability zones, regions, and edge locations. Availability zones, or AZ, as we like to call them. AZs are physically separated data centers with a redundant power, supply, and connectivity network. Thus, each availability zone is a logical group of data centers that can be one or more physical data centers. They can be located in separate buildings or locations. They are built with redundancy, and also there is a network or high throughput and low latency between these AZs in this particular region. All traffic between all AZs is encrypted. Many data centers make up AWS Global Infrastructure. Inside the data center, there are thousands of physical servers, storage racks, and firewalls. Each data center is typically built with a redundant power supply and network. Each AZ has multiple data centers in each region. The main reason for having multiple redundant data centers in the AZ region is high availability. Many AWS services have built-in high availability where resources are replicated to multiple AZs in a region. For example, Amazon S3, or Simple Storage Service, operates in at least 3 AZs. Data is protected if one AZ falls into other. AWS also provides customers with the option to deploy the applications across multiple Asian zones, or availability zones, that's a mistake, to ensure business continuity in events such as power outages, fire, or floods. Then we have something called point of presence, or POP, or POP. The second component of the AWS Global Cloud Infrastructure is the Point of Presence Edge Network, or POP. It consists of edge sites and regional edge caches, which allow us to distribute our content with low latency to our global users. Basically, a POP serves as an access point that allows two different networks to communicate with each other. By using these global edge networks, a user's request doesn't have to travel far back to your source just to retrieve the data. Cached content can be quickly retrieved from regional edge caches that are closer to you and your users. This is also called the Content Delivery Network, or CDN. For example, we have a high-resolution image stored on a server in California. We can cache these media files at the edge location in Philippines, India, or Singapore to allow our clients in Asia to download these photos faster. Images will load quickly because they are downloaded to an edge server close to our users instead of being downloaded from the original server in California. Then we have something called region. You heard about region in the previous part of this lecture. So what is a region? When you use, for example, AWS Console CLI or SDK to manage some of AWS resources, the first thing we need to do is to select a region. The resources we have created in one region are only visible in that region. There are a few things to consider when you choose a region. First of all, we may want to choose a region that is close to our users because of the lowest latency. For example, if the most of your users are in the United States, we may want to select the United States region. The second reason is the compliance and regulatory requirements. Certain laws dictate that certain data must be stored in certain countries. For example, if your organization manages highly sensitive data for the US government, we should consider government cloud. Some resources or services are only available in certain regions. New services are usually launched first in the East and Northern Virginia region of the United States, because this is the first region that AWS built when they start with this business. Sometimes it takes a long time to get to other regions. For example, Alexa for Enterprise is currently only available in this region. However, this does not mean that you or your user or end user cannot access the application created by the service. It just means that we can only create and manage the service in that particular region. Each region may have different prices for AWS services. For example, our AC2 instances or virtual machine or data in S3 buckets may be charged at a different price in Singapore than in the United States. Keep in mind that AWS charges for cross-region data transfers. Then there is edge locations. Currently, edge sites are part of the AWS Content Delivery Network, or CDN, to deliver content with low latency and high throughput. Edge locations are close to users all over the world. They use Amazon ultra-fast global network backbone to deliver data and cache it in a location that is close to the user. Services that use edge locations are Amazon CloudFront and Lambda, for example. Edge CloudFront is an AWS global CDN network for caching dynamic or static content. Lambda uses edge computing networks to run code or low latency computing resources. They are also serverless resource. We only pay per use with no minimum upfront cost. Transferring data from AWS sources such as Amazon S3, EC2 and Elastic Load Balancing to the edge location is free. We only pay for data transfer for the edge location. For example, if you run a photo sharing website that stores images in S3 buckets in the US, the majority of our end users are in Singapore. When users download image for the first time, the images are shipped from the S3 card to the US via CloudFront and cached at the edge location in Singapore. Later, other users in Singapore will download them from the edge location. Without edge sites, this content will always have to travel from the source to the end user. We don't have to pay per data or for data transfer between S3 and the edge location. It's much cheaper than sending data directly from the S3 to our users. And we have regional cache on edge. A regional cache edge or edge cache in AWS is a location that resides between AWS edge location and source servers such as S3 or EC2 in a CloudFront Content Delivery Network or CDN. It helps cache larger objects that may not be accessed frequently at edge locations. When content is not available in the edge cache, it is retrieved from the regional edge cache, reducing the need to return to the source server, thereby improving content delivery efficiency and reducing latency for users. The great thing about these all cloud services or cloud providers is that you can see almost everything on their website. So if you go to aws.amazon.com/about-aws/global infrastructure, you can see all regions or all global infrastructure that we just talked. So if we go to this site and for example scroll down, you can see that AWS Cloud spans 120 availability zones within 38 geographic regions, with announced plan for 10 more, as I already said. So you can go, for example, to North America, South America, Europe, Middle East, Africa, Asia Pacific, and Australia, New Zealand. And then with these geographic regions, you can see all what is where and what is available. For example, AWS Government Cloud is in East US or is US East. They have 3 availability zones and it's launched 2018. If I go further, you can see that we have another government cloud. This is US West. There is 3 availability zones and it's launched on 2011. If you go, for example, to Canada Central on this map, you can check some information. There is 3 availability zones and it's launched in 2016. And then there is Canada West in Calgary. Of course, availability zone is 3 and it is launched 2023. This is the newest data center. So let's go to Mexico Central, for example. This is the newest one and we have 3 availability zone and it's launched this year. If you go, for example, to our first the first mentioned region, it is US East, North of Virginia. There is a 6th availability zone. This is the only region that has 6 availability zone and it is launched 2006. Of course, we have US West, Northern California. It is launched 2009. And you can see all these geographic regions. There is 9 geographic regions. And if we scroll down, there is something called edge locations. And you can see all edge locations around the US, for example. And there is 31. You can see one in Atlanta and so on. And let's go to South America, for example. You can see that we have 2 geographic regions in Sao Paulo in Brazil and in Chile. And this is coming soon. Also, there is a 7 edge location. If you, for example, go to Europe, we have 9 geographic regions in Stockholm, Frankfurt, Ireland, or London. And we have 31 edge locations. And you can see the whole the whole number of these edge locations. So we have one in London, Lisbon, Zurich, Vienna, Rome, Paris, Munich, Milan, Manchester, Amsterdam, and so on. And if you are interested in more about this infrastructure, you can check them on this local site. Also, you can check for infrastructure solution. You can check for AWS local zone, dedicated local zone, and so on. All of this information you can find, as I already mentioned, on the official site. On the official site of AWS. So you can see how many regions, availability zones, POPs. As I already told you, there is more than 700, and 43 local zones and 35 wavelength zones, and so on. So you can see that the newest thing that AWS just launched new region in New Zealand, and there is a new region in Taiwan, Chile, and Mexico. And you can also check the benefits of global infrastructure. So now that we know how and what is AWS global infrastructure, we will now learn more about data centers regions and what is a per region in Azure. And the last lesson in this part of this course is what is AWS cost anomaly detection. Well, as this name suggests, this is a machine learned powered tool within AWS billing and cost management that automatically identifies alerts you to unusual, unexpected, or sudden increases in your cloud spending. It minimizes billing surprises by analyzing historical usage patterns to detect cost spikes in real time across services, accounts, or tags. Let's take a deeper look of some of the key aspects of AWS cost anomaly detection, which include machine learning models. These models can, or this service evaluates your spending history to calculate the expected daily spend, comparing it against actual usage to identify anomalies. Root cause analysis. It enables users to investigate anomalies by breaking down the cause by AWS service, member account, region, or usage type. Then we have proactive alerts. You can use or receive alerts individually or via daily, weekly reports through email or Amazon Simple Notification Service or SNS. Then we can use something called Manage Monitors. You can set up automatic manage monitors that track all your AWS services, accounts, cost allocation tags, or cost categories, adapting automatically to changes in your organization. Also, we have something called customizable thresholds. You can use these customizable thresholds to minimize false positives, for example, and this is a simple tool that allows you to refine sensitivity and account for planned growth or seasonal variations. And finally, we have enhanced speed that use a rolling 24-hour window, which allows for faster identification of cost spikes compared to traditional daily reports. Also, this service, AWS Cost Anomaly Detection, is available at no additional charge and helps teams, for example, to maintain control over a cost as their infrastructure grows. So, when you start using AWS and as a company, and your company have some infrastructure that is grow on a daily basis and your business is growing, then using AWS cost anomaly detection is very useful, and you can use it as your infrastructure grows, as we already learned. If you go to our console, if you go to our billing and cost management, and if you click on cost anomaly detection, you can simply skip your tour or show me around option. And let's get started. I will now click on show me around, and here, as you can see, we can see that cost anomaly detection summary provides an outline of any cost anomalies that AWS detect and summarize the impact of the overall spend. You can see that we have our anomaly detected. I have 0, of course. I don't have any total cost of impact. I have $0 spent and 0. I don't have any spends from the last month. If I click on next, you can see that here in this second tab, you can use this tab to detect anomalies, and as here implies, you can choose your detection history, cost monitor, and alert subscription, so you can use tabs between these views. Next, you can see that this detection history section provides a list of all anomalies detected over a chosen frame, for example. By default, AWS will show you anomalies information from the last 90 days, and you can simply check this here. Finally, we have this cost monitor. As you can see, this is my default services monitor, and I can create a new monitor if I want, and this is my alert subscription, and I can check my threshold. As you can see, when my threshold, this is default service subscription. If I have this $0, and if I reach this threshold or for 40% or reach this 100, then by default I will get this information about my spendings, that I reaching this threshold or I am exceeding this threshold. So I can simply create a new subscription, or simply create a new alert subscription, and that's it. As you can see, this is me as a subscriber, and it is attached to one cost monitor. If we go to inside our default services subscription, you can see what is my subscription, what is alert subscription of my anomaly subscription. Of course, this is me as a subscriber. So this is your anomaly cost detection as a service, and you can find it, as I already told you, in management and cost, billing and cost management. Let's go to our front page, and finally we are now starting with our first service, and this is IAM user service. Of course, we will now go back to 2025 when I created this account, and the best way to see this is I don't know if I mentioned then in that if I go to IAM service, then we must create our IAM user, give that user some roles and permissions, and then we can log in with that user and use our account and create resources. I'm now, for this course, I'm using my root username, as you can see here. And finally, we can turn on our multi-session support and so on and so forth. So this is how can you use AWS cost anomaly detection. Let's move on. Well, in the next set of chapters, we will take a deep dive in IAM service in AWS. So the first thing I want to present you is what is IAM. AWS IAM, or Identity and Access Management, is a web-based service that helps you securely control access to AWS resources. It allows you to manage who can access your AWS resources and what they can do with them. Essentially, IAM is how you define and manage identities. By identities, I mean on users, groups, and roles, and what permissions and how to interact with different AWS services and resources. Identity and Access Management, or IAM, manage your Amazon Web Service or AWS users and their access to AWS accounts and services. It controls the level of access that a user can have through an AWS account and set up users, assign permissions, and allows the user to use various features of an AWS account. Identity and Access Management is mainly used to manage, as I already told you, users, groups, roles, and access policies. The account we are using to log into Amazon website is known as the root account and has all the administrator rights and privileges and has access to all parts of the account. A new user has created an AWS account. By default, they do not have access to any of the services in the account, and with the help of IAM, the root account owner can implement access policies and grant that user permission to access certain services. So we will see this in the next couple of hours. So, user control is that IAM allows you to create users in group, giving each of them specific permissions. Security ensures that users only have access to what they need, reducing security risk. Access management IAM allows you to control who can modify resources, extra security, so you can enable multi-factor authentication for added protection. And also, IAM helps you prevent unauthorized changes to your critical infrastructure, such as resources, and this is called resource protection. IAM verifies that a user or service has the necessary permissions to access a particular service in the AWS cloud or your account. We may also use IAM to assign the appropriate level of access to specific users, group, or services. For example, we can use IAM to allow EC2 instance to access S3 buckets by requesting precise permission. IAM identifies and helps us to control which user can access which service and resource in the AWS console. And we can also assign policies to user groups and roles. IAM identities can be created using the root user. IAM identities are classified as IAM users, IAM groups, and IAM roles. The root user will be automatically created and will be given unlimited right. We can create an administrator user with less authority to control the entire Amazon account. So the great idea about all this is when you create your account with your email address, for example, you will be the root user. The first time when you log into your account with root user, you will have the access to all services, all part of your account. And then the good idea is to create a new user, give that user administrator privileges, log out with your root account, and use the newly created user to log into your account. And with that user, you will be able to do anything that you need. And what do you need? To create new resources, to create new users, and so on and so forth. But this time your root user will not be compromised if some bad actor gets your credentials. Let's find out what is IAM user. We may use IAM users to access the AWS console, and their administrator permissions are different from the root user if we can track their login information. What is IAM group? A group is a collection of users, and one person can be member of several groups. With the help of groups, you can quickly and efficiently manage permissions for multiple users. So if you have or give some permission to your group, all members in that group will inherit that permission that you add to this group. Simple as that. Then we have something called IAM roles. While policies can be directly assigned to any of the service through available to Amazon dashboard, IAM roles are similar to IAM users, and they can be downloaded by anyone who needs them. By using roles, we can provide access right to AWS services and to other services, to, of course, AWS services. And then we have something called IAM policy. IAM policies can manage access for AWS by adding them to IAM identities or resources. IAM policies define the permission of AWS identity and AWS resources. So, user is your identity. One user have one identity. And you can give permission and roles to that identity or resources. Of course, resources can be identity as well. When a user or any resource submit a request to AWS, it will validate these policies and confirm whether the request will be approved or denied. AWS policies are stored in the form of JSON format, JavaScript object notation, and the number of policies that are added to specific IAM identities depends on the number of permissions required for a single IAM identity. IAM identity can have multiple policies associated with them. And there is also option if you're, for example, you can share access to your account if your team working on the project. You can easily share resources with the help of the shared access feature. Also, the IAM feature of the AWS account is free to use, and fees are only added when you access other Amazon Web Services using IAM users. So, I mentioned in the beginning of this course that I won't compare these two services or these two cloud providers, but if you remember, when we talk about Enter ID, there is some limitation if you are using this service, because it requires some licenses, and I already showed you how can you use or activate a trial license, and in the AWS IAM or identity and management service is free to use. Also, you have centralized control over all your AWS account. Any new user creation, groups, or any form of cancellation that occur on your AWS account is controlled by you, and you have control over what and how data the user can access. Also, you can assign permission to the user. Since the root account has administration rights, as I already explained, the user will be granted permission to access certain services through IAM. Also, there is a multi-factor authentication for AWS, and this option serve as MFA, serve as extra layer of security, and is implemented on your account by a third party with a 6-digit number that you must enter along with your password when logging into your accounts. In the next chapter, we will learn what is IAM user. But before we create our new user and first user, let's have a deep dive of what is IAM user. In AWS, an IAM user is an identity that represents a person or application that can interact with AWS resources, as I already told you. Essentially, it's a way to assign certain permissions to individuals or services so that they can access and manage AWS services and data. Each IAM user has their own set of credentials or security credentials, such as passwords or passkeys, which are used to authenticate and authorize their actions within AWS. An IAM user is a human user or workload that uses an IAM user to interact with AWS resources. An IAM user consists of a name and a credential. An IAM user with administrator privileges is not the same as a root user for an AWS account. For more about information about the root user, see AWS account root user. So I already explained what is the difference between AWS root user and this user with administrative privileges. So when you first create your IAM user, IAM creates these ways to identify the user. A friendly name or friendly name for an IAM user, which is the name you provided when you created an IAM user, such as Richard or Anaya or some else, any name that you want. These are the names you see in the AWS Management Console. Amazon Resource Name or ARN for IAM user. You can use ARN when you need to uniquely identify a user across AWS. For example, you can use ARN or Amazon Resource Name to designate an IAM user as a principal in the IAM policy for the Amazon S3 bucket. The ARN for IAM user might look like this, as you can see. ARN, then AWS IAM account ID without hyphens, user / for example Richard, and all IAM user will have this ARN or Amazon Resource Name. This is very important to remember. And then you have something called a unique identifier for users in IAM. This ID is only returned when you use the API, Windows PowerShell tools, or AWS CLI to create IAM users. You don't see this ID in the console. When you use the AWS Management Console to create IAM users, you must choose to at least include the console password or access key. By default, a new a brand new IAM user created using the AWS CLI or AWS API does not have any credentials. You need to create a credential type for IAM users based on your use case. By default, the new user does not have any permission to do anything. He is not authorized to perform any AWS operations or to access any AWS resources. The advantage of having individual IAM users is that you can assign permissions to each user individually. You can assign administrator permissions to a handful of users, who can then administer your AWS resources and even create and manage other IAM users. However, in most cases, you want to limit user permissions to only task, AWS actions, or some different operations and resources that are required for the job. This is good for the security point of view. Each IAM user is associated with one and only one AWS account. Since IAM users are defined with your AWS account, they do not need to have a payment method in their AWS records. Any AWS activity performed by IAM users in your account is billed to your account, and that's it. The number and size of IAM resources in AWS account are limited. We will now go to our console and see how can we create a new and first IAM user. Welcome back, and in this lecture I will show you how can we create our first AWS user. As you can see, we are in our console. This is now very famous AWS console, as you already know, and in this lecture we will create our simple user, and let's see how we can create our user. As you can see, I'm logged in with my root account, and if you go to our search, we can type IAM simple, and you can see that we have our IAM manage access to AWS resources. We have also resource manager and IAM identity center. Let's go inside our IAM or our identity and management service and access management service. So I don't have any user and I don't have any user groups. As you can see, we have 2 roles but 0 policies and 0 identity providers. If you go to access management and click on users, you can access user right from there, and you can see this is our signing URL for IAM users for this account. This is our account ID, and this account ID is also included in that signing URL. There is something called add MFA for users, but more later about this. So you can see we don't have any active access key for now, but we have 2 roles. This is role AWS service role for support and AWS service role for trusted advisor. This is default role which are created when you create your account. There is an explanation of what is IAM role. So an IAM role is an identity you can create that has specific permissions and with credentials are valid for short durations. And if we see, this role can be assumed by entities by our trust. And this is simple AWS service support and AWS trust advisor. If you can see, there is a lot of option for our left side, and these blades are for different things. Of course, you can track your user groups, roles. There is IAM Identity Center, and there is AWS organizations. More about Identity Center and organization later on. But if you click on IAM Identity Center, you can see or enable this Identity Center, and you can streamline your workflows user access to AWS managed applications and AWS account by enabling this instance. And you can simply enable instance of your Identity Center, enable your provider, and you can see more benefits if you go to this link. But for now, we won't do anything with our organization. And for example, this AWS organization used to centrally manage your multi-account environment and scale your AWS resources. So in the organization, you will have more than one account, but for now we have only one AWS account. You need to create an organization to manage these multiple AWS accounts. So this is some bonus explanation if you are wondering what is AWS organization and IAM Identity Center. Let's go to our users, and finally we will try to create our first user. In our access management, of course, you have user groups, you have users, and if you go inside our users, there is no resource to display. We don't have any IAM user, and as you can see, just to remind you that IAM user is an identity with long-term credentials that is used to interact with an AWS account. If you click on info, you have this more here. And of course, you can use IAM Identity Center for authentication, as I already explained. The first thing we need to do, if we want to create a new user, there is an icon. If you can see the orange icon, we need to click on Create User. So when you click on Create User, there will be a new form that we need to fill. So you need to add your username. For example, we will add user1, and this user name can have up to 64 characters, and you can see what is a valid characters for that you can use for this. Also, you can provide user access to the AWS Management Console. You can check this box or not, and your user will have the privilege to access your management console. So you can log in with that user to simplify this. You can provide your console access to a person. You can also choose your user type to specify the username in Identity Center. This is recommended. Or you can create a simple user, IAM user. I will now click on Next. And in the step number 2, you can choose to set the permission. You can add this user to a group, you can copy permission, or you can attach policies directly from here. Also, there is an optional to set permission boundary, so you can set the permission boundary to control the maximum permissions for this user. This is an advanced feature, and also you can copy, as I already told you, permissions, or you can attach one of these policies directly when you create this member. Or you can add this user to a group. We don't have any group, and you can create your group right from here. And you can see that you can use this permission boundary to control the maximum permission, for example. And this is simple access analyzer service role policy, for example, written in JSON format. If you click on console, you can see when this policy is created and when is last time that is added, and this is optional, as I already told you. If you go to Next, the step number 3 is Review and Create. You can see all user details that you specified for him or for he or she, and simple when you add a tag. If you want, you can add a tag if you want, simple key value pair or not, and simply click on Create a User and you will create a user. You can, as I already told you, add this user to an existing group, attach policy directly, or copy permissions, and that's it. It's very simple to create this user. Let's hit on Next again and click on Create User. So we have created our first user. As you can see, our user 1 is here, and we don't have any. This user is not a member of any group because we don't have any group. We are not using MFA. We are not signing to this user, but as you can see, this is our ARN. If you remember where I'm talking about, you can see what is the creation time, and console access is disabled for this user because we specified that. If you go inside our user, you can go summary for this user. What is the time when this user is created, console access is disabled, and there is an option to create an access key. More about access key later on. And you can see what is permission policies, boundary, general policy based on cloud trail events. You can see if this user part of group. You can see tags, security credentials. You can enable console access if you want. And now you can add your custom password for this user. You can use auto-generated password or add a custom password, as I already told you. And you can specify in this empty field a password. Let me add a new password for this user. This will be simple password. If I click show user, this is testing 1 2 3 4 5 6, and if you check this box, user must create a new password at the next sign in. You can check or uncheck this box. Let's click on enable control access. And if you click on this button, this user 1 will have permission to access this console signing link with this username and password that we specified. You can also download this as CSV file if you want, and if you download this and open this file, you can see our username, password, console signing URL, and this is our link. So another important and useful information. Let's click on close, and now we are able to log in with our new user. You can also assign more security measures, and as you can see, I'm now logged in with my root account, and I can also now log in with my user 1. If I open a new incognito tab and copy this signing URL, let me go back to my identity and access management. Let's go to my dashboard. I will now copy this signing URL for IAM users within my account. Let me paste it here, and as you can see, our account ID or alias is already included here, and the next thing we need to do is to add our username. This will be our user 1, and we need to specify our password for this user, and simply click on sign in, and we will be able to sign in as user 1 to our console. But remember, this user 1 does not have any permission, so if you try to do something with this user, you can't do anything. So as you can see, access is denied for any of service. You can, for example, go to IAM services remember we are logged in with our user 1, and access is denied for almost every service or action in this service in IAM or identity and access management, because just to remind you, our user does not have any permission. So you can see our account ID and IAM user. Also, there is a security credential. You can check your account, you can check your region, and you can see you can have access to see account settings, contact information, and any other information that is available to see if you have these permissions. So for now, that's it. Thank you for watching, and I will see you in the next lesson. Now that we know how to create a user in AWS, let's find out more about IAM groups. So In AWS, an IAM group is a set of IAM users that are grouped together to help manage permissions. Simple as that. Instead of assigning permissions to individual users, you can assign them to group, and all users within that group will inherit those permissions. This simplifies the process of granting access to multiple users who need the same level of access to AWS resources. An IAM user group is a set of IAM users. User groups allow you to specify permissions for multiple users, which can make it easier to manage permissions for those users. For example, you can have a user group called administrators, and you can give that group typical administrator permissions. Each user in that user group, automatically has permissions for the administrator groups. If a new user joins your organization and needs administrator privileges, you can grant them the appropriate permissions by adding that user to the administrator's user group. If a permission change jobs in your organization, if a person change from that group job in your organization, instead of editing the user permissions, you can remove them from the old IAM group and add them to the corresponding new IAM group. You can add an identity-based policy to a group of users so that all users in the group receive policy permissions. You can't identify a group of users as principals in a policy, such as a resource-based policy, because the group are about permissions, not authentications, and principals are authenticated IAM entities. In this example, if I take my pen, you can see that we have our AWS account, and this is me logged as simple user that have administrator rights. Me as an administrator, or I as an administrator, want to have a clear and perfect view. So I created a 3 IAM group. First group is admin group, second one is group for developers, and the third one is a test group for testers. All these groups have different privileges. So for example, in our admin group, Bob and Suzanne have all administrative privileges, and in our developers group, Brad, Jim, Mark, Kevin, and 2 applications have some different but least privileges. In our test group, Caddy, Alan, and Test App 1 and 2 have different privileges. So imagine that Bob no more work in the Bob is not our administrator. So Bob will need to go from this group, and Bob will not have any administrative privileges anymore. So the best way, Bob is now tester, for example. The best way to do this is to simply change the group for Bob and add Bob to this test group. So Bob will lose his administrative privileges, but Bob will be in the test group, and Bob will be inherit all privileges that we added or specified to our test group. Simple as that. And this is not only for Bob. If we, for example, add Kevin to admin group, Kevin will be inherit all admin right from this group, and that's it. So if you go to our next slide, we can see some important information. So a user group can contain many users, and a user can belong to more than one user of the group. So if you go back to our previous slide, Bob can be, for example, member of devs and test group, for example. So user group can be nested. They can only contain users, not IAM group. So you can put group in the group. That's very important to know. There is also no default user group that automatically includes all users in AWS account. If you want to have such a user group, you need to create it and assign it to each new user. the number and size of IAM resources in AWS account, such as the number of groups and the number of groups that a user can be a member, are limited. And this is the comparison between IAM role and IAM group. This is very important. So, definition for IAM role, that this is a temporary credential to access the AWS resources. IAM group is just a collection of IAM users that having the same permissions. Credential, these are not long-term credentials for IAM role, but IAM group, all the permissions are inherited from the group permissions. Usage, you can use IAM role to grant permissions to applications, services, or users assuming specific roles, but for IAM group usage is simplified to permission manager for a group of IAM users. IAM role access control you can use only for permission, and this is directly attached to the role, and permissions are attached directly to the IAM group. Example for IAM role is you can grant EC2 instance permission to access the CloudWatch logs or any S3 buckets, for example. And one simple permission for IAM group you can assign permission to junior developers in your organization for access to AWS development resources. And that's it. Let's see how can we create our first group in AWS. And now it's time to see how can we create our first user group. In the previous chapter, I already showed you how can you create a user, how can you grant a permission, how can you log in to or sign in to our console using that user credentials. So I'm now logged in with my root password, and as you can see, we have our 2 roles and we have 1 user. If you now go to our user groups in Identity and Access Management, you can see that we don't have any resource, we don't have any user group. Just to remind you, a user group is just a collection of IAM users. And with this group, you can use this group to add some permissions for a group of users or a collection of users. So if I click on create a new group, you have option to create a group, of course. The first thing we need to do is to add a name for this group. This will be group A, for example. And then you can add users directly from here to this group. Let's add our user 1 to this group. Also, this is an optional, and also optional is another feature. You can attach permissions to this, permission policies to this group right from here. So, for example, you can add or try to find read access. There is 1050 permission policies by now, and you can filter this by type if you want. You have something type of this, as you can see, all types AWS manage job functions or job manage, and you can try to search appropriate permission policy, and you can, for example, use this AWS manage job function, as you can see, used as none for now, and there is a description for every of this permission policy. If we scroll down, you can filter, as I already told you, AWS manage policies. So right from here you can have these 11 policies, and we are now adding this read-only access to this group, and our user 1 will have this user access policy. So there must be group A must be written correctly, and now it's good. So our user 1 will have only read access to this permission, and group A, you can see that we defined our permission, and you can see the time of our permission. If we when this is created, if you click on see group A, this is a summary when this group is created. You can see we have our ARN for this group A. We have 1 user that is a member of this group. And if we edit this option, you can change the name of your group, for example. Then you can see that we have user 1 that is a member of this group, if you remember. And if you go to permission, we can see that we have one policy, and this is read-only access policy. And if you go to access advisor, we don't have anything here to be shown. So just to remind you, our user 1 does not have any permission until now, because this group have only read-only access permission, and user 1 is now member of this group, so he will inherit, user A will inherit this permission from this group. So you can see we have now one user group and one user. And if we go back to our second window, we are still logged in as user A. If we want to see how this permission work, we need to refresh our page, and after some time our user 1 will have the permission to only read, for read only, sorry. So if you want to strict your user, you can give them this read only permission. If you now go to our identity and access management, or IAM, you can see that user 1 have the permission to read, and he can see all these options that we have in our identity and access management. So he can see how many resources we have in our resource group. We have one user group, one user, 2 roles, 0 policy, and 0 identity providers. So with the help of permissions, you can check, or you can add that permission to your user. If you go to user groups again and try to create a new group with user 1, we are, remember, logged in as user 1, you can go and type and try to create user group. So you can see that access denied to IAM create group, because our user 1 does not have appropriate permission. He cannot create group, he can only read user group, users, roles, policies, and so on. So this is the right approach from the security point of view. If you remember, we just added one permission for our user. If you click on Amazon Q, you can diagnose the following console error and see why is access denied for this user. If you go back to our console where I'm logged in with my root user credentials, you can see that we have only read-only access permission, and you can add or attach new policy or permission if you want, and this time we can add administrator access to this group and click on attach policy. So we are adding another permission policy. We have administrator access and read-only access policy. If you now, and this is attached to our group A, if we go back to our incognito browser, logged in as a user A, we need to refresh this page again, and now this policy will take effect. And now if you go to our user group, we can try to create a new group. We need to specify our name for this group. This will be group B, and simply click on create user group, and as you can see, group B is created because we have add appropriate permission for our user 1, or for group A, which is one member, user A. So user A now have 2 permissions. Let's try to create a new user with user 1. Let's try to create user 2. I will now click on sorry, I made a mistake. We will cancel this, and I want to create an IAM user. We can generate password, use auto-generate password, or add our custom password. Let's add our custom password for user 2, and I will uncheck this user must create a new password for the next sign in. This is recommended when you work in some production environment, but for this demonstration we will not use this option. Let's go to next, and we can add this user to group B, and finally let's create our user. If we go to our user group, you can see that we have our user 2 which is created, and if we refresh this page again, if you go to, sorry, user 2 is a part of one group, and if you go to that group, you will see that, or we can simply go back to our console where I'm logged in with my root account or root credentials, and if I refresh this page, you can see that we have our group B, which we created with our user 1. And if you go to our users, there are user 2 also. And if you go inside that user, you will see that user is member of group B, and this identity does not any permission, and that's it. If you go to dashboard, now we have two user groups, two users, and thanks to permissions, we now know how to work with, how to create a user and a group with our user 1. Thank you for watching. If you want to work with policy in IAM service, this is a very lecture for you. So pay attention and you will find out how to work with policy. But first, let's find out what is a policy in IAM service. In AWS, an IAM policy is a document that defines IAM permissions for a user, group or role, specifying what actions are allowed or denied to them on AWS resources. Essentially, it dictates what someone or something can do with your AWS account. An IAM policy is a JSON or JavaScript object notation document that specifies permissions. Policies can be reused with different services in AWS. The same policy can be assigned to different peoples and teams or groups. There are two types of policy in AWS. We have AWS managed policies. These are policies that are provided by default in AWS. They consist of commonly used services and the read and write permissions associated with them. User managed policies, in the event that a user needs a policy to meet their specific needs and use cases, then they can create their own custom policies. In the previous chapter, when I showed you how can you work with groups, we already saw some permission and policies. We have something called multi-factor authentication, and this feature is very useful if you want an extra layer of security. IAM support MFA, which requires users to provide another form of authentication, such as one-time password, in addition to their regular credentials. Granular control using policies. IAM policies are JSON-based documents that allow you to control access at a granular level. You can apply these policies to users, groups, or roles to define what actions they can take on specific AWS resources. And finally, there is something called identity federation. IAM support identity federation, which allows users outside of AWS, such as those from your organization Active Directory, for example, or some third-party identity providers, to access AWS resources without the need for a separate IAM user account. In AWS IAM, policies are the backbone of permission management. These policies determine what actions are allowed or prohibited on AWS resources, helping you enforce security and control. Policies can be assigned to IAM users, groups, or roles, and allow you to implement the principle of least privilege, allowing users to perform only the task they need. There are several types of policies in AWS IAM, each serving different purposes. The first one is manage policies. AWS manage policies are used, and these are pre-built policies created and maintained by AWS. They are designed to simplify permissions management by providing a wide range of commonly used permissions for AWS services. Because AWS manages these policies, they are regularly updated and maintained, ensuring that they follow best practices. And we have something called user-managed policies. These are custom policies that are created and managed by you. User-managed policies offer more flexibility because you can define specific permission based on your requirements. You can reuse these policies for multiple user groups or roles in your AWS environment. Then we have something called built-in policies. These policies are directly embedded in a single IAM user groups or role. They offer a one-to-one relationship, which means that politics is specifically tied to that entity. And that entity can be a simple user one, for example. While built-in policies provide granular control, they can be reused for different users or roles, making them less flexible than managed policies. And then we have resource-based policies. Unlike the first two policies, which are tied to user roles or groups, resource-based policies are directly tied to AWS resources, such as S3 buckets, Lambda functions, or SNS DEMs. These policies define which principal or user roles or services can access the resource and what actions they can perform. Resource-based policies are useful for controlling access to resources for multiple accounts. And there is something called permit limits. These are advanced policies that set limits on the maximum permissions that IAM user or role can get. Permission boundaries do not grant any additional permissions, but act as a constraint, ensuring that policies related to user or role do not cross boundaries. This is especially useful for delegating permissions to others while maintaining control over security. And very important are the fifth or five policy. This is service control policies or SCPs. SCPs are used in AWS organizations to manage permissions for all accounts within an organization or organizational unit, or OU. They define the maximum level of permissions that can be granted to any user, role, or group within accounts managed by the organization. SCP helps ensure compliance and management across multiple AWS accounts. So for this, you can use AWS organizations. Permission within the IAM policy define what actions are allowed or prohibited for specific AWS resources. The policy includes the following elements. Actions. It specifies API operations such as S3 put objects or AC2 start instances that policy allows or denies. Resources. It defines the specific AWS resources to which the policy applies, such as S3 bucket or EC2 instances. Effect determines whether an action is allowed or prohibited, denied, or forbidden. And conditions, this is optional, but an extra layer of control by specifying the conditions under which the policy is in effect. For example, restricting actions of the requester IP's address or time of a day. Welcome back. We are in our AWS console, and let's see how can we create our first policy. So now that we know what is a policy and how can we work with users and user group, we are again in our identity and access management, and let's see if we go to access management and click on policy. If you go to policies, there is 1,359 policies that is available by now. As you can see, a policy is just an object in AWS that defines permission. You can see the list of policy, and this is, as you can see, administrator access is used as permission policy for now. And also you have option to see what is the description of all policy. You can specify and create your own policies if you want, if you can find what you need. And you can add permissions by selecting services, action, resources, and conditions. You can select a service. For example, I can select S3, which stands for simple storage service. And here you can check and manually add these S3 actions. S3.star, that means that all actions are allowed. Or you can simply go to access level and choose the appropriate action from the list. You can select all or simply add some to describe jobs, write. So you have list, write, as you can see, permission management and tagging. Also, you can specify all of them or add one by one. It really depends on your need. There is also some action that you need to add before you create this policy, and you can also add more permissions, and you can create another permission in this. So you can create more permission for more resources in one permission. Also, there is an option to import policy or simply go to JSON file, and you can see that in that permission, that policy that we just created in our previous chapter, in our previous step, you can see how it looks like in JSON. Then in the next step, you need to add your policy detail name and click on create policy to create policy. So this is simple. It's very simple to create your own policy. If you go back again to create policy, we can simply go to JSON, and you can see or add, if you are good with JSON language, you can specify your own policy right here. I will now add this policy, and this policy will allow to get all object and list all bucket from our policy. You can see this is a version, this is a statement, effect is allow, and action is to get all objects from our S3 bucket, and you can list all buckets. So this is an action, and for the resource you can specify your ARN. So you need to just to add the name of your bucket, and we can specify something, for example S3 1000, and let's just add another bucket here, and /star will, it means that we can get the list for all buckets from our service. I will now save this and paste this, copy this, and paste this in this policy editor. And right on here, you can go to next and save this policy. Then you need to add your name. This is a custom policy. You can add your description if you want for this policy. Then permission defined, this policy is for S3 service. Action level is limited. You can list and read. Resources are multiple, and we don't have any request condition. So we can click on create policy, and right now we have one custom policy that we just create. If you go to filter by type, you can see that we have customer policy, and this is our custom policy. So as you can see, it's very easy to create your policy. And if you go inside that policy, you can see what is a permission, what is an ARN. You can delete this policy, you can edit this policy, you can even assign this policy to your group A, group B, or simple for your user. Let's go to permissions. You can see how it's easy to add this policy to your user, you can click on to add permission, and if you click on add permission, you can see what is the attached policy for that you already have. And if you go to attach policy, there is a customer managed policy, so we can add this policy right on here. Click on next and click to add permission, and that's it. This custom policy is added to our user, and our user now have this custom policy. We have two policy for group A and that is inherited for user 1 because this user is a member of this group. And if you go to our user A now have 3 policies, 2 by AWS created and 1 that we just created and attached to this policy. If you go to policies and filter by type, if you go to custom manage policy, you can see this is our policy, and now we will delete this policy by typing, click on delete and typing custom policy, and you can simply confirm by clicking delete. And that's it. Thank you for watching, and I will see you in the next lesson. Also, if you click on this link, one entity has been attached to this. You can see that user 2 has this customer policy, so we watched at user 1, but user 2, we gave user 2 this permission, this custom policy that we just created. You must type the right name, and we need to add one more letter, or simply copy from here and paste this, and now we can delete our policy. Thank you for watching. Policies are very, very important. So in this chapter I want to talk more about policies. In the previous chapter we already saw how can we create our custom policy, and we already know a lot about policies. But if you go to search bar and type IAM, we can go to our identity and access management, and as you can see we have more roles and policies than before. If I click on policies, you can see the list of policies that we have. We have some for Lambda, for S3 service, for S3 table policy, and this is all customer managed policy. And there is 1037 policies that is in this AWS. If you go to all types of policy, of course you can filter this policy and you can create a new one or add one created by AWS. If you go to policies, and if you go to, you already know how to work with JSON. If you go to visual, for example, and here you can see you can specify JSON, and in the visual option you can select a service, as you already know. You already saw this in the previous chapter. So we can, for example, choose our EC2 service, and right on here you can use effect allow or deny. So you can allow or deny these permissions that you can specify with certain actions, and these actions can be performed on specific resources. In this case we are using EC2 service. So you can filter some action or for allow effect, for example. I already showed you that you have access level for list, read, write, permission management and tagging. But now I want to take a deep dive on these actions. You can use all actions if you check this box, for example, and this will allow all actions. You can see the number in the brackets. There is more than 600, maybe more, actions or access levels that you can use for EC2. And this is all manual actions. And as already told you, if you check this box, all actions will be added to your EC2 instance. But this is not good, as you already know, because from this security point of view, it is good to have the least privilege access. If you go to specified ARM, for example, you can add a resource region. You can add any region for this. You can add resource capacity reservations. if you have any region, it will add a star, and if you click and check this box to any capacity reservation, it will also add a star to resource capacity reservations. And you can see that our resource ARN, Azure resource name, will be different, and our account ID will be added here. So capacity reservation slash star, it means that all actions will be allowed to this resource. But this is not very good from the security point of view, as I already mentioned. So this is a simple resource ARN that we already talked about. And if I uncheck this box, you can see that now we don't have star after capacity reservation slash, and you can confirm this ARN by adding this, and we need to check this again to confirm this ARN if you want to add this ARN. But this is only for capacity reservation. You can see if you check all, so all wildcards may be, or stars may be overly permissive for the selected actions. So you can allow specific ARNs for these services, and as you can see, it can hurt your security. Also, this allow effect is not very useful to use. So I will now uncheck these actions, and we can set action levels one by one. Just you can choose from this list any action that you need for a specific action, and you can go even more granular if you want. For example, we can add some, let me find some appropriate action from this list, and we can, for example, choose describe volumes or describe VPCs, for example. This is list access level. Then from the read access level, we can choose a different action if we need. So we can, for example, use get console output, get default credit specification. This is just a random for this demonstration. I want to show you how can you work with these actions, and then it depends. You can see that this allocate address requires one more action, and you can add receipt snapshot attribute, for example, and modify snapshot attribute if you want from here, or delete resource policy, delete anything that you need. This is just a simple example. You can see that we have now 10 policies, but you can add tags if you want. And now we have 10 access levels that will be included in this policy. So in the specific, you can specifically add ARN specifics for this one of these action if you want, and you can do it by simply using all, and if you go to next, you will create your policy. Also, you can check all policy. I will now uncheck all policies. This is the fastest way to achieve this. If you check and uncheck all permissions, it will uncheck all boxes. So we will only use this selected list of 2 selected policies. Let me again uncheck our tags, and we can now go and click on next. So you can add your policy detail, This will be again be custom policy, for example. You can add description if you want. You can see that our EC2 service access level is limited, so we are only adding list permissions to all resources. And if you click on create resources, policy, this policy will be created. So this is allow policy. So we are going now to custom manage policy. If we click on this plus sign, you can see what is the version, what is the statement, effect is allow, and action is describe VPC and describe volumes. Resources is star, so any service can access to this custom policy. Let's go again to custom policy, to new policy. I will choose again EC2, but this time we will use deny effect. You can do exactly the same, just like in previous step. You can choose one of these actions from this list. There is a lot of options or actions that you can choose from, and now we are using deny effect, just to remind you. I will use something from this rich list, and as you can see, there is a red icon which is denied. Let's again go to next. We will now add a policy name. This will be again custom policy 2. I will not choose any description, and explicit deny on EC2 service. Let's click on create policy, and if you go to filter customer manage policy, you can see that we have our custom type, and if we expand this, now we have deny effect, and action is describe local, and so on. So we have created two custom policies. One have allow and one with deny effect. If you go to our users and if you go to permissions, we can add this permission to our user. Let's click on add permission and click on add permission again. We can attach policies directly from here. We can choose from this filter by type, and we can add both of these custom policy that we just created to this user. And let's click on next and add permission. So our user one have both of this customer manage policy. One is to allow, one is have allow effect, and the second one has denied effect. And now I will remove these policies. And also, if you go to policies, if you choose filter by type, go to custom policies, customer policies, we can edit this policy right from here, and you can see in JSON how it looks like our custom policy too. You can edit this policy, and you can add more permission by choosing service, and you can also add more permission. Let me choose some different policy. If you want, you can add, for example, tagging, and simply go to next, and you can save changes, and both of these new list actions will be added to this existing policy. And now you can attach this policy role, as you can see, to user 1 if you want, and click on attach policy, and that's it. User 1 now have this permission policy, and we have two versions. Version 1 that we created first, and then we have version 2 which is now active, and we have two more deny effect and two more actions. So we have 4 actions, and the version of policy you can see if you go to policy. Now I will hit on detach, and we will detach this policy from our user 1. If you go to permissions in our policy, I will now go to customer policy, and I will now delete both of our policy that we just created. Let me copy this name of our policy too, which have our denied effect, and we will then delete the policy with allow effect. So it's very easy to, as you can see, edit your policy, to create your policy, to edit your policy, and you can play around with this and practice a little more. Thank you for watching, and I hope this was helpful, because policies are very, very important in AWS identity and access management world. Thank you for watching. Now that you know how to work with AWS policies or IAM policies, we are now looking at managed versus inline versus customer policy. Let's see what is the difference between these offers. The type of policy that you create depends on several factors, and no one type of policy is correct for all applications. The different types of policies you can choose from are internal policies, managed policies, and user managed policies. Internal policies apply where there is direct one-to-one or inline policies, relationship between the policy and the user or group. Usually internal policies are not a good choice, but there are times when you might want to use them. Managed policies are reusable and provide users with a library of well-defined and well-researched policies that they can add to roles as needed. AWS provides a comprehensive collection of policies that you can use, and users can create their own managed policies. So, inline policies. As I mentioned above, using a built-in policy should be an exception. You want to ensure a strict one-to-one relationship between the entities and the permissions defined in the policy. As you can guess, there is a strong connection between built-in policies and entities. If you delete an entity, the action deletes all built-in policies associated with that entity. If the permissions can apply to one or more entity, it is better to use a managed policy. An example where you want to choose a built-in policy would be when you want to ensure that someone does not inadvertently assign those permissions to another entity. Consider the case when an organization has S3 folders assigned to each department. The organization decides that only a specific user can grant access to each department's folders and grant them access permissions. You can create a built-in policy for an allowed user that would only grant to their user profile. Now, when we talk about managed policies, these policies are just a set of policies created and managed by AWS to make permissions management as simple as possible. To be precise, these are AWS managed policies. Instead of selecting specific types of AWS resources and available actions for that type, you can choose an AWS managed policy that meets the requirement and associate it with the user group or role. Going back to the previous example, let's say that any member of the IT management user group has read-only access to all S3 resources within the AWS account. From the user group profile page, you can click on Add Permissions and select directly associate existing policies. Next, you would see a list of AWS managed policies that can be joined by group. At the time of taking this course, AWS has more than 1,000 managed policies to choose from. You can choose one or more policies to link to an entity. The advantage of using an AWS managed policy is that the selection of specific actions on the resource has already been done throughout the review to ensure that it only grants certain permissions. Unlike built-in policy, the connection between an entity and a managed policy is through association. If you delete an entity, the policy remained as it is. And AWS has designed the managed policies to be simple and easy to apply to the full range of specific AWS resources. For a small organization, this makes sense and reduces the management burden associated with managing permissions. However, as your organization grows, you need to create more specific policies that can be applied to multiple users, user groups, and roles. Customer managed policies provide the flexibility while also incorporating many of the same benefits as AWS managed policies. Choosing the right type of policy depends on the type of permissions that you want to assign to the entity and the scope of those permissions. In some cases, a built-in policy may be the most appropriate and logical choice. However, if AWS managed policies meets your needs, or if the policy can be applied to multiple entities in your organization, then managed policies are your best option. If you go inside our console, and if you go to Identity and Access Management, as you can see, we can go to our policies, and you can see this is a policy. This is just an object, as you already know. And if we go to Create Policy, or simply go to our users, you can go to Add Permissions, and from here you can click on Create an inline policy. So right from here you can create your inline policy, and as you can see, you can add permissions by selecting services, action, resources, and conditions. Thank you for watching. Policy structure is one of the most important lessons in this set of chapters. So let's take a deep dive into structure of simple policy. If you can see, there is a simple policy, and it is now time to see what is structure of one policy, for example. So the first thing we need to know, what is a version ID? Well, version ID, let me just grab my pen. This is our version ID, as you can see. So version ID is just a required field in the policy that is uniquely used to identify the JSON policy. The second thing is statement. This just defines the license for the resource, and then we have brackets and curly brackets. In the curly brackets, there is something called SID, or statement ID. An abbreviation of ID of statement. This is a unique identifier for this statement. And then you can see we have effect. This is a field that defines allow or deny potential customer access to this resource. And then we have one very important option. This is an action. This is used to indicate which service can perform which action. If you remember, in one of the previous chapters, we defined some actions for allow or deny effect. And these actions will be displayed here. You can add one action or 100 action. And the last one is resource. This resource consists of a list of resources that are affected by policy. So you already saw an example with S3 bucket policy, and that's it. It is very easy to understand the policy structure. So AWS offers an IAM access analyzer which enhances policy checks and recommendations to optimize your policy. When creating or editing a policy, the JSON tab displays a policy validation panel below, highlighting various findings. These findings are categorized into safety, errors, warnings, and suggestions, which help you identify potential problems. You can use the information to customize your policy and resolve findings to ensure improved security and compliance. Also, IAM Access Analyzer helps users to manage and control who can access AWS services and resources. The Access Analyzer is used to detect and mitigate unwanted access by providing in-depth insight into the permissions on your accounts. Users can set up Access Analyzer for their account by turning on Access Analyzer policy. Once activated, your account becomes a trusted zone of the analyzer, and now the analyzer can track all resources and services within the trusted zones of their analyzer. If you go inside our console again, as you can see, we are in Identity and Access Manager. There is a new Access Analyzer that is available. So Access Analyzer, as you already know, analyzes internal access patterns to your critical problems. If we click on that link, we are now in our analyzer, and this will simplify your journey. How it works: you can create an analyzer to monitor your external, internal, and unused access patterns across your AWS environment. Then you will review your findings. IAM Access Analyzer automatically identifies access patterns across all your AWS environment, and it's detecting both internal access from outside your trusted zone and internal access. Then it will display an action, and in this action you can activate or archive the findings so that you can focus on reviewing active findings. But I must warn you that this is not a free service. If you go to Resource Analysis and Unused Access and Analyze Settings, you can see the whole list of findings here. If you go to Create Analyzer, you can choose from here. You can choose from Resource Analysis, External Information, and so on. And if you go back to our policies, when you create a policy, if you go and expand this policy, you can see how it looks like. This is Access Analyzer Service Role Policy, and you can see that all resources have access, and this is an action for all services in AWS. Thank you for watching. Well, it's time to know what is IAM roles. This is a very, very important topic, so I hope that you will stay for this explanation. In AWS, IAM roles are entities that define permissions for trusted identities to access AWS resources. They are similar to users, but they are designed for temporary access and are not associated with long-term credentials like passwords or passkeys. Instead, roles provide temporary security credentials that can be used by AWS users, services, or federated identities. So, with IAM roles, you get temporary credentials. Roles grant access through temporary security credentials which rotate automatically, improving security. There is no long-term credentials, so unlike users, roles do not have passwords or access key attached, which reduce the risk of compromised credentials. Trusted identities, roles are taken over by users within or between accounts, AWS services, or federated identities to gain temporary access to resources. Also, there is a centralized permission management, so with roles you can simplify permission management by providing a way to grant access to different entities without having to manage individual users' credentials. There is a few types of roles. First, we have service roles. These roles are used by AWS services to access others' AWS resources on your behalf. For example, an EC2 instance can take on the role of a service to access an S3 bucket. Service-related roles, a special type of service role that is associated with a specific AWS service and is created and managed by that service. We have multi-account roles. These roles allow users or services in one AWS account to access resources in another AWS account. Also, there is a federated identities. IAM roles can be taken over by users who are authenticated through an external provider like SAML or OpenID Connect, and we have IAM roles anywhere. This service allows non-AWS workloads to take on IAM roles and access AWS resources using X.509 certificates. The role of the service is taken over by AWS service. When creating a new of these, you can specify which AWS service you want to take on this role, and then assign the permissions that the service would have when it takes over the role. The most well-known example of a service role is the IAM role in the EC2 instance profile. When an instance is configured to assume a role at runtime, applications running within the instance can perform any actions on any AWS services that role allows. These are AWS managed roles that are associated with specific AWS services, and you can assign them a very specific predefined set of permissions for use in very specific use cases. The permissions policies that apply to the role associated within the service are immutable. One example is the role taken on by an autoscaling service, which grants it all permissions needed to perform autoscaling actions on all AWS services that support autoscaling, for example. As the name suggests, multi-account roles allow entities like users, application, etc. in one AWS account to take an IAM role in another AWS account in order to access resources in that account. An account that contains AWS resources that are being accessed is called a trusting account, and an AWS account that contains entities that need access is called a trusted account also. They are so called because the confidential account trusts the entities in the confidential account. And why is good to use IAM roles? Because it offers improved security. Temporary letters of credit reduce the risk of long-term disclosure of credentials. Simplified access management. Roles simplify permissions management, especially for services and multi-accounts access. You can use improved auditing, so rules allow for better tracking of who accesses resources and when, and it reduces operational cost, or OPEX. Rules eliminate the need to manage long-term credentials for many entities. Welcome back again, and we are again in our console, AWS console, and we will see how can we work with roles. As you can see, I'm in my IAM dashboard. We have two roles. If you remember, those roles are created when we created our account. If you go to roles, there is also this AWS service roles and AWS service role for trusted advisor. You can delete these roles, but this is default roles and it is recommended that you don't touch these roles. Also, you can see roles anywhere, that you can access AWS from your non-workloads. We have this X.500 standard and so on. If you go to our AWS support service role policy, and if we edit our roles, you can see what action this role support. This analyzer, it is a really extreme long JSON document. Also, you can see what trusted relationship is using. This is our second role, and if you want, you can create your role, and you can use temporary credential, of course. You can see what is the date of the creation of this role. This is the date when I open my AWS account. This is the ARN for this role, and maximum session duration for this role is 1 hour. Of course, you can edit this role, and this is a role description, as you can see. Also, last activity of this role, you don't have any details about, because we don't use this role for now. And there is also what is role. If you go back to our role, you can search a role if you have more than 10 or 100 role. You can use search option. Also, you can create your own role if you want. Role is very important, just like policy. And if you click on this button, orange button, you can see that we have trusted entity. This is our step 1. So we have AWS service. It allows services like EC2, Lambda and others to perform action in our account. Then we have AWS account. It allows entities in other AWS account, as I already mentioned in theoretical part of this lecture, or some third party to perform action in this account. We have web identity. It allows users federated by the specified external web identity provider to assume the role to perform some action in this account. For example, we have SAML 2.0 federation, and you can create a custom trust policy to enable others to perform action in our AWS account. And right below this trusted entity type, we have an AWS account. As you can see, we are still learning about trusted entity type. As I already told you, we can choose to log in with Amazon, Amazon Cognito, Facebook, or Google. In the SAML 2.0 federation, you can choose to allow users to use this federated SAML 2.0 from some corporate directory to perform some action in this account. So you can add a role to some external users, for example. And you can, of course, create a trust policy by using JSON files. I will use the first one and choose my EC2 service. You can choose from a list of service. EC2 is one of the most used service. And right here, when you choose your service or use case, you can choose a use case for a specific service. You can choose EC2, for example, to allow EC2 instances to call AWS services on your behalf. You can use something called EC2 role for AWS System Manager, EC2 spot fleet role, EC2 spot fleet role autoscaling, EC2 spot instances, and so on and so forth. But the most used use case is this EC2 Elastic Cloud 2 that will call some AWS service in your behalf. So imagine if you have some virtual machine and that machine needs to talk with some other AWS services, so you will use this role. Let's click on next, and now we need to, in the step number 2, we have to choose some permission policies, and I will use this IAM read and only access. This provides only read access to IAM, as you can see, and we will hit on next. So exactly the same policy we used with our user one. If you remember. And now this time we are using our EC2 instance. We are creating a role for that instance. So we need, in the step 3, we need to add a name, to see a review, and to click on create. We will use EC2 role. For example, this will be your role name, and description is automatically added. This allows EC2 instances to call AWS services in our behalf. So this is a trust policy, as you can see. You can copy this policy and you can see how it looks like. And permission policy, you can see this is our policy name. You can add the tags if you want. This is an optional. Let's add, for example, EC2, and as a value we will add Linux, for example. Let's click on create role, and we successfully created our first role in AWS, as you can see. So now we have 3 roles. The first two, is created by AWS when we create this account, and the third one is created by us. And if you go inside that role, you can see that what permission policy is added. We have one tag, what is a trust relationship, and as you can see, we can attach up to 10 managed policies. You can also set a permission boundary if you want. You can generate policy based on CloudTrail events, but more about this in the later part of this course. So we have 1 attached entities. And that's it. This is how can you create a role in AWS Identity and Access Management for EC2 instance. And you can see that you can edit this maximum duration time for this role by clicking edit. If you go to trust relationship tab, you can see that entities that can assume this role under specific condition, you can edit this trust policy. It is also written in JSON, and this is our tags. You can see where is last access, and not access in the period for now. And also you can revoke your session if you want. And that's it. There is a lot of options when it comes how to work with role, and you can see how it looks like to revoke your session. If you choose to revoke active sessions, IAM attaches an inline policy named AWS revoke older session to this role. So this policy denies access to all currently active sessions for this role. It is really a great feature. So if you go click to edit, you can see that you can change your name for role description, and you can edit your maximum duration. You can add some custom duration or use 1, 2, 4, 8 and 12 hours, which is defined by AWS. And if you click on save changes, you can actually add a time for maximum duration, session duration of this role. And if you click on delete, you will delete this role. AWS has a default password policy for IAM user that requires password to be at least 8 characters and contain a combination of uppercase letters, lowercase letters, numbers, and or non-alphanumeric symbols. Users can also create a custom password policy with stricter requirements, such as a longer minimum length, for example 14 characters, or password reuse limits. The IAM password policy does not apply to the AWS account root user password or IAM user access keys. If the password expires, the IAM user cannot log into the AWS Management Console, but can continue to use their access keys. When you create or change a password policy, most of the password policy settings are applied the next time your users change their password. However, some of the settings are applied immediately, like when the minimum character length and character type requires change, these settings are applied the next time your users change their password. Users are not forced to change their existing passwords, even if the existing passwords do not comply with the updated password policy. When you set a password expiration period, that period applies immediately. For example, let's say you set the password expiration for 90 days. In this case, the password expires for all users whose existing password is older than 90 days. These users are required to change their password the next time they log in. You can create a lockout policy to lock a user out of an account after a certain number of failed login attempts. Let's go to our console to see how can we work with password policy. Once again, we are in our identity and access management in our AWS console, and if you remember, we were talking about password policy. And if you go to access management account settings blade, there is a password policy, and you can here configure your password requirements for your IAM users. As you already know, this account uses the following password policy, as you can see, and you can see there is also security token service. So this is used to provide trusted users with temporary security credentials that can control your AWS resources. But more about security token service in the later part of this course. And this is our endpoints, active endpoints, if you see. But if you scroll up again, we have global endpoint and United States, North Virginia, always active endpoints. If you go to our password policy, as you can see, right now, the minimum password policy for my users is 8 characters by default, and password strength include a minimum of 3 following mix of characters: uppercase, lowercase, numbers, non-alphanumeric characters. And other requirements, you can see never expire password and must not be identical to your AWS account name or email address. This is our policy, our password default, our password policy, and now we can edit this policy. We already saw when we added our password to our user 1, for example. If you go to the right side of our screen, of our AWS, we can actually edit this policy. So, there is a lot of options that you can add to this default and change this default password policy. Let's click on edit, and as you can see, we have two types. We have IAM default, this is our default password requirements, and we have our custom password requirements. If I click on custom, you can change the password minimum length from 6 to 128 characters if you want. Then you can change this, for example, to 12, to 14, and so on. And you can check this box for password strength. For example, you can require at least one uppercase letters from the alphabetic Latin alphanumeric alphabet A to Z, one lowercase, required one list number, required at least one alphanumeric character. And then you can have other requirements. You can turn on password expiration. You can check box if you want to have password expiration requires administrator reset, so your admin needs to approve this reset, and you can allow users to change their own password or prevent password reuse. So you can choose between these two or four options, but you must choose custom password policy. And once that you finish with the settings, click on save changes, and this password policy will take on effect. But I will click on cancel. I am satisfied and happy with my currently default password policy. In one of the previous chapters, I already told you about service control policy. In the next couple of minutes, we will take a quick look at service control policy. So in AWS, a service control policy, or SCP, is a type of organizational policy that allows you to manage permissions in your AWS organizations. It acts as a protective fence, controlling the maximum permissions that IAM users and roles in your organization can have. Service control policy help you enforce consistent security and compliance standards across multiple AWS accounts. What is the purpose of this policy? So, SCPs define the maximum permissions that can be granted to users and roles within your organization's account. They do not grant permissions themselves, but limit the scope of what can be done. Scope: SCPs are tied to the organizational units, or OUs, or individual accounts within an AWS organizations. They apply to all orders within the TNC or a specific account. So we need to have more accounts, and AWS organization required to use service control policy. How it works? Service control policy are based on the AWS Identity and Access Management, or IAM policy language, and are JSON documents. They can be used to create whitelist, explicitly stating what is allowed, or blacklist, explicitly stating what is blocked. They have centralized control. So SCPs provide a centralized way to manage permissions across the organizations, ensuring consistency and reducing manual effort. If you're following this course in sequence, then you already know what is multi-factor authentication, or MFA. But this was lecture in Azure part of this part of the course. We are now talking about MFA in AWS. So let's first learn what is an MFA in AWS. AWS multi-factor authentication, or MFA, is a security level feature that adds an extra layer of protection to your AWS account by requiring users to provide two or more forms of identification or identification. This helps protect your account and resources from unauthorized access, even if its user password has been compromised. Here's how MFA works in AWS. We have two or more factors. MFA requires users to provide not only their username and password, something they know, but also another factor, such as a code from an authenticator app, or their phone or a security key, something they have. Improved security. By requiring the second factor, MFA makes it significantly more difficult for unauthorized people to access your AWS account, even if they manage to obtain the user password. So you need, the bad actor need access to your phone, but your phone is right behind you. IAM and root users. You can enable MFA for both IAM users created within your AWS account, and the root users of your AWS account. So everybody can have MFA, you as a root user, and 1 or 100 of users that you created in your IAM. So we have IAM Identity Center, AWS Identity Center, the successor to AWS Single Sign-On, has a multi-factor authentication enabled by default for all users, which require a factor in addition to the username and password. For IAM users, you can enable MFA through the AWS Management Console or AWS Console by opening your IAM user security credentials and assigning the MFA device according to the AWS documentation. For root users, MFA for the root user of your AWS account can be enabled through the IAM console according to the AWS documentation too. For IAM Identity Center users, MFA is enabled by default and requires users to enroll their devices. When you enable MFA for a user root or root user, it only affects their credential. IAM users in an account are different identities with their own credentials, and each identity has its own MFA configuration. So this is very important to know. Your AWS account, or you as a root user, and IAM users can register up to 8 MFA devices of any type. Registering multiple MFA devices can provide flexibility and help reduce the risk of access being interrupted if the device is lost or malfunctions. You only need one MFA device to log into the AWS Management Console or create a session through the AWS CLI. MFA adds additional security that requires users to provide unique authentication from the AWS-supported MFA mechanism in addition to their login credentials when accessing AWS website or services. So, to secure your AWS identities, you must follow these recommendations for MFA authentication. AWS recommends that you enable multiple MFA devices for root AWS account users and IAM users in your AWS accounts. This allows you to raise the security bar in your AWS account and simplify access management for users with high privileges, such as root users of an AWS account. You can register up to 8, as I already told you, MFA devices by any combination of currently supported MFA types. With the root user of your AWS account and IAM users. With multiple MFA devices, you only need one MFA device to sign in to the AWS Management Console or create a session to the AWS CLI as that user. The IAM user must authenticate with an existing MFA device to enable or disable an additional MFA device. In case of a lost, stolen, or inaccessible MFA device, you can use one of the remaining MFA devices to access the AWS account without performing the AWS account recovery process. If an MFA device is lost or stolen, it should be separated from the IAM principal with which is connected. Using multiple MFAs allows your employees in geographically dispersed location or those working remotely to use hardware MFA to access MFA without having to coordinate the physical exchange or a single hardware device between employees. Using additional MFA appliance for IAM principles allows you to use one or more MFAs for everyday use, while maintaining physical MFAs appliances in a secure physical location such as a vault for backup and redundancy. As you can see, you can use authenticator apps. This is a popular option. It includes Google Authenticator, OT, and Microsoft Authenticator. Hardware security keys. These are physical devices, often USB keys that can be used for authentication. And you can use web authentication or web authn, WS3. W3C, standard that allows strong authentication using public key cryptography, often used for passwords. Let's go to our console and see how can we enable MFA. If you go to our IAM dashboard in our console, you can see that I'm logged as my root user, but security recommendations is red. I don't have MFA enabled. If I go to security, my credentials, I can assign my MFA. If I go to users and go, for example, to user 1, I can go to security credential, scroll down. As you can see, I can add MFA for this user. You can use MFA for multiple users. Let's go to my root user. I will click on security credential, and we are in my security credential. I'm logged in as my root user, as you can see, and I will click on assign MFA. The first thing I need to do is, as a step 1, to add my device name. I will add something like my phone, and after that you can use exactly the same policy as you already know, and then for naming, of course, policy, and then in the MFA device you can choose a device option. You can choose passkey, security key, authenticator app, or hardware TOTP token. I will choose my authenticator app and click on next. Then in the next step I need to add a virtual MFA device as an application that running on my device that I can configure by scanning a simple QR code. So I need to install a compatible application such as Google Authenticator, Duo Mobile, or OT app on my mobile phone or device. I have two phones. I have iPhone and I have Android phone. This time I will use my Android phone. As you can see, if you go to our AWS Amazon features, MFA, there is virtual authenticator app. We have options for Android and for iOS. We have exactly the same. We have Twilio OT Authenticator, Duo Mobile, Microsoft Authenticator, Google Authenticator, and Symantec VIP. For iOS, I have Twilio OT Authenticator, Duo Mobile, Microsoft, Google, and Symantec VIP. I will choose for Android Twilio OT Authenticator, and I will click on this link. This link will prompt me to Google Play, and I will click on install Twilio OT Authenticator on my phone. Just to remind you, let's click on install. For now, I'm using my Android phone. I need to add my password for this. To log into my Google account. And finally, this will install Twilio OT Authenticator to my phone. Of course, when you download this authenticator, you need to set up your AWS account, and it's very easy to set up your AWS account on Twilio OT. And after that, once that you install your authenticator, you will be able to access your account. So let's be patient and wait until Twilio OT Authenticator install on my phone. I can show you this, but application is already installed and I'm logged in. So I'm now adding my credentials to my Twilio OT app, and these credentials are credentials for my AWS account, of course. And if we are patient enough, we will be able to see but Authenticator is very good. Authenticator if you are not using Azure, for example. For Azure, I use my Microsoft Authenticator, and it is of course recommended to use Microsoft Authenticator because Azure is Microsoft product after all. So you can secure all your accounts with Twilio Authenticator. You can access from anywhere, everywhere, with multiple devices, and of course you can access to your cloud. Now that we installed Twilio app, I will click on show secret key, and now I will choose my QR code on this page, and then I will use the app to scan the code. Alternatively, you can add your secret key. Now we need to type 2 consecutive MFA codes below. I will first enter the first one, 381878, and I will now wait for 30 seconds and enter a second code entry. This is the number that I'm getting from my Twilio app. This second MFA code. This is a secret key. If you don't want to use your QR code. And finally, I will now enter my second code entry, 099935, and let's click on add MFA. And just like that, we are adding our multi-factor authentication for my root account. As you can see, type is virtual. This is our identifier. Certifications are not applicable, and this is the date when this created. So you can register up to 8 MFA devices of any combination, and with your AWS account, root, and IAM user. So this is how can you create and work with MFA in AWS. How can you enable MFA for your root account? Of course, you can do this also for your user. And now, if you go and try to sign in to my account, with one of the users, we can go and show my credentials. I can go to some different browser. Let me copy this signing URL code. This is our account alias. I will add my username, account, and username and password, and we will be able to log in. Let me try to sign in as a root user. I will now add my email address, and then I will need to add these characters to show that I'm not a robot. Let's click on that. Captcha was incorrect, so I must type this again. And finally, I will add my password for my root user. I'm signing as a root user. And finally, you can see that we now need to add our MFA code from our OT app that we just installed on our phone. So I will again use my phone and OT app, and I will add this code. (084)361, and click on sign in, and I will be able to sign in as a root user in other browser to my existing AWS account. So it's very useful and easy to set up MFA for your root and IAM user. Thank you for watching. There is another authentication methods in AWS, access key for CLI and SDK. In the next couple of minutes, we will learn more about these methods. So, AWS access keys consisting of an access key ID and a secret access key. that are used to programmatically access AWS services through the AWS CLI and SDKs. These keys are associated with an IAM user and act as long-term credentials. They provide secure and convenient access to AWS resources by signing API requests. So, how can access key work with AWS CLI and SDK? With AWS CLI, AWS Command Line Interface or CLI uses access key to authenticate and interact with AWS services through commands in your terminal. AWS SDK is just the AWS Software Development Kits or SDK, also use access keys to authenticate and allow applications to programmatically interact with AWS services. Authentication for both the CLI and SDK use access keys to sign API requests, ensuring that your interactions with AWS are secure and authorized. Access keys are created for IAM users in the AWS Management Console. So, it is crucial to keep your access keys safe. AWS recommended that you download them as a CSV file and store them in a file-safe location, on some storage, for example. For the security side, AWS strongly advises against using IAM users and access key for development or when dealing with sensitive data. Consider using federation with IAM Identity Center or other identity providers or enhanced security. Best practices is to avoid using persistent access key for production workloads. You can explore many alternatives such as temporary security credentials or federations for enhanced security. And the most important thing is to rotate your access keys regularly to reduce the risk of compromising them. Let's hop to our console to see how can we work with these authentication methods. If you go to documentation page of docs.awsamazon.com, you can use this guide to install or update the latest version of AWS CLI. So you must download CLI version to your local machine and you must follow these instructions. You can do it for Linux, macOS or Windows. I'm using my Windows OS on my local computer. So there is a detailed explanation how can you run your AWS CLI and how can you install this in your machines. We will now use this link to download our CLI, and let's click on this link to download and run AWS installer, MSI installer for Windows 64-bit. Let's click on download. I will now double click on this link, click on run, and let's install and accept the terms. Click on next, install, and very soon our AWS command line interface version 2 will be installed on my laptop. It's pretty straightforward installation and it does not require any special knowledge to install this. After you finish with this installing, click on finish. And now we will go to start menu and find command prompt. Let's find my command prompt. I will run this as an administrator. And once that we are logged in, I can now go to AWS and -- version to check my version of this CLI. As you can see, we are using the latest version of AWS CLI that is just installed on our computer, on our local laptop, if you want. Now, I want to run AWS IAM lists, and I want to list all users that I have in my IAM. As you can see, this is this is the list of services, but we need to run IAM list and users, and as you can see, it is unable to locate credentials. We need to configure credentials by running AWS configure. So let's run AWS configure, and we need to add our AWS access key. But where to find AWS access key? Let's go to our dashboard. I'm logged in as my root user. And I will go to security credentials. Let's go to access keys, and let's click on create access keys. Of course, you can go to users and go to user 1, for example, go to security credential, and you can add exactly the same access key for your simple user. You can choose your use cases. I will choose command line interface, and I will check this confirmation, and let's click on create access key. Step 2 is optional, and here we're getting our access key and our secret. I must warn you that this secret will available only now. If you go from this page, this secret will not be able, you will not be able to see this again. I will now copy my access key and secret access key to my clipboard, to my CSV file, and I'm now able to download this CSV file, and you can see my secret access key and my secret access key password, access key ID, and secret access key. Of course, when you're watching this demonstration, this secret will be deleted, so it is available only now. I will now copy my AWS access key here in my command prompt, hit enter, let me copy again access key. Let's go again to our command prompt, and finally let's hit on enter. And now we need to add our secret access key, AWS secret access key. Let me copy this secret access key and paste it here. Hit on enter. You can add default region if you want. I won't add any region. I won't add any default output format, and that's it. If you now go to AWS IAM users list dash users, we will be able to see all our users in our IAM. This is user 1 and user 2. You can see that we have user 1 ID, what is his ARM, when is created, and password last used. Of course, we are not logged in with our user 2, so we don't have this password last use, and we have all this in our JSON format. So you can see it's very easy to use our AWS CLI, and you can do very good and security good things for your environment. If we scroll down, you can see that for user 1 we have our access key and when is last active and so on. Thank you for watching. When you're working with identities or groups or users or applications in AWS or Azure, it really doesn't matter. You must follow the rule of principles of least privileges, or POLP. So, the principles of least privileges is a cybersecurity concept that requires users, programs, or devices to have only the minimum level of access and permissions necessary to perform their assigned task. By limiting access, the principal reduces the potential damage from accidental errors, insider threats, or security breaches, as an attacker or malware would have a much harder time spreading or causing damage if they compromise an account with limited privileges. It applies to all users, including humans and non-human entities like applications and devices. What is the key aspect of the principle of least privileges? Restrict access. It ensures that users only have the permissions they need for their job functions, and nothing more. For example, a marketing manager does not need access to the software development environment or payroll data. It minimizes the attack surface. By limiting privileges, the principle makes it harder for attackers to exploit vulnerabilities and use hacking tools that rely on elevated permissions. It contains threats, of course. If a user account is compromised, a threat like malware is contained within the limited resources that account can access rather than spreading throughout the entire system. It applies to all entities. The principle is not just for human users. It also applies to machine users like devices, bots, and software applications. It also requires ongoing management. Privileges should be regularly reviewed and adjusted as role changes. Temporary elevated access should only be granted when necessary and revoked immediately after use. So, principle of least privileges is very, very important when you're working with identities. As I already told you during this demonstration of Enter ID and AWS, when you work with IAM roles, for example, or IAM permissions, or if you work with Azure role-based access control or Enter ID roles, it is very, very important once again to take this principle of least privileges and to have assigned to your users only the minimum level of access and permissions that is necessary to perform their assigned task. So take care of this and everything will be fine in your environment. Thank you for watching. Now that you know what is Azure PowerShell and Cloud Shell, let's see what is AWS Cloud Shell. So AWS Cloud Shell is a pre-authenticated shell or a browser-based shell that allows users to manage their AWS resources directly from the AWS Management Console. It simplifies interactions with AWS services by providing a command line environment with pre-installed tools such as AWS CLI and SDK, eliminating the need for on-premises installation and configurations. You can use AWS CLI commands using your preferred shell such as Bash, PowerShell, or Z shell, and you can do it without downloading or installing a command line tool. You can run AWS Cloud Shell from an AWS console, management console. The AWS credentials you use to sign in to the console are automatically available in a new shell session. Because AWS Cloud Shell users are pre-authenticated and you don't need to configure credentials when interacting with AWS services using AWS CLI version 2. We already saw how can we install our CLI version 2. The shell environment is pre-configured with support for several leading software languages such as Node.js and Python. That means that, for example, you can run Node.js and Python projects without first executing installation and runtime. PowerShell users can use the .NET Core runtime. While with AWS Cloud Shell, you can use up to 1 GB of persistent storage in each AWS region at no additional cost. Non-volatile memory is located in your home directory, and is private to you. Unlike ephemeral environments, resources which are recycled after the end of each environment session, the data in your home directory remains between sessions. The AWS Cloud Shell environment and its users are protected by specific security features. This includes features such as IAM permission management environment session restrictions, and secure pasting for text input. As an administrator, you can assign and deny permissions to AWS Cloud Shell users using IAM policies. You can also create policies that specify specific action that users can perform with the environment. Inactive and long-lasting sessions are automatically stopped and recycled. Securing bounding is enabled by default. This security feature requires you to verify that the multi-line text that you want to paste into the environment does not contain malicious script. You can customize your AWS Cloud Shell experience to suit your preference. For example, you can change the screen layouts, multiple tabs, the display text size, and switch between light and dark interface themes. The session restore functionality returns session that you have started on one or more browser tabs in the Cloud Shell terminal. If you refresh and or reopen recently closed browser tabs, this feature continues the session until the shell stops due to inactive session. To continue using your button, click any key in the terminal window. Session Restore also returns the latest terminal output and running processes in each terminal tab. AWS Cloud Shell is an AWS service that is available at no additional cost. However, you pay for other AWS resources that you run using AWS Cloud Shell. We go back to our console and click on this icon. It will open Cloud Shell, as you can see. So we are creating an environment, and there is a few seconds for AWS to create our terminal. And then we can add command against this terminal. If I click on action, you can see that we are using US East 1 environment action. You can add a new tab, split this into rows, split into columns. You can upload file, download file, restart, delete, or use some global action, for example. Then, if we, for example, click here, it will open in a new browser tab. And if you click on this little cog, you can set up your preferences for font size, choose your Cloud Shell DEM, enable save paste, or simply Amazon Q inline suggestion that will display command suggestion as your type when using Z shell, for example. And then you can click on confirm to confirm these preferences. And you can click on cancel, of course. Then in Cloud Shell we can run some commands. For example, if I type AWS IAM list dash users, that we already saw how can we list our users from our different environment. And then, as you can see, we are getting exactly the same result, and this result is displayed in our Cloud Shell in JSON format. So it really doesn't matter if you're using your Cloud Shell CLI and some other program on your local computer, or using Cloud Shell, the AWS commands will interact with your resources. So this is just a simple explanation how can you use Cloud Shell in AWS console. Let's see another example how can we use Cloud Shell. If I go to my Identity and Access Manager, let's go to users, and I will now create a new user, or simply we can use our user 1 if we want. But for this I will now first check permissions. We don't have any permissions for our user 1, and we don't set any permission in boundary for now. If I scroll up and go to groups, you can see that we don't have any security credential, and we don't have any tag for our, or MFA for our user 1. So user 1 is a simple user without any permissions or security credentials. I will now go to my Cloud Shell. So as you can see, I'm logged in as a root user, and we are waiting for the environment to run. Our environment is ready, and we are able to work with Cloud Shell. But this is me as a root user, as you can see. I want to enable console access to user 1. So I will add custom password for user 1. I will add my password. Click on enable console access. And we will use this console sign-in URL and username and console password to log in with this user in our incognito mode browser or in new private window. I will now add my username. As you can see, our account ID or alias is automatically added because it is included in our link. I will add the user 1 and password for user 1 that we just added and click on sign in. As you already know, our user 1 does not have any permission or roles, so he can do nothing or he can do much. But if I click on Cloud Shell icon, you can see we are not able to create environment because our user 1 does not have permission for that. And I want to add a permission for my user 1, so let's go to permission, and here we will click on I want to go to policies first and choose my Cloud Shell full access, or you can simply check this policy and you can see that action is Cloud Shell and effect is allowed for any resource. So we will add this policy to our user 1. Let's go to actions and click on attach, and we will attach this to our user 1. Click on attach policy, and after some time policy is attached and is to entity user 1. If you go inside our user 1, let's go to security credentials, you can see that, to permissions, you can see, let me just refresh this page, and you can see that we have our AWS Cloud Shell full access. So let me go back to our private window where we logged in with our user 1, and now we will sign out and again sign in with our user 1, so that this policy or permission can take full effect. Let's click on again sign in, and once again we will provide our username and password for this user and click on sign in. Just to remind you, we don't use any MFA or passkey, so access key, so it is very easy to understand what we are doing. Now we don't have any permissions for any other resources, but we have permission for Cloud Shell, so we can connect to our Cloud Shell and we are connected to our terminal. So with our user 1 we can now take the full advantage of Cloud Shell, and we can, for example, type exactly the same or some other command. We can type, for example, AWS console and add our access key, our secret access key, or using our AWS ls to list all services that is available to us in this console. As you can see, ls is a list, and we can work with our Cloud Shell and take the full advantage of our with our policy, of course. And that's it. This is how can you add a policy and work in Cloud Shell with user 1. I will now remove this policy and go to our users. So let me check my user 1. And as you can see, we don't have any policy in place. Thank you for watching. Now it's time to know what is Access Advisor and Credential Report. AWS Identity and Access Management Access Advisor is a feature that helps you optimize user and role permissions by providing visibility into which AWS services are accessed and when. It helps you identify unused permissions, allowing you to refine your policies for better security and cost management. Access Advisor helps you understand how users and roles use their assigned permissions by showing which AWS services they accessed and when they last accessed them. Analyze this information about last access to services for IAM users, groups, roles, and policies. Benefits of Access Advisor is reduce attack surface. By identifying unused permissions, you can remove them, reducing the potential attack surface of your AWS environment. Also, there is enhanced security. Minimizing permissions to only what is needed improves the overall security posture of your AWS account. Also, there is a cost optimization. Excessive permits can sometimes lead to unnecessary cost. Identifying unused services allows you to optimize your cost. Also, there is a policy refinement. Access Advisor helps generate targeted and more accurate IAM policies, ensuring that users and roles have the right level of access. On the other hand, you can view the latest access information for IAM policies in the IAM console or programmatically using the AWS CLI or SDK. Integration with AWS organization. So Access Advisors can be used with AWS organization to set permissions restriction across the whole organization. And this allows you to manage permissions at scale and ensure consistent secure policies. In AWS, a credential report is a detailed CSV file, separated value file, that provides a comprehensive overview of the security status of IAM users of AWS accounts and their associated credentials. It lists all IAM users and the status of their various credentials, including passwords, passkeys, and multi-factor authentications or MFA devices. This report is a key tool for monitoring security and compliance, helping to identify potential vulnerabilities and monitor credential usage. What it contains: IAM user information. It lists all IAM users in your AWS account. Credential status. For each user, display the status of their credential, such as passwords, whether the password has been set and when it was last changed. Access keys. Whether the access keys are active or inactive and when they are last used. MFA devices. Whether MFA is enabled for this user. And report format. The report is usually in CSV format, which makes it easy to analyze in tools such as Excel. If you go to our console again, and if you go to our security and access management, you can see that we have our security recommendations as a root user, and as a root user we don't have any active keys, but we have MFA. If you go to credential report, you can download your credential report, for example, but there is no report created in past 4 hours, and new report will be created, of course. The credential report is just a simple list of our IAM users in this account, and the status is about various credentials. If you download this, you can see that we have 2 users, and we have the name of our user, we have our Azure resource name, when the user is created, password is true. So in these columns you can see what is the password, is supposed MFA, is there any active access key, and so on and so forth. So when the key is last rotated, and other features and information. So credential report is very, very useful if you have, for example, more than 100 or thousands users in your AWS account, or if you're using AWS organization, you can see how many. It really depends of how many users you have, there is this report, and this report is located on Wednesday in June, of course. And then if you go to organization activity, you have something called organization, but our account is not a member of an organization. In some of the previous chapters, I already talked about AWS organization. So if our account is a member of that organization, then we can see all organization activity here. Also, in the access report, you can see that you have service control policies, and we already talked about service control policies, and of course, resource control policies are also part of AWS organization. So just want to show you that we have also these settings here. If you go to users and go to our user 1, for example, we can go to we can see, of course, our permission policies, and we can see that our user 1 is still member of group 1. We see that we don't have any security credential, and we have one access key, if you remember. We don't have any SSH public key. We don't have any Git credentials for AWS code commit, and so on and so forth. And if we, for example, go to last access tab, we can see all information about our user 1, and last access information shows the services that this user can access and when those services were last access. So you can even see that in your reports. So you can see that this user was active with read-only access. This is policy granting permissions. For example, AWS Identity and Access Management, and we are using this user also use AWS Organization, Amazon EC2 service, and so on. So you can filter services by access history, and for this also, this is a very, very common tool to see the activity of your users. So you can go even more granular with this. Now it's time to see what is IAM Access Analyzer. AWS IAM Access Analyzer is a security tool that identifies and helps you manage access to your AWS resources, including finding resources that are shared externally and identifying unused access. It uses automated reasoning to analyze IAM policies and resource-based policies to detect potential security vulnerabilities, helping you achieve the principle of last privilege. What is the key feature of this service? Well, external access analysis. It identifies resources like S3 buckets or IAM roles that are shared with external AWS accounts, public entities, or even other principals within your organization. It uses unused access analysis. It continuously monitors IAM users and roles for unused access keys, passwords, and permissions, helping you to identify and remove permissions that are no longer needed. Also, it validates IAM policies or policy validation against their grammar and AWS best practices to ensure they meet security standards. And also, it can generate fine-grained IAM policies based on observed access activity from AWS CloudTrail logs. How it works? You can first create an analyzer. You can create an analyzer in a specific AWS region for a single account or an entire organization. Then this service continuously analyzes policies and resources configuration to find potential issues. It generates findings that can be reviewed in AWS Management Console and then even sent to Amazon Event Bridge for automated workflows or used to support compliance audits. And also you can take action. After reviewing the findings, you can take any action, such as refining policies, archiving findings, or deleting unused resources. And finally, the last chapter or lesson in this part of this course, We will talk about IAM best practices. So, AWS IAM best practices focus on securing access to your AWS resources by adhering to principles such as least privilege, multi-vendor verification or MFA, and regular security audits. These practices help minimize the risk of unauthorized access and data breaches. So, the first one is least privilege. I was already talked about least privilege. So you can assign only the necessary permission for each user or role. You can avoid granting too broad permissions. Use the IAM access analyzer to identify and remove unused or excessive permissions. Regularly review and update your permissions to ensure that they are in line with current needs. Also, you can use multi-factor authentication from multi-vendor verification. You can enable MFA for all IAM users, especially those with administrator privileges. MFA adds an extra layer of security in addition to passwords, making it harder for attackers to gain unauthorized access. Also, you can use to secure root user credentials. Never use the root user account for everyday task. Securely store root user credentials and use them only for account and service management task. You can create separate time users for day-to-day administrative tasks. Then we have number 4, you can use IAM roles. Use IAM roles to grant temporary access to AWS resources instead of long-term access keys. Roles can be assigned to users, application, or services. Also, you regularly rotate your credential regularly. Rotate access keys and password regularly to minimize the impact of potential compromise. Use temporary credentials with an expiration time to improve security. Implement password policies. You must implement strong password policies for all users. Require complex passwords and regular password changes. Use user managed policies. Create user managed policies to define specific permissions instead of using AWS managed policies. This allows for more granular control over access. Then implement a zero trust security model. You need to assume that no user or device can be trusted by default. Regularly check and authenticate every access request regardless of the user background. Number 9 is regularly review and revise IAM policies. Periodically review IAM policies just to ensure that they are still relevant and effective. Use tools like AWS Cloud Trail to audit user activity and identify potential security issues. Use AWS Organization and AWS Identity and Access Management Identity Center. AWS Organization allows you to manage and multiple AWS accounts within a single organization. I said so many times. And IAM Identity Center, the successor of AWS Single Sign-On, provides a central place to manage user access to multiple AWS accounts and applications. By implementing all these best practices, you can significantly improve the security posture of your AWS environment and reduce the risk of unauthorized access and data breaches. So, just to remind you, all of these 10 best practices we saw in some examples or labs. So, use these labs as a starting point for these best practices. Thank you for watching. A virtual machine is a software-based emulation of a physical computer that runs its own operating system and application using a portion of the physical machine resources. This allows multiple isolated virtual machines to run on a single physical server, which improves resource utilization, enhances security through isolation, and makes it easier to test and develop software. How it works. A physical computer, called the host, runs virtualization software that creates and manages one or more guest virtual machine. The virtual machine borrows resources like a CPU, RAM, and storage from the host machine to function like a standalone computer. Each VM is isolated from the host system and other VMs, So if one crashes or encounters any kind of problem, it doesn't affect the others. When a VM is shut down, the hardware resources it was using are returned to the host machine. So, host and guest shared resources isolation ED allocation is a must-know. Then, what are the key benefits? Increase efficiency. You can consolidate multiple virtual servers on the single physical server to use the hardware resources more efficiently. Also, there is a cost-saving benefit. It reduces the need for physical hardware, which can lower cost for power consumption, cooling, and space in data center. VM can be created, deployed, and managed easily, and resources can be allocated on demand to meet changing needs. So you have a lot of flexibility and scalability about your image size. Enhanced security provides isolated environments, which is ideal for testing potentially risky applications without endangering the host system. And also disaster recovery options. It offers better backup and recovery options because the VM state can be saved and restored easily. And on my local laptop, I have two virtualization programs. One is Hyper-V Manager, and it is official Microsoft program for virtualization. As you can see, I already have few VMs, and you can create a new VM. I have VM1 based on based on Windows Server 2025. I have VM2 Ubuntu and VM3 based on Debian. All these virtual machines are shared. My laptop is a host system, of course, and you need this Hyper-V Manager to run this, to virtualize your virtual machine. And in this program, in this manager, you can create virtual machines. So, as you can see, this is my 3 virtual machines based on 3 different OS images. And now, if I want to run some of these computer or VMs or instances, they will use my CPU, memory, and disk space for my laptop. And the other one is Oracle VirtualBox. So you can create a new VirtualBox, and if I want, I can start and run my virtual machine based on Ubuntu VM. As you can see, it is powering up, and it's very easy to run my Ubuntu virtual machine, and it also uses the CPU VM for my VM, of course, memory and graphic. After some time, this Ubuntu VM will be up and running, and you can, as you can see, you can, for example, with Ctrl-T run this. Ctrl-Alt-T, you can run your terminal, and now you can, for example, run sudo apt update to update my system, but I need to add the password for this VM. I know my password, so I will add my password. As you can see, just like that, we are downloading packages, official packages from Ubuntu server, and as you can see, 167 packages are downloaded, and it is available as you can see, if I want, I can install now. Let me run, for example, sudo apt full upgrade and dash yes, and here it is. it is downloading, and then it will install all necessary packages from my Linux system or for available programs that run on my VM. As you can see, I have few programs and I can run this program right from here. So this virtual machine is on my local laptop, but it runs like a normal Ubuntu OS or virtual machine. So this is, for example, on premise. This is not in the cloud. This is on my laptop. I will now finish this demonstration, and here I just wanted to show you that you can, for example, go to files and you can see what files do you have on your system. You can run terminal, you can browse if you want with Firefox, you can open sites, you can do anything, everything what you want, just like in your normal VM or your normal laptop. And here it is. You can see after downloading it, necessary packages is finished. We are updating our system, so this is now installation progress or process, and after that I will simply restart my virtual machine on my laptop, and then this machine will be updated. Thank you for watching, and I will see you in the next lesson. Containers and virtual machines, or VMs, are two approaches to packaging computing environments that combine different IT components and isolate them from the rest of the system. The main difference between the two is which components are isolated, which in turn affects the scope and portability of each access. A container is a unit of software that contains all the components and functionalities needed to run an application. Most modern applications consist of multiple containers, each of which performs a specific function. Containers are typically measured per megabyte and do not use a hypervisor, and are generally considered a faster, more agile way to handle process isolation. One of the most important factors to contribute to the success of the container is portability. Similar to the interconnection of Lego bricks, the individual containers can be easily swapped and moved to different environments. Once an application and its dependencies are packaged in a container, it can be deployed whether or wherever it is needed. For example, a developer or administrator laptop, a data center, the cloud, or the edge, with the expectation that it will function exactly the same. Docker is an open source platform for building, deploying, and managing containers application, has played a major role in the evolution of container technology over the years. Virtual machines play a key role in the cloud computing, mimicking physical computers and running operating systems in isolated instances. Multiple VMs are typically hosted on a single server, with a hypervisor acting as a lightweight software layer positioned between the physical host and the VM. This hypervisor efficiently manages access to resources, allowing virtual machine to function as different servers while offering improved flexibility and agility. It initially gained popularity in the 2000s due to its consolidation and cost-saving initiatives, and the use of VMs has evolved over time. Organizations have matured their VM implementations, expanding beyond consolidation to embrace different use cases. This includes providing on-demand resources for application and optimizing access to expensive resources such as GPUs. VM also served as the foundation of many early cloud computing environments, facilitating resource virtualization and supporting more release and isolation, that is, more client running systems that share the same resources. Virtual machines contain their own operating system, allowing them to perform multiple resource-intensive functions at the same time. The increased resources available to VM allow them to abstract, share, duplicate, and emulate entire servers, operating systems, desktop, databases, and networks. The real question is how virtual machines work and how container works. Software called hypervisor separates resources from their physical machines so that can be shared and dedicated to VMs. When a user issues a VM instruction that requires additional resources from the physical environment, the hypervisor forwards the request to the physical system and caches the changes. VM looks and acts like a physical server, which can multiply the disadvantages of application dependencies and large operating system footprints, a footprint that is generally not required to run a single application or microservice. Everything inside the container is packaged and sent using the container image, a file that includes all libraries and dependencies. Container images files are similar to software installation packages such as RPM in Linux, but those that only need a compatible kernel and container execution time to run the application, regardless of which OS was used to create the container or where the libraries within the container originated from. Because the containers are so small, there are usually hundreds of them loosely connected together, which is why container orchestration platforms such as, for example, Red Hat OpenShift and Kubernetes are used to secure and manage them. There is a few useful programs that can you help to create a virtual machine on your laptop. One of them is Oracle Virtual Box Manager. So if you want, you can create your simply VM, but first you need to download the image and then you need to create your virtual machine. I will not go to the process of creating a VM. I just wanted to show you that I have these VMs here. One is VM1, this is Ubuntu VM, and I have the second one is Ubuntu server. If I, for example, click on this VM and click on start, this VM will power up, and as you can see, after some time it will starting to boot our device with this Linux operating system, and after some time I will be able to log in to my VM with my username and password, and as you can see, I'm able to work just like this is a real VM. So I can, for example, run a terminal from here and then run some command to update my system, and this is how it works. So as you can see, with the help of this Oracle VirtualBox, I can create my VMs. You can create virtual machine based on Windows image and based on Ubuntu desktop image, or for example Windows Server. Let me try again just to show you how it looks like to update your virtual machine, which is of course separated and isolated from your Windows operating system. Of course, I run this Ubuntu virtual machine on my Windows laptop. Also, I run some of my virtual machines on my macOS. So this is how can you install work with your virtual machines. Also, you can update your machine, work like this is a normal VM. Thank you for watching, and I hope this was helpful. Now it's time to see what is compute in AWS. In AWS, computing refers to the processing power, memory, and other resources needed to run applications and workloads in the cloud. It includes virtual machines or instances, containers, and serverless functions that execute your code and process data. Essentially, it's the foundation on which your applications are built and run in AWS. AWS Compute Services is a game changer for businesses that want to scale applications without the hassle of managing physical hardware. AWS offers core infrastructure such as processing power, memory, and storage, enabling enterprises to seamlessly run applications and handle cloud workloads. Whether you're deploying virtual machine servers, managing containers, or using serverless computing, AWS Compute provides solutions for every use case. Compute is essentially the power used to run applications and processing tasks. It includes key resources like processors, RAM, and storage to help execute budgets and manage data. In the cloud, computing refers to renting virtual resources, such as virtual machines or containers, to run your applications without having to manage the physical hardware yourself. Computing resources are the basic components of system. They allow it to run applications and process data. These resources are essential for everything from performing everyday tasks to more complex processes. The main computing resources include CPU. This is a central processing unit. Think of CPU as the brain of the computer. It handles all the processing, executes the instructions, and performs the necessary calculations to keep the applications running. Then we have RAM, or random access memory. And RAM is the short-term memory of a computer. It stores data that is actively being used or processed, allowing the CPU to access it quickly and efficiently. Storage refers to the place where data is stored for a long time. It's where your files, apps, and even your operating system are located. Storage can be in the form of traditional hard disk drive, HDDs, faster SSDs, or cloud storage. And then we have networking. Network resources are systems and paths that allow data to be transferred between computers, devices, and applications. They also connect everything and allow data to be communicated. And we are using a lot of cloud virtualization resources, virtualizations that allows us to run applications in isolated environments such as virtual machines, or VMs, or containers, or shared physical hardware. In the cloud, these resources can be easily provisioned, scaled, and managed, giving businesses the flexibility to customize resources based on their needs. Essentially, they are the backbone of modern computing, enabling everything from simple applications to complex systems. AWS Compute Services is practically the backbone of cloud computing, helping companies to get the most out of the cloud without having to deal with all the headaches of legacy infrastructure. These services are the main ones for running applications, processing data, and handling workloads, but without the hassle of hardware maintenance. With things like Amazon EC2 service, which provides you with virtual machines, or AWS Lambda, which is a serverless. It basically runs code without worrying about the server. AWS has option for all sorts of needs. Whether you need consistent performance or the ability to scale things when needed, they got you covered, of course. As more and more businesses move to the digital world, AWS Compute Services is becoming the obvious choice. They streamline operations, reduce cost, and facilitate rapid adoption and innovation. AWS Compute Services refers to a set of cloud solutions provided by Amazon Web Services that provide the necessary power, memory, and infrastructure needed to efficiently run applications, process data, and manage workloads. Instead of managing hardware or data centers, AWS Compute Services allows customers to run and scale their applications in the cloud, providing flexibility, scalability, and cost effectiveness. AWS Computing Services span a wide spectrum, meeting the needs of a variety of applications. For traditional workloads, EC2 instances offer customizable virtual machines. Container-based applications can use ECS or AKS for efficient management and deployment. Serverless computing with Lambda technology eliminates the needs for infrastructure management, making it ideal for event-driven workloads, and AWS also provides edge computing solutions like Outpost or Wavelength. Also, there is a hybrid cloud options like Snow Family, VMware Cloud, and AWS to extend AWS capabilities to on-premises environments. So, key AWS compute services are Amazon EC2. It provides virtual machine instances to run applications. AWS Lambda allows you to run code without managing servers. AWS Elastic Beanstalk simplifies the deployment and management of web applications. Amazon ECS or X to run and manage containers. AWS Fargate run containers without managing servers or clusters. And AWS Batch for batch processing of large amounts of data. In the previous chapter, I already mentioned something called EC2 service. But before we dive deep into this service, let's see the theoretical part. Amazon Elastic Cloud, or EC2, is a web service offered by Amazon Web Services, or AWS, that provides variable computing capacity in the cloud. Essentially, it is a virtual server in the AWS cloud that allows users to lease computing resources such as CPU, memory, storage space, and network resources. EC2 allows users to deploy and manage applications and services without having to invest in physical hardware upfront. Variable computing capacity, so EC2 allows you to adjust the amount of computing resources like CPU, memory, storage space, etc., allowing to your virtual server as needed, making it scalable for different workloads and traffic patterns. Also, EC2 instances are essentially virtual machines that runs on Amazon physical servers. You can choose from different types of instances optimized for different workloads. Also, EC2 is Infrastructure as a Service offering, or IaaS, which means you are responsible for managing the operating system, applications, and other software on a virtual machine, while AWS manages the underlying infrastructure. Also, EC2 offers several benefits, including cost saving by eliminating the need for upfront hardware investment, increased agility by enabling a rapid deployment and scaling of applications, and improved security with a variety of security features and options. EC2 is used for a wide range of applications, from running simple websites and web applications of hosting complex machine learning models and big data processing tasks. EC2 also integrates with other AWS services such as Amazon S3 for storage, or Amazon RDS for databases, or Amazon VPC for networking, providing a comprehensive cloud computing environment. EC2 is an abbreviation for Elastic Compute Cloud, a service provided by Amazon, and this is a complete on-demand computing service on the AWS cloud platform. It allows you to rent a virtual machine to run your applications, and just like in Azure, you only pay for what you use. Instead of buying and managing your own servers, EC2 gives you a virtual machine where you can run websites, applications, or even big data tasks. You can choose how much memory, storage, and processing power you need and stop them when you're done. The EC2 offers the security, reliability, high performance, and cost-effective infrastructure to meet demanding business needs. You can deploy your applications on EC2 servers without worrying about the underlying infrastructure. Configure your EC2 instances in a very secure way using VPC, subnets, and security groups. You can scale the configurations of an EC2 instance that you have configured based on the requirements on the applications by adding an auto-scaling group to the EC2 instance. You can also scale, increase, and decrease an instance based on the incoming traffic of the application. Here's the example how to use EC2. First, you will use application deployment. In an AWS EC2 instance, you can deploy your applications such as .jar, .var, or .ir application without maintaining the underlying infrastructure. Then, the second step is to application scaling, when you deploy your web application in an EC2 instance, you know that you can scale your application based on the demand you have by scaling an AWS EC2 instance. Then you can use, for example, for machine learning model implementation, you can train deploy your ML models in an EC2 instance, as it offers up to 400 gigabytes and storage service purpose built to optimize cost and performance for ML projects. You can use this service for a hybrid cloud environment. You can deploy your web application in an EC2 instance, and you can then connect to a database that is deployed on your on-premise servers. It is a cost-effective service. So Amazon EC2 instance is cost-effective. So you can deploy your gaming app, for example, in Amazon EC2 instance. And also, there is a different type of Amazon EC2 instances that are designed for specific activities. You can consider the unique requirements of your workload and applications when selecting an instance type. This can include computing, memory, or storage needs. Also, there is a different type of AWS EC2 instances, and we have general purpose. It provides a balanced resources for a wide range of workloads. It is suitable for web servers, development environments, and small businesses. Example of these instances is T3 and M5 series. Then we have instances optimized for computing or compute optimized. It provides high performance processor for compute intensive applications. It will be ideal for high performance web servers, scientific models, and batch processing. Examples for this instances are C5 or C6G series. Then we have memory optimized instances, and this is high memory to processor ratio for large data sets, ideal for in-memory databases, real-time big data analysis, and high performance computing or HPC. These instances are, for example, R5 or X1E series. Then we have storage optimized instances. It provides optimized instance resources for high sequential access to read and write to large data sets, best for data storage, Hadoop, and distributed file system. Examples are E3 or D2 instances. Accelerated computing instances. It provides hardware accelerators or co-processor for graphic processing and parallel computations. It is ideal for machine learning, gaming, and 3D rendering. Examples of these instances are P2 and G4 series. And EC2 provides its users with a true virtual computing platform, where you can use a variety of operations and even run another EC2 instance from this virtual created environment. This will increase the security of virtual devices. Not only creating, but EC2 also allows us to adapt our environment to our requirements at any time during the lifetime of the virtual machine. Amazon EC2 itself comes with a set of default AMI or Amazon Machine Image options that support different operating systems along with some pre-configured resources such as RAM, ROM, storage space, etc. In addition to these AMI options, we can also create AMI curated with a combination of default and user-defined configurations. And for future purposes, we can save this user-defined AMI so the next time the user won't have to reconfigure the new AMI or Amazon Machine Image from scratch. Instead of this whole process, the user can simply use an older reference when creating a new EC2 machine. Amazon EC2 includes a wide range of operating systems that you can choose from when choosing AMI. Not only have these options been chosen, but users have also been given the privilege to upload their own operating systems and opt for them when selecting AMI during EC2 instance startup. Currently, AWS has the next most popular set of operating system available on the EC2 console: Amazon Linux, Windows Server, Ubuntu Server, SUSE Linux, and Red Hat Linux. Also, Amazon single-handedly rules the cloud computing market due to a variety of options available on EC2 for its users. It allows its users to choose from a variety of software available to run on their EC2 machines. The entire service is assigned to the AWS Marketplace on the AWS platform. A number of software such as SAP, LAMP, Drupal, etc. are available for use on AWS. AWS gives us ability to scale according to needs. All dynamic scenarios can be easily solved using EC2 with the help of this feature. And because of the flexibility of volumes and snapshots, it is very reliable for its users. Due to the scalable nature of the machine, many organizations such as Flipkart and Amazon today rely on it whenever there is a huge amount of traffic on their portals. EC2's calculation per seconds means that you only pay for the exact time of the calculation you use, down to the seconds. There is no need to pay unused minutes or extra time, making it a more cost-effective option for short-term tasks or workloads that are dynamic in nature. Welcome back, and now it's time to see how can we create our first instance based on Linux image in AWS. But first, let's try to sign in to our console as a root user. As you can see, this is our front page, and I have an option to access my account by using root access or I'm user. I will add my email address because I want to run this demonstration by my root credentials. So the first thing I need to do is to add my email address, and of course after that we will see more about EC2 service. But first, let's understand that you as a root user, if you remember, are responsible for all tasks and you have unrestricted access to this account. Let me add my email address. I will click on next. Then I need to provide these characters as shown in this picture. So this verification will say that I'm not a robot. And finally, I will add my password for this account, for this root user. And finally, I will add MFA code from Twilio app. And this code is 254, and let's sign in. Let me try again. I guess I misspelled my password, so I will again add my password just to correct this. And of course, once again, I will add my MFA code from my phone, 677010. Let's sign in, and once again, we are signed in as a root user in our management console. And you can see after some time there is a recently visited site. So the more you work with your AWS, the more services will shown here as a recently visited. You can go to EC2 instance or service, or simply type EC2 and click on this link to go to your EC2 service. Of course, this is you have something called EC2 image builder. This is a managed service to build and customize your OS images, and in global view you can see dashboard and more information about your EC2 instances. Let's click on EC2, and because this is the first time we are running this service, we don't have any instances or virtual machine here. If I scroll down in our main page, we can see some additional actions link. You can open a new window with EC2 pricing, and you can check all your pricing here when it comes to instances. And there is really a lot of information, so you can find more about pricing if you go to this page. And of course, on the left side of this screen, we have a link or blade called instances, and as you can see, there is also instances type. There is more than 200 instances type, So you can check what type you want, and now there is a more. You can find the resources by attribute or a tag, and you can use instant type finder by instance type, CPU, architecture, memory, storage, and so on. So there is really a lot of options that you have when you want to find the proper instance type. You can see what is the on-demand Windows pricing, for example, and for Linux instance types. If you type, for example, we'll click on this search bar, you can see more options, and now you can use this free eligible options, free tier eligible, and as you can see, we can find, for example, all free eligible virtual machines that is offered to us. You can also choose by architecture or type micro 2 t2.micro. This is a free virtual machine, free tier, and that's it. Also, there is a lot of options here. We will take a deep dive in the later part of this course, but if you go to images, there is an AMI, something called Amazon Machine Images, and there is a catalog for these images. The first is Quick Start AMIs. You can find official AMIs by, for example, AWS, Linux, for macOS. You can filter this result by architecture, by OS, and you can see there is a various Linux distributions. Also, there is a Windows Server 2025 based image, and you can see that is free eligible for us. Then you can select a proper image. There is a lot of images 2022-2019. Also, you can create your own Amazon images. As I already told you, you can filter by OS, by architecture. You can create your own AMIs. There is also AWS Marketplace AMIs. You can find these AWS Trusted Third-Party AMIs in the next tab. But here, when you create your AMI, it will be shown here in this section. And AMI is just a template that contains the software configuration, as I already told you in some of the previous chapter, like operating system, application server, application, and so on. So you can select AMI provided by AWS, by community. You can buy some image from marketplace, and here you can see what is the publisher. And if you check Amazon Web Services, this is official web images or AMI images by Amazon. And of course, you can clear this filter and search for anything else. In the community AMIs, you can find a lot of AMIs, but created by community members. But there is an option, and these images are the paid one. So you need to pay if you want to use these images in your community AMIs. So as you can see, we have something called Elastic Block Store, network and security, and so on. But if you go to dashboard, this is our dashboard, and you can see all. This is our global view, of course. This is ECT free tier, and you can see what resources are we currently have. We have only one security group, and this security group is added by default when you create this account. Of course, this is for United States, North Virginia region. If I scroll down, you can see service health. You can launch instance from here. You can migrate server if you want. Then there is a lot of 6 AZs or availability zone, and this is our security group. Security group is nothing but a simple firewall for your virtual machine. Something else you already saw in Azure when I talked about network security group, for example. So this is some similar service but in AWS. But just to mention once again, I don't want to compare this to cloud and these services. Just to have a better understanding what is a security group. Of course, in the later part of this course, we will talk more about security groups. If you go inside your security group, you can see that we have one inbound rule and one outbound rule by default. There is something called sharing, and this is VPC association. You can see your tag. Of course, this is the default security group, and it is attached to our default VPC. As you can see, this is our VPC ID. We have one permission entry and one permission entry for inbound rules and for outbound rules. If I finally go to instance types, you can find instance types that we already saw this option. But if you go to instances, as you can see, we don't have any instance right now. So you can check this instance state. There is a lot of action that you can run from here. And if you type launch instance, you can simply launch instance from template, migrate server, or simply launch instance. So it really depends what you want to do, but you have an option, and that is a very good thing. If I click on launch instance, we are now in this wizard, and we need to add some things to launch our instance. As you can see, AWS automatically recommends to take a walkthrough because AWS knows that we recently created our account, so it offers us a simple walkthrough. You can click on that link if you want. But if you go to launch an instance and go to name and tags, I can add a name for my instance. This will be vm1_Linux. You can add the tags if you want, and if you scroll down, you can use quick start image. This is our OS images, Amazon images, and you can see we have Amazon Linux, macOS, Ubuntu, Windows, Red Hat, SUSE Linux, or Debian. And there is, of course, more if you want. You can browse for more if you want. Then, after that, if we choose our Amazon Linux, we can choose our image type. As you can see, this is a free eligible tier, and we can use this Amazon Linux 2023, and this is a very good image. So we are using our 64-bit architecture. You can choose between this and ARM, and this is a verified provider. And then we need to choose something called instance type. In the instance type, you will choose the size of your virtual machine. I will be mostly using this t2.micro. This is a free eligible VM, and this is T2 family with one vCPU and 1 GB of memory, and you can see the pricing for this machine. But this is a free eligible machine, and if you scroll down, you can choose whatever image you want, of course, just like in Azure. Then we need to specify our key pair login. You can use this key pair to securely connect to your instance. If you do not have any, this is a required, of course, for logging. If you don't have any key pair, you can create one. Simply click here, create a key pair, add a name for your key pair, choose your key pair type, and you choose between RSA, encrypted private public key, and this encrypted private public key ED2559. And then in the private key format, you can use .pem or .ppk. You can use .pem for OpenSSH, and you can use .ppk for PuTTY. This is a private key file format, just to remind you. We'll use this .pem extension, and we'll use OpenSSH, and when you hit create key pair, this key pair will be created and automatically downloaded to your local machine, of course. So this is how can you create a key pair, as you can see, and this is our key pair. Of course, I will now click and open this just to show you how it looks like, but it is a very good, from the security point of size, that you do not open this key and do not show to anyone. This is your key. Then we have something called network settings. In the network settings, we need to provide our network, our subnet. You can choose to assign auto-assigned public IP address. You can use firewall security groups, and you can create a new security group or select existing resource security group. We have one default security group, just to remind you, and you can see if we go to the list of our region, just to remind you that all this is provided by AWS. So we have default VPC, default security group, default subnet, and so on. I will now choose my security group. This is my default security group, and then you can also create your new security group. You can allow HTTP traffic, allow HTTPS traffic from internet, allow SSH from anywhere. This is 0.0.0/0 is from internet, for example, and that's it. So with the help of security group, you can limit your traffic. Also, you can choose from anywhere custom IP address, or you can add your custom IP address. This is from your local laptop. This is the public IP of your public IP address. And then we can configure our storage. As you can see, by default, we offer 8 gigabytes of GP3 root volume with 3000 IOPS input out per seconds, and this storage, this volume is not encrypted. You can select between general purpose SSD, GP3, GP2, and more about disk later. Also, there is an advanced option, but as you can see, free tier eligible customers can get up to 30 gigabytes of EBS general purpose. Of course, you can add a new volume, so this VM will have two volumes, and that's it. This is the most important thing when it comes to virtual machine. There is also, you can add your file system if you want, but in the advanced details you can set more options. You can join this to some domain, you can set an instance profile, you can choose your DNS hostname, create a new IAM profile, use hibernate behavior, shutdown behavior, and so on. In the next set of chapters we will look some of these options, but for now I will leave everything as it is, so I will not use any of this option. And if you scroll down, there is a really lot of options that you can use, like capacity reservation, and that's it. Also, you have this license configuration, and if you scroll down, you can add a file or upload a script if you want to use something called PostScript deployment. So if you remember, we already saw how can we add this in Linux. This is a simple bin bash script, and I will now paste here, and this will update our system, install HTTPD, and it will start our engine. This is simple Apache server, and this message is coming from our IP, and we will get this message when we create this machine and copy public IP address in the new browser. We will get this message from our VM. And in the summary, you can see that we have one instance based on Amazon Linux 2023 AMI. We are using t2.micro instance type. We are creating a new security group and one volume of 8 gigabytes. And finally, we are using a free tier. In our first year, I'm getting 750 hours per month of this family, T2 micro family. And anything else, all information you can see. Now let's click on finally launch instance, and we are launching our instance. And that's it. Our instance is successfully initiated and launched. So if you click on view all instances, we are automatically go to our instances, and if I refresh this page, you can see that our VM1 Linux is here and instance state is pending. So we need to wait for this machine to be created. Of course, you can change the name of your VM. As you can see, instance state is now running. This is our instance type. Status check is still initializing. You can set alarm status here. Our availability zone is US East 1A. This is our public IP address. This is our DNS public. We don't have any elastic IP. We don't have IPv6. Monitoring is disabled. We are using new security group. This is our key pair, the launch time, and platform is Linux, Unix. So this is our first VM based on Linux system. If you check this box, you have some more information about this virtual machine. You can check what is instance ID. You can see your public IPv4 address, private IP address, hostname type, what is your subnet, what is your VPC, and all other information, just like in Azure. So there is a really lot of information that you can see in your details tab. And then if we copy our public IPv4 address, you can also check your status, monitoring, security. As you can see, there is a lot of graphic that are used to see recommendations about to see metrics, about metadata, CPU utilization, network in, network out. This is a security. You don't have any IAM role for this VM, and this is information about networking, storage, and if you want, you can add or see your tags. Let me open now a new tab, and I will copy public IPv4 address, paste it here, and you can see this is our message that coming from our IP address, and that's it. This is how can you add a script when you create your virtual machine, and how can you create your virtual machine. This is our script. And if I now go to dashboard in the EC2 global view, if I refresh this page, you can see that now we have one instance that is running, we have one volume, we have one instance, we have one key pair and two security group. If you remember, the first security group is default and the second one is that we just created with this VM. Of course, if I click on connect, or you can see first our instance state, you can stop instance, reboot or terminate or delete this instance, and in the action you have there is a bunch of settings that you can use for the instance setting, networking, monitor, image, templates, and so on and so forth. And we can now click on reboot this machine, and this machine will be rebooted. As you can see, we are getting this message that we successfully initiated rebooting of this VM. Now if you refresh this page, you can see that our machine is up and running again, and you can open again this address and you will get exactly the same message that we are getting from here. But because we are rebooted our machine, we do not get this message, because now we have different address. And that's it. This is how can you use and create your first VM in or instance in your AWS service. This was a long and very detailed demo, but if you click on connect, you can connect to your instance. You can use this instance EC2 instance connect, and you can, as you can see, this is our username. This is our default username. You must use this EC2-user. If you try to add some different name, let's add something like AWS user, and if you try to connect, you can see that it is failed to connect to your instance, because you must use this default option, default username to connect to your virtual machine. If I try again to connect, and this is, as you can see, EC2 user, we can use, of course, session manager, SSH client, or serial console. And if you use this EC2-user and try to connect now, you can see that we are successfully connected. So this is a must known username if you want to connect to your VM. Now let's try to update our system. So I will run sudo yum update -y. This will download all the necessary packages for this virtual machine. This is complete. Then the next, I want to run how much I have on my hard drive, how much space, with df-h command. As you can see, I have 8.7 gigabytes on this drive for now, and let me try to check my Nginx status. Sorry, we are using HTTPD. This is we are not installing Nginx, we are installed Apache. So sudo systemctl status HTTPD. Let me paste this, and as you can see, service is active and running, and it is enabled. We are using Apache HTTP server. And finally, if we run another command, you can see how much memory and CPUs are using this service. And if you run systemctl list -units -type service, we will see the list of active services on this machine. Let me paste it here, type and enter, and this is the whole list of active services that is running on our VM right now. There is a lot of, as you can see, this is stopped by me. And if I type Control X, you can exit, or Control C, you can exit from this command. And finally, let's curl and check our IP of this Amazon public IP. This is good for debugging. Let me copy and paste it here. And if you run this again, let me click on enter, this is our public IP address of our virtual machine. As you can see, this is our public IP address, and also in the bottom of your screen you can see the public and private IP address of your VM. And if I go to actions, to instance state, I can now stop my VM, and this is how can you stop this instance. And you can see that our instance is in stopping state. Let's see now how can we create a Windows VM or instance based on Windows VM image. As you can see, I am in my EC2 service. We have one instance from previous chapter. This is our VM1 Linux, and this machine is in stop state. And now I want to create a new instance, based on Windows image. Let's click on create a new instance. I will add a name for my instance. This will be VM2 underscore Windows. And then for the OS image, I will choose Windows. I will choose exactly the same image machine or AMI. This will be Microsoft Windows Server 2025 base image. And we must use, as you can see, this is the images that is offered to us. And I will use this one, based server. And our username is administrator. This is very important. And finally, we will choose our instance type as T3 micro. I will use exactly the same key pair, and in the network settings we will allow HTTP and HTTP traffic. Of course, we are using the default network or VPC, and as you can see, our storage is now 30 gigabytes. This is our root volume, GP3, and in advanced details we can add, if we want, some file, but I won't add anything because I want to create a simple instance based on Windows Server 2025. So the number of our instances is 1, and let's click on launch instance. So if you remember, we are now using T3.micro because we need more CPUs and memory to run this OS. Let's click on launch instance. And our instance is launched and finished. If we now go to our instances and refresh our page, you can see that we have two virtual machines. VM1 Linux is stopped, and VM2 based on Windows is running, but it's still initializing. If I check the details of this machine, you can check what is the instance ID, public IP, private IP address, what is our instance type. We are using default network or VPC. We are using, of course, network security group, and you can see this is our storage, and it is attached to this VM. Of course, there is also a lot of graphic for monitoring. And if I now refresh again this page, you can see that our machine is still initializing, but if I go to connect, there is now 3 options to connect to this VM. I will choose my RDP client, and you can choose to connect using RDP client. And if you click on get password, we need to wait at least 4 minutes after launching on an instance before trying to retrieve the auto-generated password. So if you go again to our instances, you will wait for this machine to be initialized, and we will then try to connect again, let's go to connect. As you can see, we have session manager and EC2 serial console, but let's go to RDP client because this is a Windows based machine. You can use this is our instance ID, of course. We will use connection type connect using RDP client. We can download this remote desktop file. As you can see, this is our windows.rdp file, and the most important thing that if you click on password, you will now use this password, and then you can upload your private key here. So if I click on private key, let's go to our download folder and add this key pair file here. This is our private key pair, if you remember, and let's click on decrypt password, and that's it. This is how can you get your password here. And now if I open my download folder, username is administrator. Let me open my file explorer. I will go to my download folder and double click on this RDP file that we just downloaded. Click on connect, and here I must now provide my username and copy this password. Administrator is the default username, and I will now copy this password and paste it in our RDP client. Paste it here and click on OK. And let me try again. I will now provide again this password and paste it here and hit on OK. Let's click on yes. And we are successfully logged into our Windows Server 2025. So now we need to wait for this machine to boot up. And if you remember, when we were working in our Azure, we are now see our VM. But if you want to your virtual machine run faster, then choose a different instance type. I choose t3.micro, and you can choose T4, for example, and this virtual machine will be faster. But as you can see, this is our desktop, and we are waiting for our machine to boot up. We are waiting for Server Manager to load up. So I will leave the whole process so that you can see actually how it runs on AWS. So the most important thing is to use this administrator username, and after you upload your private key pair from your laptop or desktop machine, you will be able to retrieve your password, and you can copy this password to log in to your RDP. With your RDP to your instance. And we are now waiting for our Server Manager to boot up. And you can see that we are successfully once again logged into our VM. And if I go to Start menu, you can click on Server Manager, and this Server Manager will look exactly like this. We need to wait for this manager to completely load up or finish loading, and after that we can click on Add Roles and Features and install what we want, some role or feature. I will try to install IIS, Internet Information Services. You already saw how can you add this role when we worked with Azure VM. Let me now just check our local server. This is our computer name, this is our workgroup, and you can see the all other information about this VM. So you can assign your IP address if you want, and you can also click on enhanced security, and you can turn this off if you want to run Edge, for example. Then we can finally try to add roles and features. I will now click on roles and features, and let's click on next. We will again use role-based or feature-based installation. Let's click on next, again next, and finally we will choose Internet Information Services. This is a little slow because this machine does not have many vCPUs and memory, so we are running server 2025, but you must be patient if you want to see how it looks like. Just to mention again that if you want to use a faster machine, you must use a different family type with more vCPUs and memory. Finally, after some time, we can select our role. I will use web server IIS, and click on next. Of course, you can use any role if you, whatever you need. And let's go to add features. Let's click on next, next again. After a few next, we will hit on install. And we are installing our IIS to this destination server, and you can track your process. I must tell you again that this is a slow VM for this kind of image, so we will go back after this installation is complete. And after some time, our installation is successfully finished, and we are now able to hit on close, and you can see that we have our successful installer feature, and you can go to IIS if you want. And we can run this server or try to add some service if you want. Sorry, site if you want. Just like in Azure. Let me now minimize this. I will do exactly the same thing and right click on my mouse, click on new, let's open a new text document. I will now repeat the same steps just like in our Azure VM. So this is a message from our VM Windows server. I will now hit on in AWS. I will now hit on save. You can add whatever message you want, save as. Of course, we will save this on C drive. And let me go to inetpub. Let's go to www.root folder, and here we will save this as default.html document. Let's click on save, and after that we will minimize this window. But before that, let me go to our File Explorer, go to our C drive, let's go to inetpub www.root, and you can see that we have our default file that we just saved. And if I minimize this window, let me go back to my instances. I will now copy my public IP address of this Windows VM, paste it in a new window, and if I hit enter, you can see that we have successfully installed Internet Information Services on our AWS EC2 instance. And if I do /default HTML, we will see the message from our Windows server. So exactly the same thing, just like in Azure, you can do in AWS, and that's it. This is exactly the same message that we just added to this server. I will now try to correct this misspelling, and that's it. This is how can you host your website on your EC2 instance in AWS. And if you go back to our instances, you can see that we can now stop this virtual machine and simply click on stop, and now the both of our VMs are stopped. Windows 1 based on Linux image and Windows 2 VM2 based on Windows image, and both our machine is stopped. So this is how can you stop your machine. Of course, our remote desktop session has ended because we stopped our machine. And if you go to monitoring option, you can see the graphics, and you can refresh this graphic, and this is how can you look more granular into your VM and check all activities in your VM. And that's it for this lesson. Thank you, and I will see you in the next chapter. Well, there is several ways to connect to Amazon EC2 instances. The most common using SSH or Secure Shell for Linux instances and RDP Remote Desktop Protocol for Windows instances. Other options include EC2 Instance Connect and AWS System Manager Session Manager. Let's talk about SSH or Secure Shell. This is for Linux instances, so SSH is a standard and secure method for connecting to EC2 instances, especially those running Linux. There is some prerequisites. You must use an SSH client such as PuTTY or PuTTY or the one built into macOS or Linux, and a public DNS or IP address of the instance are required. Also, authentication is usually done using a pair of keys or key pairs. This consists of private key file and public key file. You must create a key pair when you start the instance and use the private key to connect. Also, SSH can be used with SFTP or Secure File Transfer Protocol to transfer files. Then we have RDP or the Remote Desktop Protocols. For Windows instances, RDP is the standard protocol for connecting to Windows EC2 instances. There is also some prerequisites. It requires RDP client such as Remote Desktop Connection client built into Windows and a public DNS or IP instance address. You will need to provide a username and password for the administrator account on the instance or your credentials. We have this connect to EC2 instance option. This is for both Linux and Windows machines. This is a simple web interface that allows you to connect to your EC2 instance directly from the AWS Management Console or using AWS CLI. This is a simplified key management, so it simplifies the connection process by managing keys and permissions. There is no need for SSH or RDP client, so you don't need to install or configure any SSH or RDP clients on your local computer. Also, there is AWS System Manager Session Manager for Linux and Windows. This is a fully managed AWS service that allows you to manage your EC2 instances via web interface or AWS CLI. There is also no need for some clients. It eliminates the need for SSH or RDP clients and infrastructure setups such as bastion hosts or port forwarding. Also, there is enhanced security, so it provides a secure and monitor way to connect to your instances, especially for private instances. And we have endpoint to connection to EC2 instance. This is for private subnets. This is a feature that allows you to connect to EC2 instance in your private subnets without the need for a public IP address or as an established host, of course. It simplifies the process of connecting to instance in private subnets by creating a managed interface endpoint. Well, I already mentioned AWS Batch service when we talked about compute services in AWS. So let's learn more about this service. So AWS is a fully managed service that plans, schedules, and runs containerized batch computing workloads such as ML, analytics, and simulations on AWS. It automatically provisions and manages the necessary compute resources, including Amazon ECS, Amazon AKS, and Amazon or AWS Fargate, removing the need for you to manage infrastructure or clusters. This allows users to focus on their jobs and analysis rather than on infrastructure management, with the option to use both spot and on-demand instances to optimize cost. The key feature for this service that it handles the provision and management of compute resources such as EC2 instances and Fargate based on job requirements. Also, there is a dynamic resource allocation, so the service dynamically provisions the optimal quantity and type to compute resources needed for the jobs, which help eliminate capacity constraints and can reduce costs. Also, it runs jobs in Docker containers on services like Amazon ECS, AKS, and Fargate. You can set up multiple jobs queues with different priorities. AWS Batch evaluates jobs based on their priority and resource requirements to run them on the most suitable compute resources. Also, it's supposed to use a lower cost spot instances to run jobs, further reducing expenses. How it works? You submit a batch job along with a job definition that specifies the container image, CPU memory, and other parameters. Then AWS Batch places the job in a specific queue, and after that the AWS Batch scheduler determines when and where to run the job based on the queue's priority and the job's resource needs. It automatically provisions the necessary compute resources such as container on ECS, AKS, and Fargate, and the job runs once completed, AWS Batch may automatically scale down the compute resources. This service is very important if you use more than one job, and it uses EC2 virtual machines. Let's see another option. How can we connect to our Linux DB instance in EC2? As you can see, I do some testing with my VMDB Linux and I want to create a new instance. As you can see, I'm in my console in EC2 and I will now go to my instances and let's click on Launch Instance. I will use North Virginia as my region, of course, and I will add a name for this VM. This will be simple VM based on Linux. Let me choose my Ubuntu image. I will choose this 24.04 LTS image, Ubuntu server. Username is Ubuntu. Instance type will be t2.micro. It is a free eligible for me, and if you want, you can create a new key pair. I will add a name for this new key pair. This will be based on, you can choose between .pem or .ppk. This will be VM Linux. And V, for example, and let's hit on create key pair. As you all know, we are getting this .pem file with our private key downloaded on our laptop, and of course I can edit network settings on, or I can use this default one for this region. I can edit this if you want, and let me choose subnet, for example. Will you choose UAssist 1A, and auto-assign public IP is enabled. So I will use firewall for security group. I can use this. Let me copy first my name and I will paste this name of my VM here to security group. We are creating a new security group, and again this will be VM Linux security group, for example. And I can copy this name again and paste it here in description that is required. And of course this is our storage, and let's click on Launch Instance. We completely successfully completed our machine. You can see that we have our launch log and this is succeeded. Let's go to our instance. I will now refresh this page and you can see that our machine is running but still initializing. I will now open a new tab, download my PuTTY tool. We already know what is a PuTTY. Let me download this PuTTY tool. And we are waiting for this download. One thing that I didn't mention, when you delete your instance in your EC2 service and it say that your virtual machine is terminated, but is still, you can still see that you have one VM. After 1 hour that will disappear and all deleted or terminated VMs will disappear after 1 hour, of course. Let me now download this PuTTY tool and we will download our for 64-bit MSI installer. This is our link. And then we will download, of course, something called PuTTY generator. And I will scroll down and find this for 62-bit. Let me click here and click on download. So with PuTTY we can first generate our key. I will show you how. And if I refresh this page again, you can see that our machine is running. Let me now first upload our putty. Double click on this icon, let's click on next, next, install, and that's it. Putty is installed. Let me click on finish. I will now close this read file, and if I type putty, you'll now see our putty client. So we need to use our host name. This is public IP address of our VM, and this is how can you. So sorry, I did a mistake. We need to double click on puttygen. So I will click on run. This is our puttygen. Let's click on load, and I will go to my downloads, and in the download or the desktop folder, let me just find my private key. This is our download. Let me choose all files, and we will use this VM Linux -nv, and we will load this key into our puttygen. So let's click on save private key. I will now click on yes, and I will now save on my download folder putty private key files, but this will be .ppk file with that extension. And let's click on save. I will now close this putty generator, and let's go to our client putty, and here I will go to SSH auth credentials, and I must browse my private key that you just saved. Go to our session, let me just find this session, and we need to copy public IP address of our VM that we just added or create. Our machine is here and is working. Let me copy this public IP address. This is our public IP address, and I will paste this address to our putty here, and let's click on open. Let's accept this. Let me log in as Ubuntu. If you remember, this is our password, this is our username, and this is our password, and we are logged in with our private key to this VM. And now we can run a various command on this VM. So as you can see, it's very easy to use this second option to log into your Linux VM. Well, there is a lot of benefits of using EC2 service. Amazon EC2 or Elastic Cloud Compute offers several benefits, including scalability, flexibility, cost effectiveness, and reliability. It also allows users to quickly scale computing resources up or down based on demand, provides a wide range of instances, types, and operating systems, and offers pay-per-use pricing models. In addition, EC2 integrates with other AWS services and provides robust security features. Let's talk about scalability and flexibility. We have elasticity. The EC2 allows you to easily increase or decrease your computing capacity based on your needs. Without the long lead times associated with traditional infrastructure, you can increase or decrease resources within minutes, or even automate scaling using tools such as autoscaling. Also, EC2 service offers a wide range of instance types optimized for different workloads. You can choose from general purpose, compute optimized, memory optimized, storage optimized, and accelerated compute instances, each with different processor, memory, storage, and networking capabilities. You can choose from a wide range of operating systems, including different versions of Linux, Windows servers, and other, or even use some custom AMIs or Amazon Machine Learning. Another benefit is that this is a cost-effectiveness. You can use pay-per-use. EC2 offers a pay-per-use pricing model, where you can only pay for the resources what you consume. This can lead to significant cost savings compared to traditional infrastructure, where you may have to provide excessive resources to cope with peak loads. Saving plans and reserve instances, this is for predictable workloads, so you can leverage saving plans or reserve instances to further reduce costs by committing to certain levels of usage. Also, we can use spot instances for fault-tolerant workloads. We can use these spot instances to bid on unused EC2 capacity at significantly discounted prices. Also, another benefit is reliability and safety. There is a high availability include, so EC2 is designed to be highly available and fault-tolerant with multiple availability zones within each region. This helps to ensure that your apps remain available even in the event of a single zone outage. Also, EC2 integrates with other AWS security services such as Virtual Private Cloud, security groups, IAM or Identity and Access Management, and encryption options to ensure the robust security of your compute resources. Also, there is something called Nitro system. The AWS Nitro system is the foundation of EC2 and provides a secure foundation for your application with features such as hardware virtualization and a dedicated management plane. Also, one of the benefits is seamless integration with other AWS services. So EC2 works seamlessly with other AWS services such as S3, simple storage service for object storage, RDS for databases, relational databases, and many others, allowing you to create and deploy complete application on AWS. Also, EC2 can be integrated with an on-premise infrastructure, allowing you to create hybrid cloud environment. Also, this is a very good service for developer and management. So you can use various tools. For example, APIs and command line tools. ACT provides a comprehensive set of APIs and command line tools or CLI for managing instances and other resources, enabling automation and scripting. There is also Management Console. The AWS Management Console provides a user interface for managing your EC2 instances and other AWS services. EC2 autoscaling automatically adjusts the number of running instances based on demand, ensuring optimal performance and cost effectiveness. Also, AWS Computing Optimizer analyzes your EC2 usage patterns and makes recommendations to optimize performance and reduce cost by adjusting the size of your instances. If you go to our console and go to EC2 instance type, there is the option to find instance type finder. So you can find instance type requirements based on workload type, priority, or use case, or simple you can use CPU manufacturer. So this is a very useful option if you need to search some web or app server, and you can use instance type finder for this. And it really save your time and effort to find whenever you need. As you can see, you can choose a different option, and you can even add advanced parameters. You can select a parameter to see the whole list of recommended instance type. So in the next few minutes I will try to show you how can we use this type finder and how can we search for different VMs if we need. And finally I will go to workload type, so you can choose from Kubernetes or machine learning, for example. Then for the priority you can use price or performance or low cost, And for the use case, you can use, for example, data science analytics, high performance computers, and so on. And you can choose by CPU manufacturer from Amazon, Intel, AMD. Let me choose AMD, for example, and I will add parameters such as number of CP. And if you go and click on add, you can add the number of VPC cores. Let me add 1, and maximum number of CPUs I will put on 12. You can also add another parameter based on memory, and if you click on add, you can add a minimum memory of 4, for example, and maximum memory of 15 gigabytes or 16, for example. Then you can add instance storage in gigabytes. If you click on add, you can, for example, add minimum instance storage in gigabytes and maximum instance storage, and you can finally add network performance gigabytes per second, and you can add minimum network and maximum network performance. And finally, when you add all desired information, you will hit on get instance type, and you will see the recommendations and what is the recommendations that match to your specified requirements that you provide here. And you can view recommended instance family details and additional information. So instance type finder recommends instance family C7A and 6CA. So this is how can you use this instance type finder, and you can find it on instance type blade in EC2 service. Of course, you can download the whole list in CSV file of all instance types here. If you download this, you can click on open file, and it will open in Excel as comma separated value, and you will see the whole. If you remember, when we create our virtual machines or instances in AWS, we already saw something called security group. Now it's time to see what are these security groups. So in AWS, security groups act as a virtual firewall for your EC2 instances, controlling incoming and outgoing network traffic. They define the rules that determine which traffic is allowed to reach your instances and which traffic is allowed to leave them. Think of them as a layer of security that protects your instances by filtering network traffic based on your defined rules. A security group controls the traffic, what is allowed to enter and leave the resources with which it is connected. For example, when you connect a security group to an EC2 instance, it controls inbound and outbound traffic for the instance. When you create a VPC, it comes with a default security group. AWS provides security groups as one of the tools for securing your instances, and you need to configure them to meet your security needs. If you have requirements that security groups do not fully meet, you can maintain your own firewall on any of your instances in addition to using security groups. A security groups can only be used in the virtual private cloud for which it was created. You can associate each instance with multiple security groups, and you can associate each security group with multiple instances. You can add a rule to each security group that allows traffic to or from its associate instances. You can also change the rules for a security group at any time. The new and changed rules are automatically applied to all instances that are associated with all security groups. When Amazon EC2 decides whether to allow traffic to reach an instance, it evaluates all policies from all security groups that are associated with that instance. And here you can see how it looks like. This is a simple VPC with a security group. As you can see, the EC2 instances in the subnet are associated with the security group. And the red, this one here, let me just take my pen. This red square is our security group. As you can see, security group is in some kind of boundary for our EC2 instance. and security group is placed in our public subnet, and this is our VPC in some of the region. So if you try to find something more about security group, you can see that an example of this features is a security group, which functions as a virtual firewall, as I already told you, to regulate incoming and outgoing traffic for Amazon EC2 instance or AWS resources in VPC. So what is a security group? Security group performs the function of a virtual firewall, managing incoming and outgoing traffic for one or more Amazon EC2 instance or other AWS service within the VPC. The security group has something called inbound and outbound role. Inbound role defines the types of traffic that are allowed to use resources. It serves as a virtual firewall, controlling traffic entering and exiting the VPC for one or more Amazon EC2 instance or other AWS services. This is a mistake. It must be simple V, not W. And of course, there is outbound rules, and these rules govern traffic that is allowed to leave a resource. So inbound traffic destinations are processed by outbound rules. They can be forwarded to an alternate security group, a CIDR block, a single IPv4 or IPv6 address, or all three. Also, Amazon EC2 instance, as you already know, this is a web service called Amazon Elastic Cloud. Offers scalable and cloud computing capabilities. For example, developers, it is intended to simplify cloud computing at the web level. VPC is virtual private cloud. This is a virtual network. Allows you to run Amazon resources into a defined virtual network. Also, there is a protocol. A protocol is a set of policies that control how two devices communicate with each other. And we have something called CIDR. This is a technique of assigning IP addresses and forwarding internet protocol packets, and it's called classless cross-routing, domain routing, or simply CIDR. And we have something called port. This is just a port that serves on the computer as a communication endpoint for a particular process or service. Let's now go to our console and see security group. If you can see, we are now in our EC2 service. In the instances, I have my Linux and Windows VMs, and both of VMs are in the stop state. If I check my VM1 Linux, you can see in the action, and I can now start my instance. Let me try to start my Linux instance, and our machine is running. And if I scroll down, you can see that we have our new public IP address, of course, because this machine was in the stop state. When you stop your virtual machine, just like in Azure, you will lose your public IP address. But our message is still coming from this IP address. So our script is working. And now our machine is still initializing. And if we, for example, go to our network and security and go to our security group, you will see what security groups are available here. Also, if we click on security tab of our VM, you can see that we have our security group that is attached on this VM, and we have inbound rules, and this is inbound rules that we created when we create our VM. We have HTTP, SSH, and HTTP inbound security rules for this VM, of course. This is a port range 443. This is HTTPS. 22 is for SSH, and 80 is for HTTP, if you remember. And protocol, what we're using is TCP. The source is internet, and the inbound rule, this is a default inbound rule. All port ranges, all protocol for destination is attached from this security group. And if I go to security group, you can see that we have default security group, and we have our one security group that we created when we create our virtual machines. If I go inside that security group, you can see exactly the same information that we saw in our instances blade. We have 3 permission entries and 1 outbound rule. I can now click on edit inbound rule, and simply from here I can add a new rule or change existing rules or simply delete these rules. Let me delete port 80 rule and click on save rules, and you can see we don't have any rules for this inbound rule for this security group. I can now go inside that group and delete SSH if I want and click on save rules. So I don't have any rule beside HTTPS. If I go now and copy public IP address, after some time we will not be able to reach our message from our VM because we don't have a proper rule. We just deleted SSH and port 80 rule, as you can see, and it takes time to take effect, to this rule to take effect, and we have now 1 permission entry for our inbound rule. If you go again to our inbound rules, I can now click on add a rule, choose my, for example, HTTP, and add this CIDR block and choose source as anywhere, and exactly the same thing I can do for SSH, for example. Automatically is choosing protocol and port range, or you can simply switch this SSH HTTP. Let me add my CIDR block, and if I click on save rules, we can add custom or anywhere IPv4, click on save rules, and once again we have added our rules. And if we now refresh this page, you can see that automatically we are able to reach this message that is coming from our IP, public IP from our VM. Exactly the same thing we can do for our outbound rules, but I won't do anything. And as you can see, there is a lot of options that you can use with security groups. Of course, this is VPC association. You can associate the security group to any VPC in your environment, in this region, of course. And you can also use tags if you want. So security groups created with the default VPC cannot be shared, as you already know. So you must create a new security group if you want to share with some VPC. That is a new option. And of course, all security groups has its own IDs, and you can see the owner. This is the ID of our account, of course. And in the description you can see when it's created, and that's it. And of course you can see what is the VPC ID. All resources in AWS has its own ID. One of the great thing about this security groups is you can that you can limit that only you can access this VM. So let's try to create a new VM. Let's add the name for this VM. This will be VM3 based on Ubuntu image, and I will use instance type t2.micro. We will use existing key pair, and I will now choose to create or select existing resource group. Let me choose my existing resource group, and finally I will hit on launch instance, and we are successfully create our instance. As you can see, if I refresh this page, you can see that we terminated this machine and our VM3 is still pending. and our machine is up and running. And this is our public IP, and if I go to our security group blade, let me find my launch wizard 1. I will go inside that security group. As you can see, for now we have only default outbound rule, and this is from all protocol, all port range for source to destination is allowed, and exactly the same we are having for our outbound rule. If I go to my outbound rule, I can edit this rule, and you can add a rule. Of course, if I go to inbound rule, I can edit this inbound rule, and if you want you can delete this rule, but in the custom option you have to add your IP address. And when you add your IP address, you can save this rule, and from the source, this is my IP address, only me can have the access to connect to this virtual machine. So with this option you can limit the traffic, and this is great for the security point of view. So for the source I will using my IP address to connect to this inbound rule, to this virtual machine, thanks to this inbound rule. As you can see, protocol is TCP, type is SSH, and with the help of security group ID you can limit the traffic and who has access to this VM. So just like in Azure, if you are using NSGs. So if you go to instances and try to connect, you will be able to connect just from this VM, from your VM and from your public IP address. Now if you go to my security group, I will change this to anywhere IPv4 or custom and click on save, and now everybody who wants to SSH to this instance will have the power to do that. Thank you for watching. IAM roles provides a secure way to grant EC2 instances access to AWS resources without the need to manage long-term credentials. When an EC2 instance needs to communicate with other AWS services, it uses the IAM role associated with it for authentication. This eliminates the need to embed access keys directly into an application or instance. Here is the detailed explanation how it works. First, we need to create our IAM role. So this IAM role is created with a specific trust policy that allows EC2 instance to take over the role. Then, of course, the role also has a permission policy that defines which AWS resources the instance can access. Then we need to role this attachment, and IAM role is attached to an EC2 instance during instance startup or later via the EC2 console. Then we need to use something called instance metadata service or IMDS. When an application running on an IS2 instance, it needs to access AWS services. It points to the instance metadata service, and IMDS provides a temporary security credential associated with an attached IAM role. And then we need to use authentication authorization. The app uses these temporary credentials to authenticate with other AWS services such as S3, DynamoDB, etc. The permission defined in IAM role policy determine what action an application can perform. So, what is the advantages of using IAM roles? Enhanced security. IAM roles provide temporary rotating credentials, eliminating the risk of storing long-term access keys on the instance. It has simplified management, so a single role can be used for multiple instances within the web layer, making it easier to manage permissions. Also, all actions performed by an instance can be tracked back to the IAM role, making auditing easier. And it eliminates the needs for manual management and rotation of access key. How it works and what is the example? If the application on the EC2 instance needs to read data from the S3 bucket, it should create an IAM role with the read access to a specific S3 bucket, attach the role to the EC2 instance, and the application, when it needs access to S3 bucket, will use the temporary credentials provided by IMDS and IAM role to authenticate with S3. So once again, we are in our EC2 instance and service, I will go to my Linux instance, and if I go to security, you can see that we don't have any role for this instance. So what we need to do is to connect to this VM. I will connect using EC2 instance connect. So as you can see, we are connected to our VM. I will now run AWS IAM list -users, and as you can see, it is unable to locate credentials, so I must configure credentials by running AWS configure first. So let's run AWS configure, but if you go back to our instance, so what we are trying to do is to list the list of users. Let's go to IAM, to our access and management service, and if we go to users, let's create a user. This will be user 1, for example, and let me just create a simple user. I will create another user. This will be user 2. Let's hit on next, and let me hit on create a user. This is just a sample. It really doesn't matter what the name are you using for these users. Let's go to roles, and let me click on create a role. I will now use AWS service, and this will allow AWS service like EC2 to perform actions in this account. I will now use EC2 service, choose this EC2 that allows instances to call AWS services on my behalf, and I will now search for read access. I will now try to find this with job functions. Let me click on next, and here we need to add a role name. We will add EC2, for example, a role name for this, and this is our selected trusted entities. Let's hit on create role. So we are creating a read-only access role for our EC2. As you can see, this is the name of our role, and trusted entities is our AWS service EC2. Now, if we go back to our EC2 service, go to our instances, go to our VM instance, go to security, you can see that we don't have any role now. If I go to action, choose my security, and choose modified IAM role option, I can now add this role to my instance, to my VM1 Linux instance, and let me click on update IAM role. So if we go back to security now, you can see that we have this IAM role added to this instance. And now if you go back to our instance, we are connecting to our instance and try to use exactly the same AWS IAM list users command, you can see that we can list the users that we created in our IAM service. So this is how can you add a role to your EC2 instance, and it is very common use case to add a role to your EC2 instance. It is very easy to use this, and very good to use this IAM role for your instances. Thank you for watching, and I will see you in the next lecture. I hope this was helpful, and welcome back. In this chapter, I will talk about AWS EC2 purchasing options. We already looked at purchasing options, but this topic deserves more time. So first we will talk about purchasing options, and then we will go to our console and see how it works. Well, as you already know, AWS or Amazon EC2 service offers several options for purchasing computing capacity, each with different trade-offs between price, flexibility, and commitment. These options include on-demand instances, reserved instances, saving plan, spot instances, dedicated host, dedicated instances, and capacity reservations. So we will talk about each of them. First one is on-demand instances. On-demand instances allow you to pay for computing capacity by the hour or per second, minimum 60 seconds, without long-term commitments or any upfront payment. It is ideal for short-term, irregular workloads that cannot be interrupted. For example, a startup testing a new application, or a company running high-performance computing application. And some of the real-world example is e-commerce website that uses on-demand instances during flash sales to cope with a sudden spike in traffic. Then we have reserved instances, standard and convertible. Standard reserved instances offer up to 75% of the price on request, with a commitment on 1 or to 3 years. For example, an always available database server of the appropriate size will work continuously for 1 year. On the other hand, convertible reserved instances provide a discount up to 54% off on demand, and the flexibility to change the attributes of a reserved instance as long as the exchange results in the creation of reserved instances of equal or greater value. Some use cases that these reserved instances is best to use for constant workloads. Standard reserved instances are ideal for applications with predictable usage, while convertible reserved instances are suitable for workloads with some variability but generally consistent performance. A financial service firm that uses standard reserved instance for its consistent backend processes and convertible reserved instances for its customer-facing applications is a real good world example. And of course, this may require scaling than something else. Then we have EC2 saving plans. Saving plans offer significant savings over on-demand pricing in exchange for the obligation to use a certain amount of computing server or power measured in $ per hour over a period from 1 to 3 years. It is suitable for users with a constant amount of computing power usage over a long period of time. This can range from running microservices to data processing applications. A media company is a really good real-world example that continuously runs data processing workloads on EC2 instances, committing to a certain amount of computing power usage with an EC2 saving plan to reduce cost. Then we have spot instances, or EC2 spot instances provide access to unused EC2 capacity at a discount up to 90% of the subscription price. For example, it is ideal for applications for flexible, stateless, and fault-tolerant, such as big data analysis, containerized workloads, or CI/CD pipelines, continuous integration, continuous delivery pipelines. It is not suitable for critical jobs or those who are not tolerant of interruptions. A research institution that conducts large-scale genomic analysis using spot instances with a lower cost for its flexible and disruptive task is a really good real-world example. Then we have our dedicated host. So dedicated hosts are physical servers with the capacity of an EC2 instance entirely dedicated to you or to your use. They allow you to use your existing server-related software licenses and can help you meet compliance requirements by providing physical isolation from other AWS users. Especially useful for business with a strict regulatory compliance need or those who need to use their existing cloud software licenses. For example, one of the good real-world example is a user that intends to use their current software licenses based on AWS criteria per socket per core or per virtual machine for a Windows server running on AWS. I already explained how dedicated host works. So when you decide to purchase dedicated host, the whole host will be just for you. So any virtual machine or instance that you provide or provision will be exclusively on that host, and this host is yours. Nobody can host any other machine on that host because you're paying for dedicated host. Also, we have dedicated instances. Dedicated instances run in a virtual private cloud or VPC on hardware that is intended for a single user. Unlike dedicated hosts, dedicated instances do not offer the same level of control over a physical host, but they do ensure that your instances are isolated at the hardware level from instances belonging to other AWS accounts. It is ideal for applications that require isolation from other users' instances for security or compliance reasons, but they do not require the use of existing software licenses. The government use dedicated instances to process sensitive data, ensuring compliance with strict regulatory standards without the need of physical control over the server. This is a very, very good real-world example. And then we have capacity reservation or reserve capacity. This option allows you to reserve some capacity for your EC2 instances in a specific availability zone for any period of time. It is useful for applications that need guaranteed availability in a specific AWS region, providing capacity for mission-critical applications. An online gaming company may use capacity reservations to ensure that it has enough capacity to launch a new game in a specific geographic region. So choosing the right option to purchase an EC2 instance depends on your specific use case, budget, and flexibility requirements. Whether it's a cost-effective spot instances for interruptible workloads or dedicated host for applications that require compliance, AWS provides a wide range of options to meet a variety of business needs. By understanding each of these options and aligning it with your operational requirements, or OPEX, you can effectively optimize your AWS investment. So I'm again in my Amazon Management Console, and as you can see, if you go to our EC2 Center or EC2 Global View or Service, you can see that there is something called Events. So you can even check this option to schedule some event. But the main reason why we are here again is this instances blade. For example, spot request, saving plan, reserve instances, dedicated host, and capacity reservations. So let's go first on spot request. Here you can request a spot. As you can see, you can create a fleet spot. If you go to actions, you can see what is detail instance by type if you choose this option. Then we already talked about in great detail, but if I click here, you can create something called create spot request, calculate spot placement score, and create spot blueprints. Let's go to create spot fleet request. By creating this request, you're using predefined launch parameters, providing instance type attributes, or manually selecting the type of instance that you need. In the launch parameters, you can manually configure these launch parameters. You can also select an AMI and configure optional parameters, or you can use a launch template to quickly set up launch parameters. Here in launch parameters, in the first option, this manually option, you can choose, for example, AMI, Amazon Microsoft Instance, and if we scroll down, you can, for example, add what is the total capacity that you need and so on. So you can choose your key pair name, choose or search for AMI. There is additional launch parameters if you need to see. Then you need to see what is IAM Fleet role, and as you can see, this is a very useful option if you want to use this request for your spot instances. If I go to use a launch template, you can see that we don't have any template here, but you can create a launch template. If I click on this link, you will go in ECT Management Console once again, and here you can create a launch template. This is the same template that you use to create auto-scale option. So as you can see, this is auto-scaling group, sorry. And when you define this launch template, name a subscription, you need to add the template name, add the version for your template, and choose application or OS image. You can choose from here and add instance type, key pair login, network settings, storage, resource tags, and so on. You will hit on create template, and then that template will be used here in our use a launch template, of course, with added parameters. But for now I want to stick with these manual launch parameters, so we can see that we need to choose our AMI, and of course this AMI is just a template that you already know. This template contains a software, operating system, application server, application, and so on. So you have a large number of AMI that you can use from Windows, Linux, some kind of other distribution of Linux, and some custom images. You can also search for AMI if you don't have appropriate here. Then I will choose, for example, my Amazon Linux 2 image, and here you need to provide a key name pair. You need to have one, or if you do not have, you can create right from here. Also, there is some additional parameters to add if you want. You can launch EBS elastic block system, optimize instances. You can attach this at launch, but this volume, as you can see, this EBS volume is the root data for our VM or for our spot instance. So you can see what is the snapshot. It uses, of course, snapshot, what is the size, what is the volume type, and so on. Then you can also enable CloudWatch for detailed monitoring of this spot instance and spot fleet. Sorry, you can auto assign IPv4 or IPv6 address. You can add some optional instance profile. You can add or create a profile, and then you can use to specify user data to run some script. You can do it as a text or as a file. So you will add some code in this empty field. And finally you can create your tag, and we have something called additional request detail. You can add your fleet role, and that's it. So this is how can you request a spot fleet of machine for your request. If you go to this fleet spot in IAM console, you will have to find appropriate role. We already know how to create a role, so nothing special here, just a simple wizard that you must set up for this request. Of course, you can add total capacity, for example, the number of instances and CPUs to launch. You can choose between the CPU and memory, and you can also add the memory. The number of domain instances always persist, while spot instances can be scaled. So you will add this target capacity, for example, scaling. And then you can also maintain this target capacity after. If something happens, that it will automatically, you can choose to replace interrupted spot instance that is part of this fleet, to terminate, stop, or hibernate that machine or instance, of course. Then we need to specify our network. But before that, you can also choose your capacity rebalance, and this is also very interesting option, and also you can set the maximum amount per hour that you're willing to pay for spot instances, for example, and in the USD you will add your number, for example $10 per hour. And then in the network section you have to choose your network VPC section, your VPC, sorry, virtual private cloud availability zone. And as you can see, this is default network that is located in one of our region. We are currently using North Virginia, so you can create a new VPC right from here, and that's it. And finally, very important option that you can or you must enter your compute requirements for your, of course you can choose availability zone from here. There is a 6th in North Virginia or is US East 1. In this instant type requirement, you need to enter your compute requirements and let the AWS choose your optimal instance. So you can choose between specify instance attributes that match your compute requirements. You will add the minimum and maximum VPC, virtual CPU and memory, and you can choose additional options for your, for example, network, instance type, and so on. And in the manually selected instances, you can choose the instance by fleet request. Here you can choose, for example, one of these family instance, and that's it. Finally, you have to choose between spot allocation strategy, price capacity optimized, this is recommended. So you are requesting the lowest spot instance from your most available pools. And there is also some other settings. So this is how you can create a spot fleet instance. Then we have saving plans. We already talked about saving plans, that saving plans are flexible pricing model that offer the lowest price of EC2 and some other services in exchange for a commitment to a consistent amount of usage for 1 to 3 years. You have flexible saving plan that provides the most flexibility, that you can save up to 66%. You can also, these plans apply to EC2 instance, Fargate usage, Lambda usage, and you can see all information in that here. Then there is also a significant discount. You can choose EC2 instance saving plan with the lowest prices, and you can change. You can save up to 72% in exchange for some commitment. Of course, if you click on this link, you will go to saving plans and cost, and you can purchase a saving plan. If you click on this, click saving plan, you can choose a purchase detail. There is also compute saving plan, and you can choose your commitment from 1 to 3 years. You can add your hourly commitment, for example, $2, and you can choose your payment options. You can select to pay upfront. This is how much it will cost, and if you change this, of course compute saving plan applies to all of this EC2, Fargate and Lambda service, regardless of any region, instance, family, size, and so on. And this is the purchase summary that you will pay upfront, of course. Also, you can start the daytime when do you want to allow this. You can choose to pay the partial upfront, so you will first pay this sum and 730 monthly payment until this purchase plan. So 50% you are paying upfront, and you can see no upfront, then monthly payment is different, and you can see there is a lot of options that you can choose to add your purchase plan. Then we have something called EC2 instance saving plan. It applies only to EC2 instance family regions, and you can choose, of course, between commitment from 1 to 3 years. You can choose your region, let me choose some of the region, and then you will choose the instance family, and let's find some appropriate family. For example, let me find T2 micro, and then you can choose payment option if you want to pay upfront, or sorry, hourly commitment, and then you can choose to pay, for example, all upfront, partial upfront, and so on. So if you want to purchase this plan, this is the cost that you will pay in one, and then you can, for example, choose to 3 years commitment, and then as you can see, this is upfront cost is $26,000 for 3 years for this type of family, and for $1 commitment to this saving rate. Of course, it really depends on what are you using this and what are you host, for example. Then if you choose partial upfront, you will pay 50% of the total commitment upfront and other 30,000 by monthly payment, and there is no upfront. As you can see, there is only, you will only pay 3 years for $730, and you can play around with these options just to see how this saving plan works. So there is a lot of option to choose to save your money, and this saving plan is some kind of commitment for 1 and 3 years. So if price goes up, you will pay this price that you, when you purchase this saving plan. The other option, as you can see, is reserve instances. So you can purchase reserve instances, for example, and here you can choose your platform between Linux and Windows, and there is a lot of options. As you can see, you can choose various distributions of Linux, Windows, of course. Then for the tenancy, you will choose default or dedicated. There is also, we talked about convertible and standard class, and here you can choose your instance type if you want. Then long term from 1 to 12 months or for 12 to 36 months, and payment option. Of course, no upfront or partial, and here you can do a search and you can view your cart, and here from here you can buy your reserve instance. The Amazon recommend reserved saving plans before reserve instances because you can save much more and get the most for your money. Also, there is AWS pricing calculator, and you can also contact AWS specialist for a personalized quote if you have some additional request. So this is how can you purchase reserved instances. If you go to dedicated host, you can see that you can allocate dedicated host, and there is also a reservation to dedicated host. You can reserve your dedicated host. So if you click on, for example, allocate dedicated host, then you have the option to buy this host especially for you. So this physical host, this is just some server that runs in some of AWS data center, and every time you decide to provision your virtual machine, then here it will be hosted on that dedicated host that you buy, that you pay for. And we have capacity reservation. You can choose between capacity reservations to reserve compute capacity for your EC2 instance in a specific AZ. So we have two types of capacity reservations: to create on-demand capacity reservations and long-term for machine learning, as you can see. And if you choose create on-demand capacity reservations, let's click on get started. You can choose EC2 instance details, for example, and you can reserve a compute capacity for your instance in specific AWS, in the availability zone for any duration. So here you will use instance type. You can choose Elastic Block Store that is optimized. You can choose your platform. Of course, Linux or Windows. Then you can choose your availability zone. This is the North Virginia availability zone. If you choose a different region, then the number of AZ would differ according to AWS. So we have 6 availability zone in this region. So you can choose between these 6, and then for the tenancy, you can choose to run a default shared instance hardware instance or to choose your dedicated service. So once again, dedicated host is included here. And the total capacity, you can reserve capacity to your current on-demand instance quota. And of course, there is something called placement group. If you choose to create this service, then all your virtual machine will be placed close to each other to have a small latency. And then you can choose how much capacity do you want to reserve. The number of instances you will add on this empty field. For now it says 1. Of course, you can request your capacity, and you can choose when do you want that capacity to start. You can choose, for example, immediately, at a future date. So when this capacity reservation ends, you can add a manually end of this date and so on. So you can check your instance eligibility, for example. You can target only the instance in the capacity region. So whatever you want, you can specify it here in this part of this. In this part of this EC2 service. Of course, you can specify commitment how much days at some future date if you want to, for example, start from November 2025, and we are now in October in the moment of this when I am recording this. So everything is at your disposal. It really depends on what do you want and what do you need. So AWS is really try hard to get the most for your money. So you have to choose between one of these if you want for spot request, saving plans, reserve instances, dedicated host, capacity reservations. And this is very important if you want to save some money or get the most for your money. So we now know what is capacity reservations. Of course, you can purchase capacity blocks for Microsoft Learning, for example. And here there is 3 steps that you must fulfill. And as you can see, this is a very large and strong instance type. You can choose platform. We don't have Windows here. This is only Linux, based on Linux instances. And here you can choose total capacity, duration, capacity start date, and so on. Then you can add the tags, and in the step number 3 you will review and purchase what you add here. And that's it. This is how can you reserve some of these options, these purchasing options, and save a significant amount of your money and use AWS just like any other service. If you now go to calculator.aws, here you can estimate the cost for your architect solution. Here is how it work. You can, for example, create an estimate, and right from here, if we click create estimate, you will choose your service, and then when you add all part of that service, for example, what type of OS do you want to use, what type of instances do you want to use, OS and so on, you will get an estimated price, and you can calculate how much it will cost, for example, for 3 years, 5 years. And then when you calculate your expenses, you can choose one of these plans that we just talked about. Thank you for watching, and I hope that this was helpful. Let's see how can you change the instance type. As you can see, I'm in my console, in the front page of my management console in AWS, and if you want to change the instance type, you can do it right from your console. First, let's go to EC2 service. I will go to instances, and let me create a new instance, or we can launch a new instance. Now that we know how to work with this service, I will first add the name for this instance. This will be 001. I will use AWS AMI T2 micro is okay. Let me use my existing key pair. You can create a new key pair if you don't have existing one. Just add your name and choose key pair type and private key profile and click on create a new one. Then in the networking settings, I can use my existing group. We will use this one, and I want to change anything. I'm happy with this. So we are creating instance type based on t2.micro, and let's click on launch instance. So our instance is complete. We can check our change log, and let me go to my instance, and as you can see, if we go to instances, of course we have our VM01 that is running, but is still in phase of initializing. So we have to wait for a little to see these machines are already terminated. As I already said, it takes 1 hour to get terminated machines to disappear from this list. So we need to wait until our status is initializing. If I click on connect, we can use our EC2 instance connect. Let me connect here, and as you can see, we are connected to our Linux VM. But first, let me just check this status check of this VM01. And in the meantime, you can see what we already know, how to connect to this instance. And if I go to VPC, for example, and go to route tables, you can see that in the routes we have this route for our internet gateway that is added by default, of course. More about this in our networking part. So you need to add a new route, choose internet gateway here, and choose your existing internet gateway, add 0.0.0/0. This is for internet, and you can click on save changes, and then you will be able to connect to your instance if there is some kind of problem. Of course, we are now waiting for our VM to be initialized. So we will go to EC2 instance again, and I hope we can now work with this machine. So after some time, our machine is initialized, and I will now run this command echo hello to create this hello.txt file. Let me paste it here. I will now run ls list to see that, as you can see, we have two files, one that we just created, and if you do a cat hello.txt, we are getting the response back, and this is hello from that file that we created. If you type free-m, you can see how much memory is used in this virtual machine and what is a free and available memory for our use, of course. This is a very nice to know. And finally, if you go back to our virtual machine, you can see that we are running this t2.micro machine. This is our instance type, and finally we can now go to our instance state, click on stop this virtual machine. So I will stop this VM, and as you can see, our machine is in the stopped state. So once again we must wait, and if I right click on this machine and go to instance state, you can use one of these options to change the behavior of your machine. Let me now, okay, now our machine is stopped. I will now once again do exactly the same exactly the same thing. You can see that we don't have any public IP address, and if I go to instance settings, I can click on change instance type. Now we have the option to change our instance type. You can choose a new instance type, and you can see instance type comparison, and this is T2 micro, and I will now, for example, choose some other instance type. You can choose C series and anything, any type that you need for your workload, for example. Let me find the appropriate one, and I will scroll down to find, for example, this again T2 Nano family, and we are choosing new instance type, and you can see the comparison, how much memory, how much core, what is the pricing on demand, Linux, free tier is eligible, this is not eligible, and you can also find another one. For example, let's choose small, for example, and you can see that we also have this comparison. And finally, if you click on change instance type, after some time your VM, your instance type will be shown here after we refreshed our page and start this instance. So your instance must be stopped if you want to change your instance type. And as you can see, we again have this public IP address. This is our new IP address. Our machine is running, status is initializing, and instance type is T2 small. You just change this instance type. So as you can see, it's very easy to change instance type of your VM, but your instance must be in stop state. If I try to connect again to this machine, let's try to connect. As you can see, if I run, for example, again these commands, ls, you can see that we have our two txt files here, and if I run free-m, you can see that we have now different type of memory that is available for us. So once again, it's very easy to change the size of your VM, and you can also change back to T2 micro if you do not have any other request. So we have a different public IP address, and that's it. I hope this was helpful, and I will see you in the next lecture. But before that, we can now refresh our page once again, and our status of this machine is still initializing, but after some time status check will be okay, and we will be ready to work with this machine just like before. If I now stop this machine, I can roll back to this T2 micro in exactly the same way. We can stop this machine, go to our instance settings, and change the instance type. But I won't change it, so this is how can you do it. Of course, it must be in full stop state, not stopping. If you try now, you will be able to roll back to the previous state of this machine. So now it's time to, when this public IP address doesn't show here, you can now go back and revert this machine to T2 micro machine. And finally, if you click on, also you can compare prices, and if you click on change instance type, you will revert this machine to T2.micro instance type, and that's it. Now you can again start your VM, and your VM will be running as T2 micro instance type. Thank you for watching. An AWS Elastic IP, or EIP, is a static public IPv4 address for dynamic cloud that you can programmatically associate with an EC2 instance or network interface in your AWS account. It provides a stable public endpoint for your application, allowing you to remap the address to a different instance if the original one fails or needs to be replaced, thus making instance failure and minimizing downtime. What is the key features and benefits of Elastic IP? Well, it is static and stable. So an Elastic IP is a fixed IP address that does not change, unlike the default public IP addresses assigned to instances which change and the instance is stopped and restarted. You can quickly reassign an Elastic IP from one instance to another by associating with a new network interface or instance within your virtual private cloud. Also, this reassignment feature allows you to recover from an instance failure by redirecting traffic to a healthy instance, providing a reliable public endpoint and ensuring application availability. Also, and Elastic IP is associated with your AWS account, not a specific instance, so you can move it around as needed without having to update DNS configuration or application settings. Also, it enables internet connectivity, so if your instance that does not have public IP, and Elastic IP can be used to provide with one, allowing communication with the internet. Also, you are charged for an Elastic IP if it is allocated to your account but is not associated with a running instance. You only pay for the time when use this Elastic IP. Now that we know what is Elastic IP, let's see how can we work with Elastic IP. As you can see, I'm in my EC2 instance, and I started my VM01, and VM02 is terminated. As you can see, my VM1 have this public IP address, and if I go to launch a new instance, I want to create a new instance. So this will be VM03. I will use my Amazon Linux image, choose my t2.micro instance type, I will use exactly the same key pair, and in the networking settings I will select my existing security group. This will be Launch Wizard 1, and here the only thing we need to do is to click on Launch Instance. Just let me check, is everything? Yes, it is. Okay, so we can now launch this instance. And if we go back to instances, you can see that we have now 2 virtual machines or instances up and running. So here, if I refresh my page, you can see that both of these machines are running, and our VM01 has its own public IP address. And if I go to networking security and go to Elastic IP, we don't have Elastic IP for this region, so we can allocate this public IP address. We will use public IPv4 address for Amazon pool of IPv4s, so we will use our EastUS1 and click on create. So this is our Elastic IP and this is our public IP address. So I must warn you that this is a static IP address, so it can change. Now that we know how to use this address, we can check this box and click on actions and use associate Elastic IP addresses. You can choose your resource type for instance or network interface. I will choose my instance and choose my VM01, if you remember, and click on associate. Now we are associating this Elastic IP to our VM1, and if I now try to refresh this page and check again, you can see that public IP address of our VM01 is now different because we are added this public IP, this Elastic IP to our VM1. If I go back to Elastic IP, you will see that this is exactly the same public IP address that we just added or allocated to our VM1. I can now go to actions again and click on view details or the associate public IP address. I can now deassociate public IP address from our instance, and if I try again to associate this public IP address, you can see that I can now use exactly the same Elastic IP address for our VM03 that we just created. So if I go back to instances again and uncheck and refresh this page with our instances and check again our VM01, you can see that we have different public IP address. But if you go to VM03, you can see that we have exactly the same public IP address as our Elastic IP, because we are now using this public IP, Elastic public IP address for our VM03. So this is how can you work with Elastic IP to associate or deassociate your address. I will now deassociate this address and go to actions once again. Let me now check the public IP address of my VM03. As you can see, this is now a different public IP address because we are deassociate Elastic IP. So Elastic IP is a static IP address and it will cost you money. Now if we go to actions and click on release Elastic IP address, this will remove this IP address from my account for now. And if you go to view details, you can see all details about this Elastic IP. So as you can see, it's very easy to work with Elastic IP when you need. I will now release this Elastic IP and click on release. When you need a public IP address, static public IP address, Elastic IP is the right choice for you or your company. And you will pay for this Elastic IP as much as you're using it. And now when we release our public Elastic IP, there is no here. So if you now refresh this page, you can see that we have exactly the same public IP address that we have when we disassociate Elastic IP. Thank you for watching. In AWS, Elastic Load Balancer, or ELB, is a service that automatically distributes inbound application traffic across multiple targets such as EC2 instances, containers, and IP addresses in one or more availability zones. It improves application availability and fault tolerance by routing traffic only to the correct instances and automatically scaling to meet demand. Elastic Load Balancer is a service provided by Amazon in which incoming traffic is efficiently and automatically distributed between a group of backend servers in a way that increases speed and performance. It helps to improve the scalability of your application and secures your applications. The load balancer allows you to configure validations for registered targets. In the event that only and any the registered targets or auto-scaling group fail the validation, the load balancer will not direct traffic to the unhealthy target. This ensures that your application is highly accessible and fault tolerant. We have 4 types of load balancer. The first one is classic load balancer. This is a traditional form of load balancer that was originally used. It distributed traffic between instances and is not intelligent enough to support host-based or path-based routing. Eventually, it reduces efficiency and performance in certain situations. It works at the level of connections as well as the level of requirements. A classic load balancer is located between the transport layer, TCP or SSL, and the application layer, HTTP or HTTPS. But classic load balancer is deprecated. Then we have application load balancer. This is type of load balancer is used when decisions are made regarding the routing of HTTP and HTTPS traffic. It supports path-based routing and host-based routing. This load balancer works on the application layer of the OSI model. The load balancer also supports dynamic host port mapping. Then we have network load balancer. This type of load balancer works on the transport layer, TCP or SSL of the OSI model. It is capable of processing millions of requests per second. It is mainly used for load balancing TCP traffic. And finally, we have gateway load balancer. Gateway load balancer provides you with the ability to deploy, scale, and manage virtual devices such as firewalls. Gateway load balancers combine a transparent gateway and then distribute the traffic. To avoid sending traffic to servers that are unable to process requests, load balancers monitor the health of backend resources. The process of relocating loads in a distributed system to ensure that no computer is overloaded, underloaded, or idle is known as load balancing. This seeks to speed up several aspects of the cloud environment such as reaction time, execution time, system stability, etc. Work on load balancing research has not been able to offer an accurate systematic classifications of methods and procedures. Factors responsible for the problem of load imbalance and also some methods that can be used are listed here. You can identify the factors that cause load imbalance problems in cloud computing, provide a systematic overview of the existing approaches used in the load balancing process and how these approaches have been used in cloud technology. A physical device, a virtual instance that runs on the specialized hardware, included in application delivery controllers or ADC, designed to improve the performance and security of web and microservice application more broadly regardless of their hosting. So, to recap all of this, Elastic Load Balancing in AWS, it distributes inbound application traffic across multiple targets such as EC2 instances, containers or ECS, Lambda functions, and IP addresses across multiple availability zones. Distributes traffic across multiple servers, improves the performance of the application. It accepts incoming traffic from customers and direct requests to its registered targets. It monitors the status of its registered destination and directs traffic only to the correct destinations. Enable wipe protection to prevent accidental deletion of your load balancer, and this is disabled by default. Deleting an Elastic Load Balancer or ELB will not delete instances registered on it. There is also across load balancing, so if you enable this, each load balancer instance automatically distributes traffic to register the targets in all enabled AZs. It supports SSL hashing, which is a feature that allows the AWS Elastic Load Balancer to bypass SSL interruption by removing SSL-based encryption from incoming traffic. Also, if you want to choose Elastic Load Balancer, you must be aware of some of these options. So, it is a high available. The most common service that relies on Elastic Load Balancer is Amazon EC2 instance, as Elastic Load Balancer performs a health check to confirm that the instance continues to run before sending traffic to it. The developer can integrate Amazon Route 53 and the domain name system on DNS to further improve the resiliency of the application. Then we have autoscaling. A developer or some other user can use the AWS autoscaling feature to ensure that are enough EC2 instances running behind this ELB. The developer set the condition for autoscaling. When condition is met, a brand new EC2 instance can be started to meet the specific minimum. The developer can also set the condition to run a new EC instances to reduce latency. Also, AWS Elastic Load Balancer support application within Amazon VPC for stronger network security. The IT team can determine which they want an internet-facing load balancer or internal load balancing. The latter option allows the developer to route traffic through ELB using private IP addresses. Also, when we talk about traffic distribution, ELB evenly distributes incoming traffic across multiple computing resources, such as EC2 instances or containers, to ensure that no one or no resource is overloaded while others remain idle. This helps to optimize the use of resources. So here you will use that route robin system if you remember. Then when we talk about availability and fault tolerance, ELB improves the availability of your applications by automatically detecting and directing traffic away from unhealthy or unsuccessful targets. If the target becomes unhealthy, the ELB stops sending traffic towards it until it recovers and reducing the impact of potential failures. Then you can use for automatic scaling. ELB can automatically scale the capacity of its load balancer in response to change in incoming traffic. This ensures that your application can handle the increased traffic load without minimal intervention. Also, there is something called health checks. You can configure health checks that periodically assess the health of your computing resources. ELB routes traffic only to resources that pass these health checks, helping to maintain the overall reliability of your application. And there is something called offloading encryption. Elastic Load Balancer can offload the work of encrypting and decrypting, reducing the compute load on your computing resources and allowing them to focus on the primary task. Let's hop to our console and see how can we create our load balancer. Now that we know what is Elastic Load Balancer, let's see a simple example how can we create this resource in our console. I will go first to my EC2 instance. As you can see, I'm using North Virginia region. So let's go to EC2 instance, and if I go to instances, I don't have any instance right now, but let's create a new one. Let's click on launch instance. I will add a simple name for this instance. This will be VM1, for example. I will choose Ubuntu server 2404 LTS Amazon machine image. As you can see, this is a free tier eligible. And finally, I will use my T2.micro family instance type with 1 vCPU and 1 GB of memory. Then if I go to key pair, as you can see, I can use my VM key pair, demo key pair that we created in the beginning of this course, and the third one is VM KP1. I will proceed without a key pair, but it is not recommended. Only for demo purposes, I will use this option. Then I will not edit anything about my network settings, so I will use my default VPC. As you already know, when you create your account, AWS automatically provides virtual private network and default subnets in every region, in every AZ. So here we will create our new security group, and I will simply allow SSH traffic from anywhere and allow HTTP traffic from the internet. And finally, we will leave everything as it is. I will simply click on launch instance. We are launching our instance, and as you can see, if I check my logs, you can see that everything succeeded. So let's go to our instances, and as you can see, our VM is up and running, but we need to wait for our status check to be initialized. It is located in East US 1A. This is our availability zone, as you can see, and this is our public IPv for DNS, our public IP address. We don't have any elastic IP, and as you can see, the date of creation, and we are using Linux Ubuntu, pure Linux Ubuntu. Then here you can see every other information, but let's leave this as it is. I will now wait for this machine to be initialized, and then, or simply we can try to connect using EC2 instance connect. Let me hit on connect, and as you can see, we are connected to our pure Linux VM. I will now run sudo apt update to update with the latest packages our Ubuntu server. And then it's always good to run one more command, and that command is sudo. Sudo means super user do. This command will give you administrative privileges. So when you run, every time when you run sudo, you run apt and then full upgrade to upgrade everything that we just downloaded, and -y means yes. So here is simple option how can you update your Linux web server or Linux instance. Mainly in my practices, I like to use Ubuntu Linux or Debian, but also you can use different option like Amazon Linux. It really depends what do you want to achieve or what do you want to use. So we're waiting a few more percent for this progress to be finished. And then after that I will install just a few moments. I will install Nginx server. So as you can see, it restarted services. And after this, we will be able to install our sudo apt install Nginx command. Let me just refresh once again this machine, and as you can see, it is running and status check is passed. So our machine is up and running. I will now simply run my sudo apt install, and we will install our nginx-y. And as you can see, it's so easy to install Nginx server to your machine. And if I, for example, copy public IP address of my virtual machine, we will get a message, or we should get a message, welcome to Nginx, as you can see. So this is how can you do a first part of this lab. How can we create simple Ubuntu instance, simple VM, sorry, based on pure Ubuntu image. Now, if I go back to my EC2 instance, I can, for example, go to cd/var /ww/html. There was a mistake. So cd/var/www/html. We are now in our folder, and if I type ls, you will see that we have this index.nginx-debian-html. So I want to run sudo nano index.html. So I'm creating a new, I'm using this editor, and then I can type some simple message. After that, we simply need to run Ctrl O, hit on enter, and Ctrl X to leave this nano editor. And then if I type ls, you will see that we have two messages, index.html and index.nginx-debian.html. I will now simply run sudo rm to delete this address. Let me copy this and paste it here. So we need to add L. And if I now type ls, you can see that we have only index.html. Now, if we go to our public IP address and refresh this page, we are getting our message, welcome from our VM1, and I'm learning from Vlada's AWS course. So this is just another example of how can you add your own website or your message or something else. Now that we have our VM ready to go, let's open a new window, and in the same region, I will now go to my Elastic load balancer. Load balancers. And here from EC2, I can create a new load balancer. First, as you can see, we have different types of load balancers. We have application load balancer, network load balancer, gateway load balancer, and classic load balancer, which is now retired. But first, we need to create something called target groups. Let's first create our target group. I will hit on target group. Let's hit on create target group. I will use instances in the first step, but you can choose your target type to be IP addresses, Lambda function, application load balancer. Then this target group name will be, for example, TG1. Protocol will be HTTP port 80. We will be using our IPv4 address type. You can also use IPv6 if you want. Then we are using our default VPC from our North Virginia, of course. Protocol version is HTTP1, and health check protocol will be HTTP, and you can leave everything as it is. Also, there is advanced health check. If you want, you can set up your health check port, and every time when this health check every 30 seconds, this health check port will check your virtual instance or your virtual machine, and when success code return with 200, that usually means that your machine is healthy and it's working. Then we can simply add a tag if you want. I won't add any tags, and let me hit on next. Here we have our machine. This is our VM1. You can also create 3 or 4 machines, and all these machines will be part of this target group. Or you can create 2 or 3 maybe target groups and add a different VMs. But for now, let's make it simple, and we will now add our machine to our target group. Let's click on next, and let's click on review and create this target group. So our target group is created, and we have our target group, as you can see, and health status is target is not configured to receive traffic, and status is unused. Then if I go to load balancer, let's hit on create load balancer. Here you can see all load balancer that we can use here, and if I click here, you can see that we have classic load balancer. This is from previous generation, and usually AWS recommend that we use these 3: application load balancer, network load balancer, and gateway load balancer. For now, we already know what is application load balancer, so in this exercise I won't talk about network load balancer and gateway load balancer. We will learn more about this 2 load balancer when we get to our networking part of this course. Let me hit on application load balancer, and I will hit on create. Application load balancer, just to remind you, work on layer 7, and it can run HTTP and HTTPS traffic. I will hit on create, and now we need to add our basic load balancer name. This will be LB1, for example. I want to choose my internet facing load balancer. Of course, you can create internal load balancer. We are using IPv4, only IPv4, but you can use dual stack. It usually means that includes IPv version 4 and IPv version 6. Then in the networking mapping, I will use my default VPC. Then we can add all our subnets, but we are using only the first one. If you remember, our VM is located in subnet A, 1A, just to show you once again, US East 1A, and this is US East 1A, but I will add all 6. Then for the security group, I have different security groups, and we will add all security groups. For example, to be honest, I don't know what security group I'm using, but for the simplicity, let's add all of the security group. We are using a listener on protocol HTTP on port 80, and then here we need to select our target group. You can forward to target groups, routing action, redirect to URL, or return fixed response. I will simply choose my TG1. As you can see, this is we have one instance here, and I will not use target group stickiness. And let's make it simple and leave everything as it is. As you can see, this is our summary. And finally, let's click on create load balancer to create our load balancer. And as you can see, in a few minutes, our load balancer will be provisioned, and this is how can you create your load balancer. I will now stop here and wait for this status to be provisioning, so we will continue that. And after a few minutes, as you can see, our status for our application load balancer is active. And if I go to our instance, as you can see, and if I scroll down to load balancing, choose our target groups, you can see that now our target group is, as you can see, is associated with our load balancer and with our VPC ID, as you can see. Now let me go to our instances. Let me go to our load balancing details, and if I, for example, copy this DNS name of our load balancer, this is the name of our load balancer, then the name of our region, and we have amazon.com. We are using a record, and let me open a new tab. I will paste this DNS name, hit on enter. As you can see, we are getting exactly the same message. Welcome from our VM1, and I'm learning from Vlada's AWS course. If you remember, exactly the same message we are getting if we are using public IP address of our VM. But now our VM is behind our load balancer. So this is how can you, this is just a simple explanation and demonstration of how can you use our application load balancer. Of course, when you're working with some modern infrastructure, this virtual machine will be behind load balancer in private subnet. So this subnet will not, it cannot reach internet, of course, and it cannot be reachable from internet, of course. Then in the private subnet, there will be VM. In public subnet, we can create something called NAT gateway. Then we will add some rules for that NAT gateway in our security group. So, and then that virtual machine will be able to reach the internet. Of course, this is a modern option. This is a preferred option. In this demonstration, I'm using only simple demonstration to show you how can you create and work with a load balancer. If we now go to our EC2 instance, and for example, let's go to our security group. As you can see, we are using our default security group, if I remember correctly. We have our inbound rule, and as you can see, we have one outbound rule. So if I remember, just let me check our instance, and in our security, so we are using wizard 4. This is our security group, and as you can see, this is our security group that we are using. We are using SSH, and that's it. For the outbound rule, we use again both of these rules. So we are using this default option, nothing special, nothing complicated, and that's it. I will now first delete our load balancer. Here we can delete our load balancer. I will hit on delete and type confirm. Let me hit on delete. Our load balancer is deleted. Now let's go to our target groups. As you can see, our target group is now not associated with any load balancer. I will now delete our resource group, target group. It's deleted. Finally, let's go to our instance, and we will delete our instance that we used in this demonstration. Simply click on terminate and delete instance. And that's it. Shutting down is initiated, and very soon our machine will be terminated. Thank you for watching. Now it's time to get to know about new topic, and in this lesson we will talk about auto-scaling group, and then we will see in the practical part how can we create this resource. Well, in AWS, an auto-scaling group, or ASG, is just a collection of Amazon EC2 instances that are managed as a group to ensure that the right number of instances are running to handle the load of an application. ASGs allow for automatic scaling, allowing you to adjust the number of instances based on demand, improving availability and reducing cost. Autoscaling is an Amazon Web Service that allows instances to be scaled when traffic or CPU load increases. Autoscaling is a service that monitors all instances that are configured in an autoscaling group and ensure that the workload are balanced across all instances, depending on the load scaling group. Increase the instance according to the configuration. So, when we create the autoscaling group, we configure the desired capacity, minimum capacity and maximum capacity, and CPU utilization. If, for example, CPU utilization increase by 60% across all instances, another instance will be automatically created. And if CPU decrease, this utilization decrease by 30% across all instances, one instance is terminated. This is entirely up to us. So, what are our requirements are? This is something simple as VMSS, if you remember, in Azure. If either instance falls for any reason or failed for any reason, the scale group maintains the desired capacity and starts another instance. So, the autoscaling group monitors horizontal scaling. This service is very important for us today because we do not have to manually create new instances and do not require manual monitoring. AWS autoscaling is used to scale an EC2 instance depending on incoming traffic. You can scale apps in minutes based on traffic, which will reduce app latency for end users. You can also integrate AWS autoscaling with multiple services that is provided by AWS, such as Amazon Traffic, Amazon DynamoDB, and Amazon Aurora. You can also reduce the cost of an application due to dynamic scaling. When there is traffic, only the maximum number of resources is used. Otherwise, the minimum resources will be used. Also, there is something calling dynamic scaling. AWS autoscaling services does not require any manual intervention. It will automatically scale the application depending on the incoming traffic. Also, you will pay per use. Due to automatic scaling, the resources will be used in an optimized way. When demand is low, resource utilization will be low, and demand high, resource utilization will increase. So AWS will only charge you for the amount of resources you actually used. Also, there is an option for automatic performance maintenance. In the AWS autoscaling maintenance maintains optimal application performance, taking into account workloads, ensuring that the application is running at the desired level, which will reduce the latency and capacity will increase based on your application. And as you already know, our autoscaling in AWS will scale the application based on the application load instead of manually scaling. And AWS autoscaling will automatically scale the application when incoming traffic is high, increasing it and then decreasing it when traffic is low. First, you need to choose what service or application you want to scale. Then choose an optimization method, such as cost and performance, and then monitor how scaling works. If you have an EC2 autoscaling group with running instances, and you decide to delete the ASG, the instances will be terminated and the ASG will be deleted. A startup configuration is a template that the EC2 autoscale group uses to start EC2 instances. When you create a boot configuration, you need to provide information for instances such as what is the Amazon machine image ID, what are your instance type, key pair, and one or more security groups, and then device block mapping. If you have already started an EC2 instance, you provided the same configure information to start the instance. When you create an EC2 autoscale group, you must specify the startup configuration. You can also specify a startup configuration with multiple EC2 autoscale group. However, you can specify only one startup configuration for an EC2 autoscale group at a time, and you can't modify the startup configuration after you created it. Therefore, if you want to change the startup configuration for your EC2 autoscale group, you must first create a startup configuration and then update your EC2 autoscale group with the new startup configuration. When you change the startup configuration for your EC2 autoscale group, all new instances are started using the new configuration parameters, but the existing instances are not affected. So once again, we are in our console, and if you forgot, we are talked about ASG, or autoscaling group. So if you go to our EC2 instance and scroll down, you can see autoscaling and autoscaling group. The first thing you want to do is to create something called templates. So let's go to launch templates, and we will create a new template. So you can use launch templates to automate instance launches, simplify these policies, and enforce best practice across all your organization. After we create this launch template, which is necessary, then we will go back to ASG. First, when you want to run or create a template, you need to add a name and description for this template. I will add a name for my template, add a simple version description. This will be version 1, for example. And in the autoscaling guidance, you can check this box to provide guidance to help to set your autoscaling group. You can add tags. You can also add your source template if you want. I don't have any source template, so I will leave this as an empty. And then here I can choose what AMI image I want to use. I will use my Amazon Linux. This is Amazon Linux 2022, as you can see. And then we need to choose our instance type. I will choose my t2.micro. Then we need to specify our key pair login. I already have existing key pair. If you don't have, create a new one. And then in the networking settings, you have option to do not include this subnet in your template. I want to choose my subnet. This will be US East 1C for our North Virginia. And then I want to create a new resource group, new security group. If you want, you can create existing one. This is our default ASG. So as you can see here, you can remove subnet for creating this template. So I will now go to subnet and choose not to create this. So you can specify your security group here, and then if you click on information, you can see everything else. So there is so much information here. I will stick with default ones. So we need to remove this subnet if we want to create this template. Let's make it simple. So I will choose do not include this into my template, and we are creating our template. As you can see, our template is created, and this is our ID and name and the version. And then we will scroll down and go to autoscaling group, and I will click on create autoscaling group. There is a lot of steps that we need to do. The first one is to add a name for this scaling group. I will choose my template. This is our template that we created in previous steps. This is our version 1, and you can see all other information. Then in this step 2, we need to choose instance launch options. This is our VPC. I can now choose my AZ or subnet. that is located in this AZ, and you can choose your availability zone distribution. You can choose for balanced best effort. If one launches fail in one AZ, autoscaling will create or try to create this template or ASG in another healthy availability zone. So this is a very good option. And you have balanced only. If you choose this option, then you will do it manually. Of course, you can add load balancing options if you want. If you have no load balancer, we will talk about load balancer in our other part of this course when we talk about network. And let's make it simple and go to next. Our next step is to choose our group size. So you must set the initial size of your autoscaling group. You need to specify the desired capacity. I will leave as 1, minimum capacity is 1, and maximum is 3. So this scaling will take maximum for 3 VM. So in the metric type, you can choose to target tracking scaling policy. Target value is 50 and average CPU utilization is 50. So every time this, and of course you can choose your policy. Every time that your CPU goes above 50%, new VM will be created. And then in here you can choose a replacement behavior that, depending on your availability requirements, I will choose no policy. You can also choose launch before terminating, terminated launch, and custom behavior. So here you can control your auto-scaling group availability during instant replacement events. This includes health checks, instance refreshes, maximum instance lifetime features, and events that happen automatically to keep your group balance, called rebalancing events. So, for example, if your virtual machine gets terminated, you can choose this option and choose how do you want to your machine, that unhealthy machine, be replaced. And finally, we will go to the final 7th step of this wizard and click on create autoscaling group. As you can see, AWS now provisioning our autoscaling group. I won't take part of this in this survey. As you can see, we are now in our autoscaling group. This is our name of our HG1. This is our template. It running is default version. We don't have any instances for now, and you can see what is the desired capacity. Minimum and maximum is 3. Also, you can see the name, what AZ we are using. We are using US East 1A, located in North Virginia, and we are waiting for this status to be updated, this capacity to be updated. And as you can see, this is how can you create your auto-scaling group. Of course, this is similar service as VMSS in our virtual machine scale set in our Azure cloud. So there is really no difference or a little difference between these two services. But as I already stated, this course is not here to talk about differences between these two cloud providers. We are here to learn about VMSS and autoscaling group in this lecture. So we are still waiting for our capacity to be updated, and after some time I hope that this autoscaling group will be finished with this creation. In the meantime, we can go inside our ASG, for example, because we are still waiting and it takes some time to update this capacity. And if you go to inside our ASG that we just created, you can see that we have a lot of options, like some details and some other stuff. If we go to images and go to autoscaling groups, you can see that we have one autoscaling group. And with autoscaling group, or to edit this option, and as you can see, what is our capacity, what is our desired capacity, and we have a lot of options that we can choose from. You can set your auto-scaling options here, create a dynamic auto-scaling options or predictive scaling policy, for example. So if you go to create our dynamic scalability, you can choose target policy, for example, choose your, for example, average network in bytes, and here we can set the target value and click on create. So with this we can create our target policy, and this policy will be enabled. You can see our instance management, what is our lifecycle, our status of this auto-scaling group is healthy, and here we can see auto-scaling group metric collections, and you can see your EC2 instances that is a part of this auto-scaling group here. And now I will delete this auto-scaling group because we are finished with creating, and that's it. This is how can you create your. In software engineering, containerization is an operating system level virtualization of application level virtualization across multiple network resources, so that software application can run in isolated user spaces called containers in any cloud or non-cloud environment, regardless of type or vendor. Each container is essentially a fully functional and portable cloud or non-cloud computing environment that surround the application and keep it independent of the other environments running in parallel. Individually, each container simulates a different software application and run isolated processes by merging related configuration files, libraries, and dependencies. But together, multiple containers share a common operating system core. Recently, containerization technology has been widely adopted on cloud computing platforms such as Amazon Web Services, Microsoft Azure, Google Cloud Platform, and IBM Cloud. There are two types of container: OS and applications. Container clusters need to be managed. This includes functionality to create cluster, upgrade software or repair it, load balance between existing instances, scale by starting or stopping instances to accommodate their number of users, logging activity, and monitoring of produced logs of the application itself by querying sensors. Implementations of such open source software include OCD and Rancher. A large number of companies provide container cluster management as a managed service, such as Amazon, Google, and Microsoft. Containers are technologies that allow application to be packaged and isolated within entire execution environment, all the file necessary to run. This makes it easy to move the container application between environments like development, testing, production, etc., while maintaining full functionality. Containers are also an important part of IT security. By building security in the container pipeline and defending the infrastructure, containers remain reliable, scalable, and trustworthy. You can also easily move a containerized application between public, private, and hybrid cloud environments and data centers or on-premises with consistent behavior and functionality. Imagine you are developing an app. You do your work on a laptop and your environment has a specific configuration. Other developers may have slightly different configurations. The application that you develop relies on this configuration and depends on specific libraries, dependencies, and files. Meanwhile, your enterprise has development and production environments that are standardized with their own configurations and their own sets of support files. You want to emulate these environments as much as possible locally, but without all the additional cost of recreating the server environment. So how do you make your application work in these environments? Pass quality assurance and get the application deployed without major headache, rewriting and fixing. Answer is containers. The container in which your application resides has the necessary libraries, dependencies, and files so that you can move it through production without unpleasant side effects. In fact, container image content created using open source tools can be considered an installation of a Linux distribution because it comes complete with RPM packages configuration files, etc. But distributing a container image is much easier than installing new copies of operating system. Virtualization allows you to operate your operating system, Windows or Linux, to run simultaneously on a single hardware system. Containers share the same operating system kernel and isolate application processes from the rest of the system. For example, ARM Linux system run ARM Linux containers. x86 Linux system run x86 Linux containers, and so on. Linux containers are extremely portable, but they must be compatible with underlying system. What does it mean? Virtualization uses a hypervisor to emulate a hardware, which allows multiple operating systems to run side by side. It's not as easy as using a container. When you have limited resources with limited capabilities, you need lightweight applications that can be distributed. Linux containers run natively on the operating system, share it across all your containers, so your application and services remain lightweight and run quickly in parallel. Linux containers are another revolutionary leap in the way we develop, deploy, and manage applications. Linux containers images provide portability and version control, helping to ensure that what works on developer's laptop also works in production. A special type of a container image called the golden image creates a consistent, reliable basis for system configuration. Compared to VMs, running a Linux container requires less resources, has a standard interface like start, stop, environment variables, etc., retain the isolation of the application, and it's easier to manage as part of the larger application, like multiple containers. In addition, this multi-container application can be orchestrated across multiple clouds. To understand how microservices work at rest, we need to familiarize ourselves with the monolithic infrastructure. A monolithic architecture is a traditional software development model that uses a single code base to perform multiple business functions. All software components in a monolith system are independent due to the data exchange mechanism within the system. Modifying a monolithic architecture is restrictive and time-consuming because small changes affect large areas of the code base. In contrast, a microservice is an architectural approach that assembles software into small independent components or services. Each service performs a single function and communicates with other services through a well-defined interface. Because they work independently, you can update, modify, deploy, or scale each service as needed. A microservice is an architectural and organizational approach to software development where software consists of small, independent services that communicate through well-defined APIs. These services are owned by small, self-contained teams, and microservices make application easier to scale and faster to develop, enabling innovation and accelerating time to market the new feature. Let's talk about monolithic versus microservice architecture. With a monolithic architecture, all processes are tightly connected and run as a single service. This means that if one application process experiences a surge in demand, the entire architecture must be scaled. Adding or improving the feature of a monolithic application becomes more complex as the code base grows. This complexity limits experimentation and makes it difficult to implement new ideas. Monolithic architecture adds risk to application availability because many dependent and tightly coupled processes increase the impact of a single process failure. With a microservices architecture, and application is built as independent components that run each application processes as a service. These services communicate through a well-defined interface using lightweight API. Services are built for business opportunities, and each service performs a single function. Because they run independently, each service can be updated, deployed, and scaled to meet the demand for specific application functions. Characteristics of microservices is that they are autonomous. Each component of a service in a microservice architecture can be developed, deployed, managed, and scaled without affecting all of other services. Services don't have to share their code or implementation with other services. All communication, individual components take place through well-defined APIs. Specialized, each service is designed for a set of capabilities and focuses on solving a specific problem. If developers give more code to the service over time and the service becomes complex, it can break down into smaller services. Advantages of microservices: agility. Microservices nurture an application of small, independent teams that take ownership of their services. Teams operate in a small and well-understood context and are empowered to work more independently and quickly. This shortens the development cycle, and you can benefit significantly from the overall throughput of the organization. Flexible scaling. Microsoft allows each service to be independently scaled to meet the demand for the application, function it supports. This allows teams to build infrastructure needs, accurately measure the cost of a feature, and maintain availability if the service experiences a surge in demand. Microservices allow for continuous integration and continuous delivery, making it easy to try new ideas and come back if something doesn't work. The low cost of failure allows for experimentation and makes it easier to update code and speed up time to release new features to market. Microservices architecture don't follow a one-size-fits-all approach. It has technological freedom, and teams have the freedom to choose the best tool to solve their specific problems. As a result, microservices teams can choose the best tool for each job. You can then use reusable code. Dividing the software into small, well-defined modules allow teams to use features for multiple purposes. A service written for a particular function can be used as a building block for another function. This allows the application to run on its own, as developers can create new capabilities without writing code from scratch. The independence of the service increases the application resilience to failure. In a monolithic architecture, if one component fails, it can cause the entire application to fail. With microservices, applications deal with complete service failure by degrading functionality and not crashing the entire application, so they are resistant. A microservices architecture requires more planning and design before starting. Developers need to identify different functions that they can work independently and plan for consistent API. However, initial coordination makes maintaining the code much more efficient. You can make changes and find errors faster. Code reuse also increases over time. Monolithic applications are simpler than microservices. Developers install the entire application, codebase, and dependencies in a single environment. In contrast, the deployment of microservice-based application is more complex, since each microservice is independent software package that can be deployed. Programmers usually containerize microservices before deploying them. Containers package code and associated microservice dependencies for platform independence. Debugging is a software process for identifying coding errors that cause an application to behave incorrectly. When debugging a monolithic architecture, a programmer can track the movement of data or examine the behavior of code within the same programming environment. Meanwhile, identifying coding problems in a microservice architecture requires looking at multiple loosely related individual services. Debugging microservice application can be more challenging because several developers can be responsible for many microservices. For example, debugging may require coordinated test discussions and feedback among team members, which requires more time and resources. A small change in one part of a monolithic application affects multiple functions of the software due to a small change in one part of a monolithic application affects multiple functions of the software due to a tightly coupled coding. In addition, when developers make new changes to a monolithic application, they must retest and redeploy the entire system on the server. In contrast, access to microservices allow for flexibility. It's easier to make changes to the app. Instead of changing all services, developers only change certain functions, and they can also independently apply certain services. Such an approach is helpful in the continuous workflow in an application where programmers make frequent small changes without affecting the stability of the system. Scaling of monolithic application and face several challenges as they scale. A monolithic architecture contains all the functionality within a single code base, so the entire application must scale as requirements change. For example, if an application performance deteriorates because the communication function experiences an increase in traffic, you need to increase computing resources to accommodate the entire monolithic application. This results in a loss of resources because not all parts of the application are at peak capacity. Meanwhile, the microservices architecture supports distributed system. Each software component receives its own computing resources in a distributed system. These resources can be independently scaled based on the current capacity and anticipated needs. For example, you can allocate more resources to a geographic location service instead of the entire system. Both microservice and monolithic application have costs during development, deployment, and maintenance. However, the microservice approach is more cost-effective in the long run. You can scale microservices application horizontally by adding computing resource on demand. You only need to add resources for an individual service, not for the entire application. To scale monolithic systems, companies need to upgrade memory and processing power for the application as a whole, which is more expensive. In addition to infrastructure cost, the cost of maintaining monolithic application also increases as requirements evolve. For example, sometimes developers need to run outdated monolithic software on newer hardware. This requires custom knowledge, and developers have to rebuild the app so that it remains operational. Meanwhile, microservices operate independently of specific hardware and platforms, which keeps organization from costly upgrades. A monolithic approach is more suitable when designing a simple application of prototype. Because the monolithic application uses single code base and framework, developers can build software without integrating multiple services. Microservice application can require significant time and effort in design, which does not justify the cost benefit of a small project. Meanwhile, a microservice architecture is better for building a complex system. It provides a robust programming foundation for your team and supports their ability to flexibly add more features. For example, Netflix uses AWS Lambda to increase its streaming infrastructure and save development time. Despite this flexibility, developing using microservices requires a different set of knowledge and design thinking. Unlike monolithic application, developing microservices requires an understanding of cloud architecture, APIs, containerization, and other expertise specific to modern cloud applications. Moreover, troubleshooting microservices can be a challenge for developers who are new to a distributed architecture. A monolithic application runs on a single server, but microservices applications benefit more from a cloud environment. While it is possible to run microservices from a single server, developers typically host microservices with cloud service providers to ensure scalability, fault tolerance, and high availability. You need to have the right infrastructure in place before you can start with microservices. You need more effort to set up the tools and workflow for microservices, but they are preferable for building a complex and scalable application. So, in this chapter, I will talk about what is the benefits of containerization. Every day, developers find a new way to put containerization to work. To solve their challenges, containerization can produce unique benefits for your application. Here are some of the most common reasons for developers or other users, of course, to decide to containerize. First is portability. Second is efficiency, and you can see all the rest. But let's say something about portability. No discussion of containerization is complete without at least one of the mention of the motto write once, run anywhere. Because a container handles dependencies, you can take your application just about everywhere without rebuilding it for each new environment. The abstraction provided by containerization ensures that your container works the same way no matter where you deploy. That means that you can take your app to the cloud, run it on a VM, or go directly to the app to the cloud, or run it in a single VM, or go directly to bare metal server. As long as the host operating system supports your containerization tool, such as Docker, you are ready to deploy this with minimal hassle. Then we have efficiency. Containerization is one of the most efficient methods of virtualization available to developers. Containers improve efficiency in two ways. They use all available resources and they minimize overhead. When properly configured, containers allow a host to take advantage of virtually all available resources. Isolated containers can also perform their operations without interfering with other containers, allowing a single host to perform many functions. Containers also remove the need for virtualized operating system, hypervisors, and other bottlenecks that virtualization technique introduce. Unlike VMs, which rely on their virtual kernel, containers use the host operating system kernel, and this drastically reduce overhead and minimize resource of the use. Agility. Containerization is a crucial tool for streamlining DevOps workflows. You can create containers rapidly, deploy them to any environment, and then use them to solve multiple diverse DevOps challenges. When a task presents itself, you can quickly develop a container to handle the job. Then you can automatically shut it down until you need it again, and this process is called orchestration. Technologies like Kubernetes automate the process of coordinating, managing, scaling, and removing containers. You can think of Kubernetes, for example, as the conductor of your container orchestra. With the help of Kubernetes coordinated containers, developers or users can rapidly respond to a problem and spin up new solution without worrying about lengthy and complicated deployment. Then we have faster delivery. How long does it take to go from concept to implementation? Generally, the bigger an application, the longer it takes to get any improvements implemented. Containerization solves this by compartmentalizing your application. You can divide even the most enormous beast of an application into discrete parts using microservices. So we already know what are microservices, and microservices take apart much larger applications by segmenting pieces into containers. This division makes it much easier for developers to implement changes and deploy new code. You can change isolated areas of the application without affecting the whole. Continuous integration, or CI, is a natural partner for containerization. CI automates the process of merging, testing, and building new code. Many modern CI/CD pipelines output a container image as their final step. Then, one of the benefits is improved security. The isolation introduced by containerization also provides an additional layer of security. Because containers are also isolated from one another, your applications are running in their own self-contained environment. That means that even if the security of one container is compromised, other containers on the same host remain secure. Containers are also isolated from the host operating system and can only minimally interact with computing resources. This is inherently more secure way to deploy application. Then we have faster and app startup. Compared to other methods of virtualization, containers are quite lightweight. One of the many benefits of being lightweight is a rapid startup times, because the container doesn't rely on a hypervisor on virtualized operating system to access computing resources. Startup times are virtually instantaneously. The only limiting factor is the application itself. with no substantial overhead to wait for. The only startup delay is from your code. Rapid startup is a great reason for frequent updates and improvements. Then we have flexibility. Well, with flexibility, containerization allows developers or users or admins to versatilely operate their code in either a virtualized or bare metal environment. Whatever the demand of deployment, containerization can rise to meet them. Should there be a sudden need to retool your environment from metal to virtual or vice versa, your containerized applications are already prepared to make the switch. Containerized apps using microservices can become more flexible, that you can host certain elements on bare metal and deploy others to virtual cloud environment, for example. Then you can deploy to hybrid cloud environments that utilize a mixture of bare metal, on-premise, and various cloud providers. With the portability of containers, you can also select the most effective way of hosting the different service in your app. When you think with containers allow developers to conceptualize their available resources, that might mean squeezing an extra drop of processing from a machine at maximum capacity. Or it could mean finding that what before seemed like a resource limitation was simply an opportunity to innovate. And finally, one of the benefits is easier management. Kubernetes, for example, offers a variety of tools that simplify container management, like rollbacks and upgrades, as part of the platform. It also handles installation. There are self-healing features, so you can use that to attempt to recover failed containers, for example, terminate containers that fail health checks, and constantly monitor your container health and status. Kubernetes also automates resource management, so you can allocate each container a set of amount of CPU and RAM to handle the task or its task. Ultimately, managing containers with the help of a tool such as Kubernetes is leaps and bounds easier than traditional application management methods. So these 8 reasons are benefits of containerization. Let's move to the next chapter. I'm sure you heard of Docker in the previous chapters, so it's time to get to know what Docker is. Docker is a set of platform as a service or PaaS products that use OS level virtualization to deliver software in packages called containers. The service has both free and premium levels. The software that hosts the containers is called the Docker engine, and it was first released in 2013 and developed by Docker Incorporated. Docker is a tool used to automate the placement of application in lightweight containers so that application can run efficiently in a variety of isolated environments. Containers are isolated from each other and bring together their own software, libraries, and configuration files. They can communicate with each other through well-defined channels because all containers share the service of a single operating system core. They use fewer resources than the virtual machine. Docker can package an application and its dependencies into a virtual container that can run on a Linux, Windows, or Mac OS computer. This allows the application to run in a variety of locations, such as on-premises, public, or private cloud. When running on Linux, Docker uses Linux kernel resource isolation features such as C groups or kernel namespaces and a union-capable file such as overlay fs to allow containers to run within a single Linux instance, avoiding the overhead of running and maintaining a virtual machine. Docker on macOS uses a Linux virtual machine to run containers. Because Docker containers are lightweight, a single server on virtual machine can run several containers at a time. A 2018 analysis found that a typical Docker use case involves running 8 containers per host, and that a quarter of the organization analyzed are running 18 or more per host. It can also be installed on a single board computer such as Raspberry Pi. Linux kernel support for namespaces generally isolate the app view from the operating environment, including process trees, network user IDs, and mounted file system, while kernel C groups provide resource limitation for memory and CPU. Docker implements a high-level API to provide lightweight containers that run processes in isolation. The Docker registry is a repository for Docker images. Docker clients connect to registries to download or pull images for use or upload push images that they have created themselves. Registries can be public or private. The main public registry is the Docker Hub. Docker Hub is the default registry where Docker searches for images. Docker registries are also allow you to create event-based notification. Azure Container Registry, as we see in the previous chapter, allows you to create, store and manage container images and artifacts in a private registry for all types of container deployments. You can use Azure Container Registry with existing pipelines to develop and deploy containers. You can use Azure Container Registry task to create container images in Azure on demand, or automate builds that run source code updates, base container images, updates, or timers. Azure Container Registry is a managed registry service based on the open source Docker Registry 2.0. You can create and maintain Azure Container Registry to store and manage container images and related artifacts. Also, you can build on demand or fully automate builds with triggers such as source code commits and base image updates. Welcome back. We are in our console. Let's go to EC2 service and let's launch a new instance. As you can see, our instance is very easy to add, to create. I will add VM Docker 1, and as you can see, if you click on add tags, we can add our tags or key value pair for our VMs. We can add 50 tags for instance, and also you can check your name here and add your value, for example. Then for the resource type, you can choose instances, volumes, instance request, and network interfaces. I will leave instances, and as you can see, besides that tags are only simple key value pair, the tags can be very, very useful for if you have more hundreds of virtual machines, for example, or instances. Then you can filter your VMs, for example, by key, by value, by cost allocation, by environment, and so on. So, for example, if you add a new tag, you can add key, for example, environment, and value will be production, and so on and so forth. So you can add 50 more tags if you want. I will add my Ubuntu Linux. We are using Ubuntu Server 2404 LTS. As you can see, I'm using my t2.micro. Instance type for the key pair, I will use my first without key pair, and we are creating our security group, and I will add now all three options, and we are ready to go. Let's click on launch instance, and our instance will be created in a matter of seconds. Here it is. Let's go inside our instance. This is our instance detail, and it's still provisioning, but it's running. If I hit on connect, let's use our instance connect, EC2 instance connect, and as you can see, we are connected. Now, if let me just go to my instances. I already tried this exercise in previous chapter, in today, of course, before I start recording, and our VM1 Docker is still initializing. These two virtual machines are terminated. Now, we are interested on how can we run Docker in our EC2 instance. If I go to Ubuntu website or docs.docker.com/engine/install Ubuntu, you can see how can you install Docker engine on your Ubuntu VM. To install Docker Engine, as you can see, you need 64-bit version of one of these Ubuntu versions, like Ubuntu Questing 25.10, and we have Noble 24.04 and Ubuntu Jammy 24.0. So the first thing we need to do is to, if you want to uninstall all conflicting packages, simply run this command with sudo apt remove, and you can simply copy this. But we have a fresh virtual machine created, and we don't have any options to run this. We don't have any reason to run this because we are not installing our machine is fresh and empty, to say that. Let's first set up Docker apt repository. I will copy this command, and with this command we will be able to run. As you can see, first we will update our package or server, then we will install CA certificate, then this sudo install will add some keyrings, and then we will download Docker, as you can see, official GPG key, and it will change our mode. Let me copy this and paste in our terminal, and I will run enter. After that, you can go one by one, but also you can use these group commands all at once. Let's hit on yes. Then, if you go back to our Ubuntu desktop documents, we can add a repository to apt sources. As you can see, we can add this Docker, Linux Ubuntu, and then we will run sudo apt update. Let's add a repository to apt sources. Let me just copy this once again. Let's go to our EC2 instance, and we will paste everything once again, and finally let's hit on enter. That's it. Now we can go back to our Ubuntu, as you can see, and then we need to install our Docker packages with the latest version. This will run sudo apt install docker CLI container D, Docker buildx plugin, and Docker compose plugin. Let me copy this command, and we will paste it in our terminal and hit on yes to confirm installation. And finally we are waiting for our Docker runtime to be installed on our virtual machine, on our EC2 instance. And finally we can verify our installation that is successful by running this hello world image. Simply you can run sudo docker run hello world, and if I copy this command, let's paste it here and let's hit on enter, and as you can see, it is completed. Now we can run, for example, sudo docker ps, and you can see that we have our Ubuntu container that is running from our Docker hub. As you can see, Docker did the following steps: install the Docker client, contact the Docker daemon, then the Docker daemon pulled the hello world image from the Docker hub, then the Docker daemon created a new container from that image which runs the executable that produces the output you're currently reading, and Docker daemon streamed the output to the Docker client, which sent to our terminal. And that's it. Of course, you can check all these pages here, and this is the most simplifying option. How can you how can you install Docker on your VM or your instance? And simply let's check sudo systemctl status docker to see if our Docker is running, is our container is running. As you can see, we are getting the response back that Docker service, Docker application container engine, is active and it's running. And this is our date, 28th of February 2026. And finally, you can see that all other informations, when this image is pulled, how it's pulled, and that's it. We can now simply go till the end, and we have more lines here, but it really doesn't matter. It matters that our Ubuntu is running and we are good to go. Now that we have our Docker, we can simply, as you can see, if I refresh this, our machine is status is good, it's working. Now we can terminate our instance, and when you terminate this instance, complete Docker runtime engine and this container will be deleted from our VM, because our instance or VM will be deleted. So it's shutting down and very soon it will be terminated. That's it. Thank you for watching, and let's continue. So in the previous chapters, we really learned a lot about container services in Azure. Now it's time to see container services in AWS. So AWS Container Services provides a set of tools for running, managing, and scaling container applications. These services, such as Amazon ECS, Amazon AKS, and AWS Fargate, offer different levels of management and abstraction, allowing users to choose the one that best suits their needs. They enable efficient deployment, consistent workflow, and simplified management and containers application, both in the cloud and on premises. Containers are, as we already know, lightweight, portable way to package applications and their dependencies, ensuring consistent execution across different environments. They isolate applications, preventing conflicts and dependency issues. So, why use container services in AWS? There is a lot of reasons. I will name just a few of them. First one is simplified deployment. Containers simplify the deployment process by packaging applications and dependencies into a single unit. Scalability and flexibility. So container services allow you to easily scale your applications up and down based on demand. Containers can work consistently across a variety of environments, including on-premises and various cloud platforms. Efficiency. Containers share the core of the host operating system, making them easier and faster to run compared to virtual machines. AWS Container Services can help optimize resource utilization and reduce infrastructure cost. So cost optimizations are very important. Then we have key AWS Container Services. I will name just a few of them. The first one is Amazon Elastic Container Service, or Amazon ECS. This is a fully managed container orchestration service that allow you to stop, start, and manage Docker containers on a clustered EC2 instance. Then we have Amazon Elastic Kubernetes Service, Amazon AKS. This is a managed Kubernetes service that simplifies the deployment and management of Kubernetes clusters on AWS. Then we have AWS Fargate. This is a serverless computing engine for containers that eliminates the need to manage servers or clusters. It works both with ECS and AKS. And we have AWS App Runner. This is a fully managed service that simplifies the deployment of container as web applications and APIs. Essentially, AWS Container Service offers a comprehensive set of tools to help you efficiently and reliably build, deploy, and manage containers applications. So in the next chapter, we will talk more about all these services. Amazon Elastic Container Service, or ECS, is a fully managed container orchestration service provided by Amazon Web Service. It simplifies the deployment, management, and scaling of containerized applications using Docker containers. ECS manages the underlying infrastructure, allowing users to focus on their applications instead of managing the infrastructure. Amazon Elastic Container Service is a fully managed service that allows users to run Docker-based application containerized in a cluster EC2 instance. ECS simplifies container orchestration, allowing you to efficiently deploy, manage, and scale containerized application. This service supports multiple boot types, including the AWS Fargate boot type, which abstracts the underlying EC2 infrastructure, allowing you to run containers without having to manage or provision EC2 instances. So this is a serverless offer. This allows developers or administrators to focus on building and deploying applications while AWS manages the cluster and provisioning of resources. Amazon Elastic Container Service, as I already told you, is a fully managed service provided by AWS. And now, of course, you can run it and scale it down and up depending on your traffic. So the containers will run inside an Amazon Elastic Cloud EC2 instance. What is a container? A container is a package that contains an application and all dependencies, libraries, etc. What kind of application is needed to run? Containers are independent of the underlying operating system, and therefore container applications are quite portable, flexible, and scalable. This ensures that the application will always work as expected, regardless of the system and environment in which container is running. Docker is a software that makes it easy and automates the installation of deployment of application within this Linux container. Cluster is just a logical group of EC2 instances that run as a single application, and container instance, well, each EC2 instance in an ECS cluster is called container instance. So practically this is our VM. Amazon Elastic Container Service, or ECS, as you already know, is a managed service for deploying, managing, and scaling containers. Here's a quick overview of its key component. The first one is security. Provisioning tools help to set up and manage ECS resources. We have AWS CLI, command line interface for direct control. Copilot simplifies EC5 workloads. Management console is just a graphical interface for managing ECS. And AWS CDK and SDK provides infrastructure as a code and custom integrations. Then we have controller. ECS scheduler manage and distribute tasks, balancing workloads, and ensuring availability across clusters. Capacity options. We have Amazon EC2 support a variety of capacity options. So Amazon EC2 instance, it is customizable hosting of virtual machines. Fargate, this is a serverless container hosting and infrastructure management. On-premises compute, extend ECS to an on-premises server for hybrid solutions. This framework offers flexibility and control for containerized applications in AWS and beyond. So this is a simple map on and Amazon ECS terminology and component. As you can see, first we have provisioning. This is Amazon Web Service command line interface. We have also Copilot, Management Console, AWS Service Cloud Developer Kit, Amazon Web Service Software Kit. We have controller. This is where our scheduler resides. And finally, in the capacity option, we have our Amazon EC2 instance, Web Service Fargate, which is a serverless offer, and we have on-premises compute. Let's hop to our console and see what we can learn in our practice part of this chapter. And finally, we are in our console. As you can see, we can go to search and search for our ECS service. And here, this is our Elastic Container Service. Let's go inside this service. And here, as you can see, This is our starting page, and we don't have any container. So here we can deploy our container as application, and as you can see, even Amazon here say that it makes it easy to deploy, manage, and scale Docker containers that run your application services and batch processes. So if I scroll down, you can see how it's work. This is a simple YouTube video. You can see what are the benefits and features. Optimize cost, so you can save your money if you use some of these spot instances, on-demand or reserved instances, and you can use it for batch processing and web application. Here you can check these tabs for your clusters, namespaces, task definition, and set up your account settings. If you go to task definitions, you will get information about what is task definition and how can you create a new revision or deploy a task definition as a service or a task. So there is a lot of option that you can choose from. Also there is a link to learn more on official pages, AWS pages. Here we have our account settings, and you can also view your account details, you can log as a log user and so on. So we have something called Amazon ECR, we have something called repository. This is all links to other services or documentation. If I go to clusters, blade, and click on create cluster, here we have option to create our cluster. First, I will add a name for my cluster. As you can see, an Amazon ECS cluster groups together tasks and services, allows for shared capacity and common configurations. And all of these services and tasks and capacity must belong to this cluster. So it is very important to set up our clusters. After we add a name, we have infrastructure. So our cluster is automatically configured for AWS Fargate with 2 capacity providers, and you can add your EC2 instances. Here you can create auto-scaling group if you want. Now we know what is auto-scaling group. And for the provisioning model, we can use on-demand or spot. On-demand instances, you will pay only for compute capacity by the hour with no long-term commitments or upfront payment. If you choose spot, then Amazon EC2 spot instances let you take advantage of unused EC2 capacity in the AWS cloud. So you can save up to 90% discount compared to these on-demand prices. Of course, we already know what is a spot instance and how to get your capacity. If you don't know, go back to our virtual machine section and you will learn more about this offering. Then, as you can see, if you choose your spot, you have allocation strategy, but if you choose on demand, you have option to choose instance Amazon machine type. So you can choose, for example, Amazon Linux, and this will optimize AMI for your machine. There is a lot of AMI that you can choose from. You can choose your family. This is our instance or ES instance type. T2.micro is fine for me. And here we can add our instance E2 rule. I have already one that is created. And here in the desired capacity, we need to specify the number of instances that will be launched in our cluster. So minimum is 0 and maximum is 2. I will add my existing key pair. If you do not have one, create a new one. And in the network settings, I will use default VPCs and all my subnets that are located in our North Virginia availability zones. I will choose my security group. This is all default security group, and you can auto assign IP or use subnet IP address. So here you will add your public IP address. And finally, there is an option for monitoring. There is also optional for recommended container insight. You can provide aggregated metrics at the cluster and the service level. So you can run deep dive and analog your log insight in CloudWatch, in some other services. But if you turn this off, this will provide default CloudWatch metrics only. So if you want to see the logs for this cluster, simply go to CloudWatch. And finally, we have our encryption and tags. This is also optional, and you can choose your KMS keys and simply choose this if you want. And finally, when we are satisfied with our cluster, we can also add a different name here. So for example, I will add some random name. This will be ECS1, and you can create your namespace to specify a group of services that make up your application. And finally, if I scroll all the way down, we can hit on create, and our cluster will be created after some time, of course. As you can see, this is our ECS1 cluster. We have no services, we have no container instances, and CloudWatch Monitor is default by our CloudWatch service. And if I go inside my cluster, you can see what is the overview of our cluster. You can view or create services. As you can see, we successfully created our cluster. You can update or delete this cluster right from here, and also you have option to run a task, see all infrastructure, go to metrics, schedule task, and so on. So here, as you can see, we have only one cluster, and here, as I already told you, you can create services, create task, see your infrastructure. We have, as you can see, our infrastructure ECS cluster that is automatically created by AWS. Here in the metrics, you can check all metrics. You have schedule task. If you want, simply go to create and run this schedule task. I will not create any task. I would just want to show you how can you set up this cluster in your Elastic Container Service. And let's go to tags. As you can see, this is our tags that we created here. And if you go here and click on create, you can create a service, and you can choose what is capacity provider strategy, what replica of the deployment do you want to choose, and all other options that is available to run a task. So you can select your task definition family and so on. I don't want to get much into this, but just wanted to show you how can you create this cluster in Amazon Elastic Service. And as you can see, there is a lot of options that you can choose. You can run a serverless Fargate, or you can simply choose EC2 instance to run this Elastic Container Service. As we already know, we can run Docker containerized images, and you can also run Amazon ECR images in your Elastic Container Service. So this was just a simple demonstration of how can we create our cluster in Elastic Container Service. And finally, I will now click on delete cluster to show you how can you delete your cluster. And once again, if you want to learn more about Elastic Container Service, simply go to official pages and you will find out more about this cluster. Let me type delete ECS1, this is the name of our cluster, and simply click on delete, and this will delete all cluster and stack definition that we created in our demonstration. If I click on CloudFormation, you can go to your CloudFormation and see all. We already know how to delete or add a stack, and you can track all these changes or status, what is current status of your infrastructure ECS, so you can see that our deletion is in progress. But before that, we can also view all these steps when we started to run and create our cluster. So we need to wait for our cluster and stack deletion. It takes time, but after this I hope you will be able to provision your own cluster and see for yourself that it's working. So as you can see, we successfully deleted our cluster, and if we now go to our CloudFormation and refresh our page, you can see that we don't have any stacks, but our infrastructure ECS cluster is deleted. Infra means infrastructure, so delete is completed. There is events, and that's it. Let me close my page. As you can see, if I refresh this page, after some time this cluster will disappear from here, but status is inactive, and you can see that we don't have any namespace, any task definition or cluster. But just like VMs, it takes time to vanish. As you can see, our cluster is after some time disappear, and that's it. Thank you for watching, and I hope that this was helpful. Amazon Elastic Container Registry, or ECR, is a fully managed container registry provided by AWS. It enables users to securely, reliably, and at scale store, manage, and deploy Docker and Open Container Initiative or OCI images and artifacts. ECR integrates with other AWS services such as Amazon EC, AKS, and Lambda, simplifying development and deployment workloads. So, what are the components of Amazon ECR? Registry. We have something called registry, and this is the first component, sorry. So every AWS account has access to the Amazon ECR registry. In the registry, we can create image repositories and store their images. Authorization token before sending and downloading images. So the next step is your Docker client must authenticate to Amazon ECR registries as an AWS user. The command line interface, or CLI, of Amazon Web Services has a command called get-login that provides the user with authentication data which is passed to Docker. And what is repository? The Docker image is located inside the Amazon ECR image repository. We have something called repository policy. The repository policy allows users to control access to their repositories and the image in it. And image, the user can very easily upload or download Docker images in their repository. The user can use the repository image on their local system, or they can use it in Amazon ECS task definition. Also, let's learn more about Elastic Container Service. So, image versioning, ECR allow you to version your container image, making it easy to manage different versions of image over time. You can tag image with specific version number to track changes. So you can say that this is a version 1, version 2, version 3. We have something called lifecycle policy. So you can define lifecycle policies that automatically delete older versions of images after a certain period of time. This helps reduce cost by automatically managing the storage of unused or outdated images. Then there is also a good security option, which is scan all vulnerability. So ECR integrates with Amazon Inspector to automatically scan all container images from known vulnerabilities. This ensures that your images are safe and compliant with the best practice before they are deployed to production. Also, integration with other AWS services is great, and you can integrate this seamlessly with, for example, Amazon ECS or Elastic Container Service, Amazon AKS, Elastic Kubernetes Service, and AWS Lambda. This integration simplifies scheduling, for example. Also, it supports cross-region replication and allowing you to replicate container image to any other AWS region. This provides faster access to your images in different geographic locations and aids in disaster recovery. And also you can create public or private repository, so ECR supports both of them. You can create a public repository to share image with the community, or a private to protect your image and manage containerized application, just like in Docker Hub or in Azure Container Registry. So, ECR or Elastic Container Registry is very easy to manage in Amazon. So, as you all know, ECR is a fully managed service, so you don't have to worry about the technical side of storing and managing your Docker images. AWS handles it all, allowing you to focus on your application. It is scalable and reliable, whether you're working on a small project or managing large applications. ECR can scale to suit your needs. It's reliable and can handle all of your container images without any hassle, ensuring that you can always access them when you need them. It works seamlessly with AWS services. As you already know, it is integrated with other EC2 services, AWS services such as containers, Kubernetes service, and Lambda. This makes deploying your containerized application extremely easy, as you can directly download your images from ECR without minimal setup. It is also safe and secure. Your photos are encrypted and stored safely. You can control your images. You can control who can access to your repository using IAM service, so only the right people and services can download or upload images. It is always durable and available, so ECR runs on a reliable AWS infrastructure, so images of your containers are always available and protected. AWS ensures that your images are secure and accessible, minimizing the risk of data loss or downtime. ECR is also designed to be easy to use, with easy integration into AWS CLI and SDK, so you can download and manage your Docker images seamlessly. In addition, the AWS Management Console makes it easy to manage your repositories. Also, it is cost effective, so with ECR you only pay for the storage and transfer of the data you use, so it's very affordable. There is no upfront cost or long-term commitments, making it great option for developers and business of all sizes. Also, it allows you to tag and version your images, so you can easily track updates and manage different versions of your app. This is especially useful when you need to revert to a previous version or keep track of changes. And the most important thing, that Elastic Container Registry has a built-in security scanning, so it automatically scans images of your containers for vulnerabilities, so you can be sure your applications are safe before deploy them. This adds an extra layer of protection and helps keep your environment safe. In global, Amazon Elastic Container Registry or ECR is an easy-to-use, fully managed service that allows you to securely store, manage, and deploy Docker container images. With features such as image versioning, lifecycle policies, and automatic vulnerability scanning, ECR makes it easy to track and protect your containerized applications. It integrates seamlessly with other AWS services such as ECS, AKS, and Lambda, helping you to deploy and manage containers efficiently. Whether you're running microservices, automating your CI/CD pipeline, or ensuring compliance, ECR is ideal choice. Its flexible pricing, including the free tier, and the ability to scale as your needs grow, make it an option for business of all sizes. So in this demo I will try to show you what is ECR, but if you go to our Docker Hub container image, you can see that hub.docker.com contains, if you don't know what is a Docker, but I hope that you now do, we have Docker images and what is our verified publisher, and if I go to Nginx, for example, this is official build of Nginx server that we use so many times in our demonstration. If you remember, we installed Docker image, Nginx image on our instance in some of this previous chapter. And here Docker Hub is just a hub where you can have all these images in one place. So if you don't know, simply go here and register, or I have my username and password. If I go and log in to Docker Hub, to my account, you can see that I have 3 repositories, and all of these repositories are my containers that I used during this time. These images was created on my local laptop, and I then upload all these repositories to my account in my Docker Hub. So as you can see, you can create your own repository. You can set up that, for example, to choose between private and public. If I remember, there is only one private repository that is allowed is in a free tier. If I go back now in our AWS console and, for example, type ECR, you can see that we have our Elastic Container Registry. So here in our Docker Container Registry, we can share and deploy container software publicly or privately. So as you can see, you only pay for the amount of data stored in our public or private repositories and data transfer to the internet. Also, there is official documentation where you can learn more about ECR, but as you can see, this is how this service works. Just like Docker Hub, Elastic Container Registry is your hub on AWS console, so you can create these repositories and import all your, for example, images from local machine or from Docker Hub, for example. And here I can make my repository. I will add, for example, my name for my repository, paste it here, as you can see, and this is our name, and it supports namespaces, but let me just fix this. Also, you can change image type mutability. So if you choose mutable images or tags, this image tag can be overwritten. And let me add just simple name. I will add some random name, and here it is. But this won't work. Here it is. There is space between our name, and finally you can choose immutable, and then here images tags can be overwritten. Also, you can choose your encryption settings, and once that your repository is created, your encryption settings cannot be changed. So you can use AS256, or simply you can use your AWS key management service. It's really up to you. And here, as you can see, you can use AWS key or customer managed key. You can create your own key. I will use this default encryption. And finally, this image scanning is deprecated, but as you can see, these settings have been moved to a registry level configuration. And finally, I can hit on create. So we have created our private repository, and now in that private repository, we can also, if we go inside that repository, as you can see, we can view our push command. If I click here, so there is a detailed explanation how can you run this on your Mac OS or Linux system. First, you will need to sure that you have the latest version of AWS CLI or Docker installed on your local computer. Then you can retrieve an authentication token and authenticate your Docker client to your registry. So you will use this command. Then you will build your Docker image using this following command. For example, our first command is docker ECR get-login-password --region, the name of your region. Then docker login --username AWS, and so on. You will add your password for your Elastic Container, and so on. Then you can build your Docker image using the following command, and here you will run docker build -t. T stands for tag, and the name of our repository. After build completes, you can tag your image, so you can push the image to this repository. Then we will run docker tag command with the name of our image and the name of our repository. And finally, we will run the following command to push our new created AWS repository. And with docker push, this is the name of our ID of our account, and after that image will be placed here. So as you can see, there is a lot of option how can you run this and push this image from your local machine, how to build your image, and how to push this image to Elastic Container Registry. Exactly, or almost exactly the same, you can do it to push your images from local machine to your Docker Hub. Also, you can create this lifecycle policy, for example. And as you can see, this lifecycle policy defines how much this image will be active in your repository. And also you can add your repository tags. So more about all of these options you can find on the official AWS documentation. And finally, you can check your application rules. You can check your scanning. So here you will add basic or enhanced scanning. This is our repositories. Here you can create your public repository. Let me try to add this other name to create my public repository. As you can see, this is my Apache and HTML application. Here I can add my namespace. You can upload your logo if you want, because this is public repository. It is available to everybody. And here you can select the operating system and system architectures that are compatible with your repository. This is my Linux. And here I can add some more information and simply click on create. And that's it. You have your public repository created in your ECR service. And then we can also view our push command and run this command, almost exactly the same option on our macOS or Linux or Windows OS. So as you can see, AWS really try hard to explain all of this. You just need to copy this address and run it on your local machine, for example, or in your Cloud Shell here. Also in the public registry we have almost the same options. And that's it. You can now also delete your repository. Simply type delete and your repository will be deleted. And exactly the same thing we can do for our private repository, because I just wanted to show you how it's easy to set up and run this service. Let me now delete this, and that's it. Thank you for watching, and I hope this was helpful.